Hey everyone, welcome to this exciting course on building real-world web applications with Vue.js 3 and TypeScript. In this course, you'll master essential web development skills, including creating interactive user interfaces, handling data, and implementing state management with Pinia. Plus, we're going to have some hands-on coding exercises to really solidify your learning. Now, don't forget to check the description for the link to our GitHub repository, where you'll find all the code and a final project waiting for you at the end, so make sure you stick around until then. All right, let's dive in and get started. Before we get started, let's ensure we have everything in place to install and run Vue.js effectively, as well as to develop applications. Today, we're diving into setting up the Vue.js development environment, which is a crucial foundation for anyone looking to harness the power of this phenomenal JavaScript framework. So, grab your computer and let's make sure you've got Node.js and NPM installed. Those are fundamental tools for any Vue developer. If you're not sure, don't worry, I'll guide you through it. All right, once Node.js is set up, you can open your terminal and just type npm install-g at vue/cli. That command will install the Vue CLI globally, giving you the power to create and manage Vue applications easily. Now, isn't that exciting? After that, you can confirm your installation by typing vu-version, and you should see the version number pop up. Now, let's create a new project. You'll want to run vue create my-project, where my-project can be whatever name you choose. Just follow the prompts and you'll be all set. This isn't just about setting things up. It's all about preparing you for an incredible coding adventure. And believe me, once you start building with Vue, you'll be hooked. So, take a moment to go through the setup, and trust me, this time you're spending now is going to pay off dividends in your development journey. Let's ensure you're comfortable with this setup process. It's going to be a blast. Now, let's see how we can verify if Node.js is installed on our system. The process is quite simple. All we need to do is run a command in the terminal or command prompt, node-v. When you execute this command, it checks the installed version of Node.js and displays it right there for you. So, if you see a version number pop up, congratulations! That means Node.js is properly installed and ready for you to dive into your Vue.js development environment. However, if the command returns an error instead, it's a signal that Node.js might not be on your system. In that case, you'll want to visit the official Node.js website to download and install the latest LTS version for your operating system. This ensures you have a stable setup that's ideal for development. By confirming the Node.js installation, we lay a critical foundation for our web application development journey with Vue.js, as it enables us to execute JavaScript on our machine rather than just in a browser, which really streamlines our development workflow. To verify if NPM is installed on your system. To verify, you can simply type the command to display the NPM version in your terminal. If everything is set up correctly and NPM is installed, you should see a version number pop up, indicating that NPM is ready to roll. If not, you might need to dive into your Node.js installation or, even reinstall it to ensure NPM is included. Next, we're going to install the Vue CLI, which is super essential for easily creating Vue.js applications. We'll use NPM to install it globally, which means it'll be available system-wide, not just within a specific project. The -g flag signifies this global installation. This tool can really help streamline the setup of new Vue projects, generating a ready-to-use project structure with best practices right in mind. Finally, we'll confirm our Vue CLI installation by checking its version. Running this command will ensure everything's functioning as it should, and that you're all set with the latest features and updates within Vue CLI. This will pave the way for your development journey ahead. The figure titled Key Components for Setting Up Vue.js Development Environment displays 5 bars corresponding to the components: Node.js at 90, npm at 85, Vue CLI at 75, Vue.js project structure at 95, and Vue router at 70, with numeric annotations right above each bar. From these values, we can draw clear priorities. Vue.js project structure is rated the highest at 95, indicating that organizing files and truly understanding the structure is the single most critical element when you're setting up a Vue project. Coming in next is Node.js at 90, which reinforces that having the correct runtime environment is absolutely essential. npm follows closely at 85, showing that having a solid package management system is almost as crucial as Node itself. Now, Vue CLI sits in the mid-range with a score of 75, highlighting that while these scaffolding tools can noticeably speed up development, they are secondary to ensuring you have a robust environment and project structure in place first. Now, Vue router, with its score of 70, has the lowest importance among these 5 components, suggesting that routing is important for application functionality, but typically it becomes a focus only after you have the core environment and project layout established. The gaps in scores, for example, the 20-point difference between the highest and lowest, really emphasize that your initial efforts should concentrate on getting Node and npm installed and then defining that strong project structure. After that, you can adopt CLI tools and routing as the complexity of your project grows. Now, let's create the foundational structure for our Vue.js project. First, we're going to make a new directory. Think of this as creating a special folder where all our project files will live. To do this, we'll use a command to make that directory, followed by another command to navigate into it. This organization is super important, you know? It helps us keep our projects nice and tidy. Next, we'll run the Vue CLI command to scaffold our project. This command is absolutely essential because it kicks off a new Vue.js application and sets up a predefined structure for you. That way, you can jump into development without stressing over how to organize your files. For our example, let's call our project Hello Vue. Now, this specific command not only creates the project, but also packs it with essential features already ready to go, like configurations for development. After we execute these commands, you'll be prompted to select between default configurations or customize your settings. I highly recommend choosing the default preset, especially if you're just starting out. It gives you a solid setup, letting you hit the ground running. This streamlined approach takes away unnecessary complexity, letting you focus more on coding and less on configuration. Now that your project is created, it's time to navigate into your newly established directory using the command cd hello Vue. This step is crucial because it sets the context within your terminal, ensuring that any subsequent commands you run will apply to the correct project. Next, let's launch our Vue application by executing the command npm run serve. This command triggers a series of processes that compile your application and make it accessible on your local machine. You'll see a message in your terminal indicating that your app is running locally, typically at the address http://localhost:8080. When you open this address in your web browser, voila, your application comes to life, showcasing the success of your setup. Now, this is not just a technical achievement, it's a celebration of your effort in establishing a Vue.js environment. So take a moment to appreciate this small victory, because you've set the stage for building dynamic web applications with Vue.js. Now, let's take a moment to dive into the Vue component that serves as the heart of our application. We begin by defining a template to lay out the structure of our app. Inside the template section, there's a div with the ID app, which houses both our header and the main content. Within the main tag, you'll find a paragraph showcasing a reactive message that's done using Vue's double curly braces syntax. And don't forget the button. When you click it, it triggers a method to update that message. Next up, we're going to explore the script section where all our JavaScript logic lives. Here, we define a data property called message, initializing it to hello Vue. Now, this property is reactive, which means any changes will automatically refresh the user interface. Pretty neat, right? Plus, we've also set up a method named updateMessage, which tweaks the message whenever that button is clicked, showcasing the fantastic reactivity of Vue.js. Now, let's not overlook the style section. This is where we apply some styling to our application, ensuring that the text is centered and color-coded for optimal readability. This structured approach not only helps us effectively manage our components' presentation, but also highlights how seamlessly Vue's reactive nature integrates with HTML and CSS. Next, we'll install Vue Router, which is a crucial library for managing navigation in our Vue.js applications. So, let's kick things off by running the command to install Vue Router. This will add the necessary dependencies that allow routing in your application. Now, let's set up the router by creating a new file named router.js in the source folder. In this file, we'll import the functions needed to create the router, along with the Vue components for our different views, specifically the Home and About components. We'll define an array of routes, where each route links a path to its corresponding component. This means our application will know exactly which view to render based on the URL a user visits. Next, we're going to instantiate the router using the createRouter function. This function takes a history mode and the routes we defined. Now, this history mode uses the HTML5 history API to enable those clean URLs without any hash fragments. Pretty neat, right? Now, let's integrate the router into our application by updating our main entry file, main.js. We'll import the router and use it within the Vue app instance. By doing this, we ensure that our application responds to the navigation events as defined in our router setup, making it a dynamic and responsive experience for our users. Now, let's dive into implementing the navigation links in our app.vue file to enhance our application's routing capabilities. The template tag, as you may know, defines the structure of our component. Within this, we have a main div that's got an ID of app, and it encapsulates all our content. So inside this div, there's a nav element. This contains two router link components. Each link is specifically configured to point to a certain route when clicked. The first one takes users to the home page, and the second directs them to the About page. This setup allows for seamless navigation between different components of our application. Now, let's not forget the clever little router view component, which we include right below those navigation links. This router view essentially acts like a placeholder that displays the routed component based on the current path. So, when users click on those links, Vue Router dynamically switches out the displayed content without requiring a page reload. This creates a really smooth user experience, and I mean, it not only enhances interactivity, but also gives our app a single-page application feel. It makes everything more user-friendly and efficient. Isn't that just great? At this point, we've not just set up a Vue environment. We've also given our application a bit of interactivity and some basic routing. This is really what Vue is all about, crafting dynamic and responsive applications that can tackle the modern web's demands. Now, before we dive deeper into all the exciting features we can explore, let's take a moment to pause and reflect on what we've achieved so far. You've got a running Vue.js application that includes routing capabilities. That's no small feat, and it's definitely worth celebrating. Lastly, I want to encourage you to explore Vue's ecosystem further. Once you're comfortable with the basics, you can integrate state management with Vuex, form handling with Vuelidate, and much more. The Vue community is so robust, and there are countless plugins and components available to, enhance your application. So let's keep this momentum going, and in our next lessons, we might dive into more complex setups, including integrations and deploying your application to production. Thank you for joining me on this journey of setting up a Vue.js development environment. Let's keep moving forward and create something amazing together. Let's put our acquired tools and knowledge to the test by creating our very first Vue.js, shall we? Today, we're diving into the exciting world of building a Vue.js app from scratch. So far, we've learned how to set up the Vue.js development environment, ensuring we have Node.js and NPM installed. We created our first Vue project and explored its structure, launching the app to see Vue in action. Additionally, we introduced Vue Router, adding navigation capabilities and dynamic routing to our application. And let's not forget, we celebrated our achievements and got ready to delve deeper into Vue's ecosystem in future lessons. Now we'll be diving into the creation of a fully fledged application with a focus on building its components, managing state, and crafting a neat user experience. Are you ready? Let's jump in. The figure illustrates a side-by-side comparison of two ratings, importance level and ease of use, for 5 core items used when building a Vue.js application: Vue CLI, Node.js, Vue Router, single file components, and Vuex. So, as we look at the bars, we see that Node.js scores the highest in importance, sitting at 90. But interestingly, it has a noticeably lower ease of use rating at 70, which suggests, that while it's considered essential, it seems a bit challenging for newcomers. Now, Vue CLI, on the other hand, shines with a very high ease of use score of 90, though it carries a slightly lower importance rating of 85. This indicates that the CLI is viewed as a fantastic productivity tool, really simplifying those day-to-day development tasks. Next up, Vuex and Vue Router register high importance scores of 88 and 80 respectively, along with good ease of use ratings of 80 and 85. This highlights them as both valuable and reasonably approachable tools for managing state and routing within an application. Now, single-file components? Well, they sit at the bottom with the lowest combined ratings, an importance of 75 and ease of 65. This shows that they come with a modest learning curve, despite their essential role in organizing component code. Overall, we can see a pattern emerging here. While tools like Vue CLI can dramatically lower friction in your workflow, foundational technologies, especially Node.js and state management with Vuex, they truly deserve some focused attention owing to their high impact on any project. So, let's prioritize learning the environment, routing, and centralized state management concepts, just as we've emphasized in our lesson. Now, let's implement the command to create our new Vue project. When you execute Vue create my first app, the Vue CLI sets up a new directory named my first app specifically for your project. It'll prompt you to choose a preset, and if you're new to Vue, I recommend going with the default option. This makes things simpler and helps streamline the setup process. After that, we'll navigate into our project folder using cd my first app. This step is crucial because it ensures that all subsequent commands are executed within the context of our newly created application. Next up, we'll take a closer look at the folder structure inside the source directory. This directory includes a components folder where you can neatly store your reusable Vue components. The app.vue file serves as the root component and is responsible for the overall structure and content of your app. Plus, main.js is your entry point. It bootstraps the application and allows all components to work together seamlessly. Understanding this structure is key. It'll help you manage your code effectively as your application grows. Now, let's run our Vue application to see it in action. To do this, we'll execute the command npm run serve in our terminal. This command kicks off the development server, which lets us view our app live. When it's successfully executed, you should see a message saying that the app is running on http://localhost 8080. Opening that link in a browser will bring up the default Vue welcome page, confirming that everything is set up correctly. This is an important milestone, as you've just set up a Vue project with a hot reloading development server, allowing for real-time updates to your code without the hassle of refreshing the page manually. So, take a moment to appreciate this foundational step in your development journey. It's where the magic begins, setting the stage for building more complex functionalities and components in your application. It's a powerful start towards creating dynamic and interactive web apps with Vue.js. Next, we will modify the app.vue component to replace the default content with a welcoming message. We'll first begin with the original template, which consists of a div containing the Hello World component. This setup allows you to display a custom message by passing props. Now, to enhance the user experience, let's transform the template. We'll include a header with a simple greeting and a brief description of our application. By integrating this change, we maintain a clear structure while conveying the essence of our app to users. Now, let's take a look at how we can implement this change, ensuring our app.vue displays a welcoming header alongside additional context. The updated template will feature a header element housing an h1 tag for the main message and a p tag for the description. This new structure not only improves readability, but also introduces semantic HTML elements, which are quite beneficial for accessibility and SEO. Once you've made these changes and saved the file, you can witness the real-time updates in your browser, a testament to Vue.js's hot reloading capabilities, allowing for a seamless development workflow. Now, let's introduce dynamic behavior to our application by adding a data property and a method. We'll begin by enhancing our script with a data function that returns an object containing welcome message, which initializes the greeting displayed in the HTML. This will allow us to manipulate the message dynamically based on user interaction. Next, let's write a method called changeMessage. This method will update the welcome message to a new string when triggered, showcasing Vue's reactivity by allowing changes in the data model to reflect instantly in the DOM. Now, let's see how we can adjust our template to utilize the welcome message. We'll replace the static heading with a dynamic binding using double curly braces, which allows Vue to automatically update the displayed message as the data changes. Additionally, we will include a button that, when clicked, activates the changeMessage method. This setup will enable users to interact with our application, providing a more engaging experience. Once you've implemented these changes, testing it in the browser will illustrate how seamlessly Vue manages reactivity and updates the view based on user actions. Now that we've got some interactivity going, let's take it up a notch by adding components to our application. First, we'll create a new file named Message Component in the Components directory. This will help us encapsulate our message functionality. So, imagine this component beginning with a template that contains a div element, right? Inside this div, we'll have a heading displaying the message and a button that allows the user to change this message when clicked. Now, to make things more dynamic, we'll define a prop called initial message to enable those dynamic values to be passed to our component. This means that our component can be reusable with different starting messages, which is super helpful. Within the data function, we set up a reactive property called message, initializing it with initial message. This little setup ensures that every time the component is rendered, it reflects the message passed in. And wait, it gets better. We also define the change method to update the message when that cozy button is clicked. This is where we really see Vue's reactivity in action. So cool, right? Oh, and we include scoped styles to give the component a distinct appearance without messing with global styles. This way, our components remain visually cohesive and simpler to manage. This modular approach not only organizes our code, but significantly enhances maintainability as our application scales. Now, let's incorporate our new message component into the app.vue file to enhance our application. First, we need to import the component at the top of the script section. By doing this, we ensure that our app.vue has access to message component, which allows us to use it within our template. Next, we will add message component to the components list in the export default object. This step is crucial because it registers message component, so Vue recognizes it when rendering the application. Now, let's proceed to update the template section. We'll swap out the existing header for our message component, passing along a prop called initial message. This prop allows us to initialize the message displayed in message component with a value of hello from the app component. By implementing this, we modularize our code effectively, enhancing both readability and maintainability. Finally, after saving our changes, we can take a look in the browser and see the message rendered from message component, along with a button that users can interact with to update the message dynamically. This really demonstrates the power of components in Vue and how they can improve user experience and code organization. Now, let's implement state management using Vuex in our application. First, we need to install Vuex by executing a command in the terminal. This step adds the package to our project. Once it's installed, we create a new folder called Store right within the source directory. Here, we'll set up a central store file, and we'll name it index.js. All right, in this file, we define the Vuex store using the createStore function. We start by initializing the store with a state object that contains a default message. This state will hold all the data, or, the information we want to manage across our application. Next up, we introduce a mutation section where we define a method called changeMessage. This method allows us to update the message stored in the state. Oh, and mutations are super essential because they ensure we change the state in a predictable way. After we've established the store, we need to export it for use in our main application file. This lets us access our centralized state from any component across our app. This structure not only streamlines data management, but also strengthens the maintainability of our application as it scales. Next, we will write the code to integrate Vuex into our application by modifying the main.js file. Here, we start by importing the necessary modules from Vue and our main app component alongside the Vuex store that we just created. So, we're going to invoke createApp, passing in the app component, and then we'll chain on.use store. This step allows Vue to utilize the Vuex store for managing state all across our application. Finally, calling .mount HPP attaches our Vue instance to the root DOM element designated by HPP, which effectively initializes our entire application with Vue and Vuex. Now that Vuex is set up, let's shift our focus to enhancing the message component to make full use of this centralized state management system. To get started, we're going to import map state and map mutations from Vuex. These tools will allow us to easily map state variables and mutation methods right to our component's computed properties and methods. By implementing these helpers in the component, we can directly access the message state within our template, which gives us a dynamic display that truly reflects the current state. Additionally, the button in our template will trigger the change message mutation, letting us modify the state right from the component. This demonstrates how Vuex effectively enables state sharing and mutation across all of our app's components. Save your changes and head back to the browser. Now, when you click the button, the message should reflect the change from Vuex. This is key because it enables a centralized data management solution for your application, making it easier to track changes across various components. By this point, we have successfully built a dynamic Vue.js application with components and state management using Vuex. We've designed our app to include interactive features and have modularized our code for scalability. This approach not only enhances the performance of your application, but also simplifies future development and maintenance. So that's pretty exciting, right? Now, let's implement some global styling to enhance the visual appeal of our Vue.js application. We'll create a styles.css file in the src folder to centralize our styles. This way, we can maintain a consistent look throughout the application. In this CSS file, we'll define styles for basic elements like the body, giving it a clean font and a soothing background color to improve readability. Next up, let's add specific styles for headings, particularly H1, to apply a vibrant color that'll really grab the user's attention. Furthermore, we'll target the .message-component class to style the individual message components we created earlier. We will set padding for comfortable spacing, a contrasting background color, and rounded borders to soften the design. This unified approach to styling not only enhances aesthetics, but also makes it easy for us to implement changes as the application evolves. Finally, we'll include the styles.css file in our main.js, which acts as the entry point of our application. This inclusion will apply our defined styles globally, making every part of the application visually cohesive. By combining these elements, we create an engaging user interface that retains usability while looking polished.
A little styling can go a long way in enhancing the user interface. It's crucial for creating an enjoyable user experience in any web application. As we wrap up, remember that building your first application is just the beginning. Now that we've covered the basics of Vue.js, like components, routing, state management, and a bit of styling, you should feel confident enough to tackle more complex applications on your own. I mean, it's really exciting to think about what you can create next.
Vue.js has such a vibrant ecosystem, and there's so much to explore. I really encourage you to dive into some of the advanced topics, like the Vue router for those complex routing scenarios. It's really a game changer. And then there's Vuex, which is fantastic for larger state management tasks, making your app more robust and organized. Oh, and don't forget about the Vue Composition API. It gives you such a flexible way to build your components, which is just awesome for scaling. Thank you for joining me in building your first Vue.js application. I can't wait to see what you create next. Let's keep that momentum going and continue exploring the possibilities with Vue.js together. Happy coding! Welcome to today's lesson, where we're going to dive deep into the world of Vue.js components and tools. Specifically, we'll focus on leveraging Vue.js Devtools to inspect and manipulate your components in real time while they run in the browser. This is a critical skill for any Vue developer. Ensuring your app behaves as expected makes debugging a whole lot easier. So far, we've learned how to create our first Vue.js application, set up the development environment, and launch the app. We've explored the project structure, modified components, introduced interactivity with Vue's data model, and created reusable components. Additionally, we implemented Vuex for state management, which enables us to manage data across components effectively. Lastly, we added styling to enhance the user experience, laying the groundwork for building more complex applications in the future. Now, we'll cover how to utilize Vue.js Devtools effectively and enhance your development process through its features. Vue.js Devtools is a powerful browser extension that not only aids developers in inspecting their Vue applications, but also lets you manipulate components on the fly. Whether you're trying to see a component state or its props, Devtools provides a user-friendly interface to visualize what's happening under the hood. To kick things off, let's make sure you have the Vue.js Devtools installed in your browser. If you're using Chrome, head over to the Chrome Web Store, search for Vue.js Devtools, and click the Install button. For Firefox users, the process is similar. Just find it on the Firefox add-ons page. The displayed figure is a grouped bar chart titled Leveraging Vue.js Components and Tools that compares two metrics, importance level and ease of use, across 5 Vue-related features: Vuex, single file components, Vue Devtools, composition API, and community support. Each feature has 2 adjacent bars with numeric labels on top, showing ratings out of 100. Now, if we take a closer look, some key patterns really jump out. Interestingly, every feature's importance rating is consistently around 5 points higher than its ease of use rating. This tells us that developers generally see these features as slightly more critical than they find them easy to use. For instance, Vue Devtools really stands out. It boasts the highest ratings for both importance at 90 and ease of use at 90. This clearly signals that it's not only viewed as essential, but is also quite accessible. Following closely is Vuex, with strong scores of 90 for importance and 85 for ease of use. This highlights the crucial role state management plays in Vue applications alongside its practical usability. Now, when we move to single-file components and the composition API, we see mid-high scores. Importance is at 80 and 80, while ease of use comes in at 80 and 75, respectively. This suggests that although these features are valued, they may require a bit more familiarity to use comfortably. On the other hand, community support sits at the lowest on both scales, 70 for importance and 65 for ease. This implies that while community resources can be helpful, they're perceived as less critical or perhaps not as straightforward to leverage compared to the core tools and APIs. So, from these values, we can really conclude that by focusing your efforts on mastering Vue Devtools and Vuex, you'll probably experience the most immediate benefits. However, it's also important to recognize this slight but consistent usability gap across features that could be addressed through improved documentation or better tooling ergonomics. Now, let's implement a new component called usercard.view, which will allow us to display user information and interact with some data. In this component, we begin by defining a template section that structures our HTML. It includes a container for the user's name and email, along with a button that toggles their active status based on a Boolean property. This interaction is achieved using a method titled toggleActive, which, when invoked, flips the user's active state. Pretty neat, right? Next, we move on to the script section. This is where the essential aspects of our logic reside. Here, we declare a prop named user, ensuring that it receives an object with user data, which is essential for the component to function correctly. The toggleActive method is defined within our component's methods, enabling us to manipulate the user's active status directly, showcasing just how dynamic and responsive components can be to user actions. Awesome stuff! Lastly, we add a scoped style section to enhance the component's appearance. This includes basic styling, providing visual separation and structure that make our user card both functional and visually appealing within the application. And there you have it, simple yet effective. Now, let's implement the user card component in your main app.vue file. First, we need to import the user card component at the top of the script section, which allows us to use it throughout this file. This is essential for making our component reusable in the application. Next, we will define our components list, ensuring that user card is available for us to use. In the data function, we will create some initial sample user data as an array of objects, where each object represents a user with properties such as name, email, and active status. This setup enables us to dynamically display user information. Then, we will include the user card component within the template section of our app.vue file. By using Vue's v-for directive, we can iterate through our users array. Each user will be passed down as a prop to the user card, identified by a unique key based on their email. This approach provides a clean and organized way to display multiple user cards in the UI. With this setup complete, we can run the application to see our user list displayed and inspect its behavior through Vue Devtools. When you click the View tab, you'll see a tree structure representing all the components in your application, the app component at the root and the user card components nested underneath it. When you select a user card component, it shows you its associated data, props, computed properties, and methods. But wait, the fun part comes when we check out the state section of Devtools. In the state section, you'll find the initial state of the user prop. You can directly edit the name, email, and even the active properties right from this panel. This is incredibly handy for testing without having to change code and refresh. Just tweak the values and see immediate changes reflected in your app. How cool is that? Next, we will set up our Vuex store to manage user data globally within our application. We'll begin by importing the Create Store function from Vuex. This is crucial for creating our store. Inside the store, we define the state function, which returns an object containing a user's array. This array is where we'll hold user objects, each with essential attributes like name, email, and active status. Now, let's take a moment to write a mutation named toggleUserActive. This handy function will let us toggle a user's active status based on their email. It works by locating a user within the user's array and flipping their active property if they're found. By encapsulating this functionality within a mutation, we can ensure that we have predictable state changes, which is something Vuex tracks beautifully. This makes debugging a whole lot easier. Once the store is created, we'll export it for use within our Vue components. This integration of Vuex simplifies state management. You see, all components can now access shared user data and interact with it consistently. With this setup, we're truly laying the groundwork to harness Vuex's power in our usercard.vue component, enabling dynamic interaction with our application state. Now, let's modify the usercard.vue component to integrate Vuex for state management and enhance our application's interactivity. First, we're going to import the Vuex helpers, map state and map mutations, which will really help us smoothly integrate the Vuex store state and mutations directly into our component. Next, we'll define a prop named user email, which is key for identifying the specific user whose active status we want to toggle. In the computed properties, we'll use map state to connect the user state from Vuex, making the user data readily accessible inside our component. Here, we also create a user computed property that searches for the user matching the email prop we passed in. Then, in the Methods section, we'll integrate the toggle user active mutation from Vuex. This lets our component trigger changes in the user's active state directly in the store. The toggle active method is where the action happens. It calls the mutation with the user's email, allowing Vuex to handle that state change seamlessly. Now, whenever the toggle button is clicked, the user's active status will be modified within the Vuex store, ensuring our application state remains consistent across all parts. When you run the application now, open the Vue Devtools and navigate to the Vuex tab. You'll see your Vuex state displayed right there. Now, what's even more interesting is when you click through the user card components, each one will display its respective user data. When you toggle the active state via the button, it commits that change to the Vuex store. And guess what? You'll see it updating in real time in the Devtools. But there's more. There's an additional feature in Devtools that's pretty exciting: time travel debugging. What this means is you can actually go back and inspect previous states of your Vuex store after certain mutations have occurred. This is a game changer when it comes to debugging complex applications. All right, so now you've got a solid understanding of how to use Vue.js Devtools to inspect and manipulate your components, along with your Vuex state. This is a crucial skill for any Vue developer, and trust me, it really streamlines the coding and debugging process. Now, besides just checking out your state and props and tweaking values on the fly, did you know Devtools can also give you some valuable performance insights? When you switch over to the Performance tab, you can analyze component re-renders and spot those pesky performance bottlenecks. This is super important, especially as your application grows, to make sure it stays responsive. Now, you might be thinking, can we also integrate testing into this workflow? And the answer is a resounding yes. While Devtools is fantastic for real-time interactions and inspections, having a robust set of unit tests on hand ensures your components behave just as you expect, even when you make changes. So let's keep that in mind as we move forward. Now, let's add testing to our user card component using Jest and Vue test utils. First, we need to install the necessary testing packages. These tools will allow us to write and run tests for our Vue components effectively. Next, we'll create a test file specifically for the usercard.vue component. Here, our main focus will be ensuring that the toggle functionality is working as it should. To do this, we'll shallow mount the user card component using a sample user object that we define. This object will include the user's name, email, and active state. Shallow mounting is key because it tests the component in isolation, making sure it behaves as expected without rendering any child components. Now, let's dive into simulating user interaction. We'll trigger a click event on the button within the user card. After that, we'll write an expectation to check if the user's active state in the Vuex store has been updated correctly to false. This automation of checks through tests is immensely helpful. It allows us to catch any potential issues during development, ensuring our application remains robust as we tweak things going forward. As we wrap up this lesson, remember that leveraging Vue.js components and tools is essential for delivering a smooth, efficient user experience. By utilizing Vue.js Devtools, you gain insights into your application's behavior, making it easier to debug and enhance usability. It's like having a magical lens that lets you peer into the inner workings of your application. Always make it a habit to keep an eye on your state and components through Devtools. Now, try to embrace the combination of real-time inspection, Vuex state management, performance checks, and automated testing to take your Vue.js skills to the next level. Thank you for joining me today, and I hope you enjoyed learning about leveraging Vue.js components and tools. Keep experimenting, stay curious, and happy coding. Vue.js is a progressive JavaScript framework that enables developers to create interactive user interfaces efficiently. And now, with Vue.js 3 on the scene, we've seen some exciting changes compared to its predecessor, along with enhancements that really make Vue applications more robust and performant. So, today, we're going to dive deep into the world of Vue.js applications, focusing on the latest features and how we can leverage them effectively in our projects. Whether you're a seasoned developer or just starting, there's something new to discover. Let's get started. So far, we've learned how to create a Vue.js application, set up components, and manage state using Vuex. We explored the utilization of Vue.js Devtools for inspecting components and monitoring state in real time, which really enhances our debugging process. We also integrated Vuex with our components to streamline state management and introduced unit testing to ensure the accuracy of our application behaviors. Finally, we emphasized the importance of combining these tools for a more efficient development experience. Now, let's dive into some exciting features of Vue.js 3, particularly its composition API, and see how we can enhance our applications using these new tools. First, you'll notice the composition API allows for a more flexible way of organizing your component logic. Instead of grouping everything by options like data and methods, we can group related reactive state and functions together. This promotes better code readability and reusability. So, to get started, let's import the ref function from Vue and create a reactive variable. Just type const count equals ref of 0. Now, every time we need to update our count, we can do it easily and reactively. Amazing, right? And while we're at it, we can define functions that operate on this state right alongside it. For example, let's create a method to increment the count. Const increment equals do count.value++. See how that flows? Keeping related logic together makes it so much easier to manage. Now, let's talk about lifecycle hooks in the composition API. Instead of using methods like mounted within the options API, we can now directly use onMounted. Just add onMounted, parentheses, open curly brace, console.log, open quote, component is mounted, close parentheses. Isn't that a neat simplification? With Vue 3, we also get enhanced TypeScript support. So, if you're into type safety, you're going to love this. It makes it easier to catch errors during development, leading to more robust applications. And remember, all these tools combined, from the composition API to TypeScript, help you build more efficient applications. So, in our next sections, we'll explore even more features and practical examples to elevate our Vue.js skills. One of the most significant changes in Vue.js 3 is the introduction of the composition API. While the Options API was the hallmark of Vue.js, the Composition API takes things up a notch, allowing developers to compose their component logic in a much more flexible manner. This flexibility means you can create cleaner and more reusable code, especially if you're working on more complex applications. So, let's dive a little deeper into this and see how it works. This pie chart titled Key Concepts in Vue.js Applications reveals 5 key components and their relative proportions. So, let's break this down. First up, we have the Composition API, which takes the largest slice at 35%. This really underscores the primary emphasis on compositional patterns and local reactive logic within Vue applications. Next, we see state management sitting at 25%. This highlights its ongoing significance for centralized data handling, especially when used alongside those compositional techniques. Moving on to performance, it occupies a substantial segment at 20%. This tells us that runtime efficiency is an essential concern for developers. Now, both TypeScript and SSR/SSG are represented as smaller segments at 10% each. They certainly hold relevance, but they're not the main focus in this distribution. So, when we look at the overall pattern, it suggests a clear prioritization. Core architecture and reactive composition, specifically the composition API combined with state management, account for a robust 60% of the focus. Performance follows as an essential secondary concern, while TypeScript and SSR/SSG provide important, albeit more specialized capabilities. From these proportions, we can draw an interesting conclusion. Focusing your time on mastering the composition API and effective state handling will yield the greatest impact on your Vue projects. And of course, don't forget to also plan for performance optimization and consider incorporating TypeScript or SSR/SSG depending on your project needs. Now, let's take a look at a simple counter component built using the composition API in Vue.js. We start by defining a template that has a heading displaying the current counter value, and there's a button that increments this value when clicked. Within the script section, we import the ref function from Vue. This is super important as it lets us create a reactive reference for our state variable, which we'll call count. All right. Inside the setup function, we initialize count to 0, which is our starting point for the counter. Next, we define an increment function that bumps up the value of count by 1 every time we click that button. This reactive pattern is essential because it makes sure that any updates to count automatically show up in the UI. Yay! No extra manual DOM manipulations required. Finally, we return both count and increment, so they're accessible within the template, which allows the user to interact with the counter seamlessly. By using the composition API, we keep our structure organized, enhancing the component's reusability and maintainability. Now, let's take a closer look at a really simple yet powerful example of a composable function that manages a counter. We're going to kick things off by importing the ref function from Vue. This is super important because ref helps us create a reactive reference for our count variable, which allows Vue to track its changes over time. Next, we'll go ahead and define the useCounter function. This is where we'll wrap our countdown logic. Inside, we'll initialize count to 0, which gives us a nice starting point for our counter. Now, we need to create two methods, increment and decrement. The increment function will boost the value of count by 1 each time it's called, while the decrement function will lower it by 1. These handy little functions help encapsulate the behavior we need to mess with the counter, sticking to the principles of the composition API by promoting reusability and keeping our code nice and clean. Finally, we'll return an object that includes count, increment, and decrement. This lets any component that imports this composable dive in and interact with the counter's state effectively. So, this approach ensures that multiple components can share the same logic while keeping their own states intact, which enhances consistency and really helps reduce code duplication throughout the application. Next, we're diving into a performance-focused example that showcases Vue.js 3's impressive reactivity using a straightforward list management system. To kick things off, we'll create a reactive reference called items. This will hold an array filled with 10,000 unique elements, which we'll generate using the array and keys methods. This method effectively simulates handling a large dataset, allowing us to witness the advantages of Vue 3's reactivity firsthand. Now, let's take a closer look at the update items function. This is the function that modifies our items array. When it runs, the function adds a new item at the end of the list, increasing the total number of items displayed. Notice how by using the ref function from Vue, we can maintain reactivity. It ensures that only the necessary parts of the DOM get updated when we append an item. This streamlined updating process really highlights the benefits of Vue 3's proxy-based reactivity system, which I must say is way faster and more memory efficient compared to its predecessor. By observing how smooth this operation is, you'll really appreciate how Vue 3 caters to complex applications with extensive data management needs, resulting in a surprisingly responsive user experience. Next, we will write a Vuex store to manage the global state for our shopping cart application. To get started, we need to import the Create Store function from Vuex. This is essential for setting up our centralized state management. Now, when we define our store object, we have several key properties: state, mutations, actions, and getters. The state property holds our application's initial state, which, in this case, is an empty shopping cart represented by an array. Moving to the mutation section, we're going to define two important functions: add to cart and remove from cart. These functions take care of updating the cart by adding or removing products based on their IDs. Using mutations is a great way to follow Vuex best practices, ensuring that our state changes are predictable. Next up, we have the actions property, which includes a function we've named addProduct. This function commits the add to cart mutation, helping us understand how we can interact with the state asynchronously. It's kinda cool, right? Finally, in the getter section, we get a nice, convenient way to access computed values from our state. For instance, we can retrieve the total number of items in the cart, which is super handy. This structure supports organized and efficient state management, allowing us to integrate it seamlessly with our Vue components. Now let's see how we can implement a cart component that interacts with our Vuex store using the Composition API. In the template section, we display the current item count in the shopping cart, making it responsive to state changes. The button provided allows users to add a product to the cart, showcasing a straightforward interaction. Okay, within the script, we first import necessary functions from Vue and Vuex, specifically computed for those reactive properties, and useStore for accessing our Vuex store. Now, the setup function is where we define our component's logic. Here, we create a store instance by calling useStore, allowing us to directly access those Vuex properties and methods. Next, we define cart count as a computed property to retrieve the number of items in the cart through the store's getter. This ensures that our component reflects real-time updates to the cart. The brief pause function is responsible for dispatching the action to add a product to that cart. And finally, we return cart count, add product, and a sample product object, making these properties seamlessly available for our template to use.
Now, let's implement a simple TypeScript-based Vue component to understand how we can leverage TypeScript's features. In this example, we'll define a basic template that renders a heading displaying a message. By utilizing script langTS, we declare that we're writing our script in TypeScript, which not only enables us to integrate type checking, but also makes our components so much more robust. So, the define component function from Vue is imported to help us outline our component. Inside the component's data method, we return an object containing a single data property, message, initialized with the string hello Vue with TypeScript. This sets the foundation for our component's reactivity, allowing the message to be displayed on the screen. Now, when we leverage TypeScript, we enhance our application with better tooling support, making refactoring and maintaining our code a breeze. Plus, it encourages the use of interfaces and type definitions, which leads to fewer bugs and a clearer understanding of our data structures. In summary, this example illustrates how to create a fundamental Vue component while taking advantage of TypeScript for improved code safety and maintainability. Now, let's implement a basic setup for a Nuxt.js application, which plays a crucial role in enabling server-side rendering. First, we initiate the project using npx create nuxt app my app, and this step sets up all the necessary files and configurations for our application. During this installation, you'll be prompted to choose features like TypeScript, Axios, and Vuex, which allows you to customize your setup according to your preferences. Next, we'll create a simple page under the Pages directory. This is a vital aspect of Nuxt.js because these pages will correspond to routes in your application. We'll define a template that includes an h1 element to welcome users to our Nuxt app. Here, we also utilize the async data method, which is a powerful feature in Nuxt.js. By placing our data fetching logic within async data, we ensure that our data is retrieved on the server side before rendering the page. This means users will experience faster load times and improved SEO performance since the fetch data is available right when the page is first served. Overall, this approach really simplifies the process of creating an optimized application using Nuxt.js. As we wrap up, it's really important to emphasize the evolution that Vue.js has undergone to serve modern development needs. Like, wow! The composition API, improved performance, enhanced TypeScript support, and SSR capabilities, all of these play a vital role in building sophisticated applications. Vue 3 equips us with tools that not only simplify component development, but also enhance maintainability and resource efficiency. By understanding these essential features and applying the concepts we've discussed, you'll be better equipped to create powerful, responsive, and user-friendly Vue.js applications. The development landscape is ever-changing, and with tools like Vue, adapting to these changes is, with excitement, seamless and truly exciting. Now, in the next session, we'll cover specific patterns for building modular components and explore transitions and animations to enhance user experience in our applications. Thanks for joining me today, and happy coding!
The Composition API in Vue.js is a powerful new feature that allows developers to write more modular and maintainable code. It promotes better organization and reuse of component logic, making complex applications easier to manage. So far, we learned how Vue.js 3 introduces the Composition API, enabling better organization and reusability of component logic. We explored the integration of Vuex with this new API for more streamlined state management in applications. Additionally, we highlighted the enhanced performance capabilities of Vue 3 and its compatibility with TypeScript, improving code robustness. Lastly, we discussed the benefits of server-side rendering and static site generation in optimizing Vue.js applications using frameworks like Nuxt.js. Now, let's delve deeper into implementing the Composition API and how it can revolutionize your Vue development experience. As a visual summary of these points, the accompanying bar chart titled Performance Metrics of Vue.js Features displays 5 features on the x-axis: component reusability, TypeScript integration, state management, SSR optimization, and streamline logic, with corresponding performance percentages of 30%, 25%, 20%, 15%, and 10% shown above each bar. The chart clearly orders these features from highest to lowest contribution, highlighting component reusability as the primary contributor, 30%, and TypeScript integration as the second most significant, 25%. State management appears as a solid middle contributor at 20%, while SSR optimization, 15%, and streamline logic, 10%, are smaller but still measurable contributors. From these proportions, we can conclude that modularity and type safety are emphasized as the leading drivers for perceived performance or priority in Vue.js implementations, with state management playing an important supporting role and SSR streamlined logic offering additional though lesser benefits. The plotted values and axis labels, features, and performance percent allow direct numerical comparison, making it straightforward to prioritize efforts when optimizing Vue applications. Now let's take a look at how we can implement a user profile component using the traditional Vue Options API. In this code, we begin with a simple template that displays the user's name and email, along with a button to update the email. Within the script section, we define a data function that returns an object containing the user's information. This organization encapsulates the state of the component. Methods are defined in the Methods section, where we create an update email function. This method prompts the user to enter a new email address, updating the email field in the user object when a new value is provided. While this approach effectively illustrates basic Vue capabilities, it can become cumbersome as the application scales due to the separation of data, methods, and computed properties. Next, we will explore how to refactor this component using the Composition API, which will allow for a more organized and modular structure that enhances reusability and readability. By doing so, we can streamline our code, and make it significantly easier to manage as our application grows. Now let's see how we can implement the composition API in our Vue component to better manage state and methods. In this example, we import the ref function from Vue, which allows us to create reactive references. Within the setup function, we define a reactive user object that contains the user's name and email. By using ref, any changes to this data will automatically update the template, keeping the UI in sync with the underlying state. Next, we create a method called updateEmail, which prompts the user to input a new email address. Upon submission, the function updates the email field of the user object using userValueEmail, showcasing the reactivity provided by Vue's composition API. This organization of state and functionality within the setup function not only enhances the readability and maintainability of the code, but also makes it easier to troubleshoot. By returning the user object in the updateEmail function, we ensure that they are accessible in the template, thereby streamlining our approach to building interactive components in Vue. Now let's implement a composable function, useUser, which encapsulates user-related logic for enhanced reusability across components. This function starts by importing the ref method from Vue, which allows us to create a reactive reference to the user object holding the user's name and email. Within useUser, we define the user variable as a reactive reference initialized with a default user profile. Next, we create an updateEmail function that prompts the user to enter a new email address. This function updates the userValueEmail property with the new email entered by the user. Once we have these two features, user and updateEmail, we return them from the useUser function. This separation allows any component that imports the useUser composable to easily access and manipulate user information without duplicating code. Now let's see how we can incorporate this composable into a component. By importing useUser, we can call it within the setup function, allowing the component to directly utilize the reactive user state in the updateEmail method, streamlining our code and improving organization. This demonstrates the true power of the composition API, promoting cleaner and more modular coding practices. Next, we will implement the user profile component using the composition API to fetch user data upon component mounting. We begin by defining our template, which displays the user's name and email, along with a button to update the email. In the script section, we import necessary functions from Vue, specifically ref for creating reactive state and onMounted for lifecycle management. Now let's take a look at the setup function. Inside, we create a reactive reference for the user object, initializing it with empty name and email fields. This reactivity allows Vue to track the changes and update the DOM efficiently. We then define an updateEmail function that prompts the user to enter a new email, directly modifying userValueEmail. Next, we implement the onMounted lifecycle hook. This is where we fetch user data asynchronously from an API once the component is mounted. The response is parsed into JSON format and assigned to the user value, which automatically updates the displayed user information in the template. This approach keeps our logic organized and encapsulated within the setup function, demonstrating how effectively the composition API enhances component lifecycle management and maintainability. Now let's implement the following example using the composition API, showcasing how to leverage computed properties for our user profile component. In this code, we have a template displaying the user's full name and email, with a button to update the email. Inside the script, we first import the necessary functions from Vue, specifically ref and computed. We initialize a reactive state for the user object, which holds the first name, last name, and email address. This allows us to track changes to these properties automatically. Instead of manually concatenating the first and last names whenever they change, we define the computed property, full name, which dynamically combines these two reactive properties. Every time first name or last name updates, the full name computed property recalculates, ensuring the display is always current without additional logic. The updateEmail method prompts the user to change their email, demonstrating how easily we can modify our reactive state. This structure not only keeps our code organized, but also highlights the efficiency and clarity offered by the composition API in managing state and reactive properties. Now let's implement the following code using TypeScript along with Vue's composition API for enhanced type safety and clarity. In our template, we display the user's full name and email address with a button that triggers the email update functionality. We start by defining a user interface that outlines the structure of our user object, ensuring that properties like first name, last name, and email have the correct types. Next, we utilize the ref function from Vue to create a reactive user object, initializing it with sample data. This ability to maintain reactive state is a core feature of the Composition API, allowing automatic updates in the DOM whenever the underlying state changes. The updateEmail method allows us to prompt the user to enter a new email address, which updates the reactive state accordingly. Lastly, we create a computed property called fullName, which dynamically generates the user's full name based on their first and last names. This method encapsulates the logic for constructing the full name, ensuring that it is always accurate, demonstrating the power of reactivity and computed properties in Vue 3. As we wrap up this segment on the Composition API, it's crucial to remember that its primary goal is to improve the way we manage component logic in our Vue applications. By allowing better organization, modularity, and reusability, we can craft more maintainable and scalable applications. The ideas of composables and combining state with lifecycle hooks can lead to a significant reduction in duplication and complexity in your components. Next, we will explore how this flexibility ties into managing state with Vuex and how we can create reactive and efficient data workflows within our applications. We'll bring together everything we've learned about structured logic and powerful Vuex state management to build dynamic, state-driven applications. Thanks for sticking with me through this discussion, and let's keep the momentum going in mastering Vue 3. Welcome back, everyone. Today, we're diving into an incredibly useful tool for any Vue.js developer, the Vue.js Devtools. This handy browser extension allows you to inspect and manipulate Vue.js components while they are running in your browser. It's essential for debugging and optimizing your applications, and it can help you understand what's happening under the hood. So far, we learned that Vue.js 3's Composition API enhances code organization, reusability, and type safety, making it easier to manage complex applications. We discussed component lifecycle management and demonstrated how to fetch data and manage user interactions using the API. Additionally, we explored the creation of computed properties and the advantages of integrating TypeScript for better type inference. Lastly, we highlighted the significance of composables in reducing code duplication and complexity while setting the stage for effective state management with Vuex. Now, we will cover how to effectively use Vue.js Devtools for debugging our applications. First things first, let's talk about how to get started with Vue.js Devtools. If you haven't installed it yet, don't worry, it's a breeze. Just head over to your browser's extension store. You can find it in both Chrome and Firefox. Simply search for Vue.js Devtools and you'll be able to install it in just a few clicks. Once it's installed, reload your Vue application and you should see a new tab in the developer tools labeled Vue. Now let's dive into the basic functionalities of the Vue.js Devtools. When you open the Vue tab, you are greeted with a tree-like structure representing your Vue component hierarchy. Each node corresponds to a Vue component in your application. This hierarchy allows you to visualize the structure of your app, making it easier to pinpoint which component you need to inspect or debug. For instance, if you have a simple Vue application with a few components like app, header, main, and footer, you'll be able to see these listed in the sidebar of the Vue Devtools. Clicking on any of these components will allow you to view their data, computed properties, methods, and the events they emit. This feature is particularly useful when trying to debug issues or when you need to track the state of your components as they change over time. Now let's take a look at how we implement a simple component that utilizes reactive properties in Vue.js. In this example, we define a template that features an input field and a paragraph element. The input field is bound to the username reactive property using vModel, allowing two-way data binding. This means any text entered into the input will be directly reflected in the bound property. Immediately below the input, we see a paragraph that greets the user by displaying the value of username. Next, we define the script section where we set up the component using the Composition API. We import the ref function from Vue to create a reactive reference. Inside the setup function, we declare username and initialize it as an empty string. This reactive reference will automatically update the UI whenever its value changes. By returning username from the setup function, we ensure that this property is accessible within the template. This simple structure not only demonstrates reactive data binding, but also encourages modular code organization within Vue.js applications. The figure titled Overview of Key Vue.js Concepts displays a grouped bar chart comparing two metrics for 5 concepts: composition API, Vuex, Vue router, Devtools, and performance optimizations. For each concept, the chart shows an importance %bar and a usage %bar with numeric labels above each bar. Composition API registers the highest perceived importance at 40%, while its usage is shown at 30%, indicating it is considered very important but is used somewhat less. Vuex displays importance of 25% with a higher usage of 35%, meaning actual usage exceeds its stated importance. Vue router appears balanced with both importance and usage at 20% each. Devtools also shows parity with 10% importance and 10% usage. Performance optimizations are lowest on both scales with 5% importance and 5% usage. From these values we can conclude key patterns. The composition API is the top priority concept, but there is a gap between its importance and adoption. Vuex is adopted more widely than its perceived importance, suggesting frequent practical reliance, and routing, dev tools, and performance tasks are consistently rated and used at lower levels. These patterns suggest focusing learning and tooling efforts on increasing practical use of the composition API, maintaining disciplined state management with Vuex, and elevating attention to performance where it is currently underestimated. Now let's take a look at how to create computed properties in a Vue.js component. We start with a simple template that displays a full name property. This property will be computed by concatenating two reactive data values, first name and last name. To accomplish this, we use Vue's ref function to define these reactive variables and the computed function to derive the full name property based on them. In the setup function, we declare first name and last name using ref, initializing them with the values John and Doe, respectively. The computed function then takes a callback that returns a string combining both names. This callback will automatically reevaluate whenever either first name or last name changes, ensuring that full name always reflects the current state of these variables. By including full name in our return statement, we make it accessible in the template, where it will be displayed dynamically. So as we change the values of first name or last name, the displayed full name will update in real time, illustrating the power of Vue's reactivity system and computed properties. Next, we will write the following component, which demonstrates how to emit events in Vue.js. In this template, we have a button labeled Greet Me, which when clicked will trigger a method called emitGreeting. This method is defined within the script section of the component and utilizes Vue's event system to emit a custom event named Greet, along with a message specifically, Hello from Vue.js. By using the emit method, we are allowing the component to communicate important actions to its parent or to any other listeners that may be monitoring this event. This feature is crucial for building interactive applications, as it facilitates a clean way of handling events and passing data. After defining this component, you can see the emitted events in Vue.js Devtools, where it's possible to verify that the greet event was dispatched successfully and check the accompanying data. This not only enhances debugging capabilities, but also ensures that user interactions are accurately processed, ultimately contributing to a smoother user experience. Now let's take a look at how we can implement a basic Vuex store to manage our application state. This store will help us handle a simple counter feature where we can increment and decrement a value. We begin by importing the createStore function from Vuex, which is essential for creating our store. Inside the createStore function, we define an object that represents our Vuex store. This object contains a state property where we initialize our state with a count variable set to 0. State in Vuex is reactive, meaning any changes to it will be automatically reflected in the UI. Next, we add a mutations property that contains methods for updating the state. Here we define two mutations, increment, which increases the count by 1, and decrement, which decreases it by 1. Mutations are the only way to change the state in Vuex, and they must be synchronous to ensure predictability in state changes. Finally, we export the store, making it available for use in our Vue application. This store structure provides a centralized way to manage the state, ensuring that components can access and modify it consistently, especially when using Vue.js Devtools for debugging and tracking state changes. Let's also talk about performance monitoring, an essential part of debugging as well. The Vue Devtools can help you analyze component performance by allowing you to see how many times a component re-renders. This is crucial when trying to optimize your application and ensure it runs smoothly without unnecessary updates. Consider a situation where your app has an overabundance of components that render more times than necessary. If you've structured your components using the composition API well, you'll find that the reactivity system optimizes many updates for you. The Devtools can help you determine whether there are any bottlenecks in your rendering process. To test this, you might have a scenario set up where you're frequently updating the state. After you inspect in the Vue Devtools, you'll be able to see the components rendered in real time. You'll notice a count of how many times the components have rendered. If a component is rendering too often, you may look into strategies like memoization or using Vue's asynchronous components to improve performance. In conclusion, Vue.js Devtools is an indispensable part of your Vue.js development toolkit. It allows you to inspect and manipulate your components in real time, making debugging and performance monitoring incredibly straightforward. You can easily check the state, see your component hierarchy, monitor events, and dive into Vuex to track state changes and actions. Remember, an essential part of becoming a proficient developer is harnessing the right tools for the job. Using Vue.js Devtools effectively can tremendously streamline your debugging process and help you build more efficient applications. Now that we've explored the capabilities of the Vue Devtools, you should be well informed on how to utilize it to debug your Vue applications. So the next time you run into a perplexing issue, don't forget this toolkit. It might just help you find those pesky bugs quickly. Happy coding. Welcome to our lesson on integrating advanced Vue.js features. Today, we're diving deep into some critical Vue.js concepts, particularly focusing on reactivity and how to effectively inspect your application using official tools. So far, we learned that Vue.js Devtools is a crucial browser extension for debugging and optimizing Vue.js applications. It allows developers to inspect the component hierarchy, view reactive data properties, modify values in real time, and track emitted events. Additionally, it integrates with Vuex for state management, providing features like time travel debugging and performance monitoring to help optimize application efficiency. Overall, mastering Vue.js Devtools streamlines the debugging process and enhances application development. Now we will cover reactivity more in depth and explore how each component can enhance interaction in your Vue.js applications. Now let's see how we can implement a basic Vue instance to demonstrate the reactivity system. The code begins by creating a Vue application via Vue create app, where we define a data function that returns an object housing our reactive properties. In this case, we set up a single property called message, initialized to hello Vue.js. This property will serve as the foundation of our reactive data, allowing it to interact with the UI seamlessly. Next, we mount this Vue application to a DOM element with the ID app using app-mount #app, effectively linking our JavaScript functionality to the specified HTML. Within the HTML structure, we have a paragraph element that utilizes the double curly braces syntax, message, to display the current state of the message property. Additionally, we incorporate a button that listens for click events. When clicked, it updates the message property directly, showcasing Vue's reactivity. This leads to an automatic update in the displayed message, illustrating how Vue handles real-time changes efficiently. Next, we'll implement a simple example to illustrate Vue's reactivity system with a user object. In this code, we create a Vue application that contains a data function returning an object with user-related properties, name and age. The name holds a string, while age is an integer initialized to 30. This setup allows Vue to track these properties, meaning that any changes made to them will automatically reflect in the user interface. Now let's take a look at how we can dynamically display this data in our HTML. We set up a structure where we can show the user's name and age, utilizing Vue's template syntax to bind these properties to our HTML. To enhance user interaction, we also include a button that increments the user's age whenever it is clicked. This demonstrates the power of Vue's reactivity. As the button is pressed, the age increases seamlessly, and the UI updates without needing any manual DOM manipulation. This built-in reactivity simplifies state management and makes it clear how Vue tracks and responds to changes in the application's data. Now let's take a look at how Vue allows us to work with reactive arrays. To manage a list of items, we first set up a Vue application instance where we define a data property called items. This property initializes our array with 3 fruits, apple, banana, and cherry. Next, in the HTML, we create an unordered list where Vue will dynamically render each item in the items array. This is accomplished using the v-for directive, which iterates over the array. Additionally, we use the key binding to ensure Vue can efficiently track each item for updates. To enable adding new items to our list, a button is included that responds to a click event. When clicked, this event triggers a method that pushes a new item, date, into the items array. The beauty of Vue's reactivity comes into play here. When we add this new item, Vue automatically re-renders the list to reflect the updated state without requiring any manual DOM manipulation. This exemplifies Vue's efficiency in handling array updates, making it simple and intuitive to work with lists of data. Next, we will see how to ensure reactivity when updating specific properties of an object within Vue's reactivity system. In scenarios where you directly modify an object's property, such as assigning a new name to the user object using username, Vue may not detect this change, and as a result, the UI will not update accordingly. To overcome this limitation and ensure the property is reactive, we can use the Vue set method. In our example, we're using Vue set app user name Jane Doe to explicitly tell Vue to observe changes to the name property of the user object. This method acts as a notification system, ensuring that Vue monitors this property for future modifications and, in turn, keeps the user interface in sync with any updates. It's important to note that while Vue 3 has greatly improved its reactivity system, understanding these nuances can help you avoid common pitfalls when working with state management in your applications. Being proactive in applying Vue set can make a significant difference in maintaining a seamless user experience. Now let's implement a Vue.js application that uses local storage to remember a user's favorite color. First, we define the application with a data property called favoriteColor, which is initialized as an empty string. This property will hold the user's input. Next, in the created lifecycle hook, we attempt to retrieve any previously stored color from local storage. If a color exists, we assign it to favoriteColor, ensuring that the user's preference persists even after a page reload. Moving forward, we define a method called setColor, which takes a color as an argument. When invoked, this method updates the favoriteColor data property with the provided color and simultaneously saves it to local storage. This two-way interaction not only updates what the user sees on the screen, but also stores their preference for future visits. In the HTML, we set up a simple user interface that consists of an input box bound to favoriteColor using Vue's vModel, allowing real-time data binding. The button triggers the setColor method to save the user's entry, while a paragraph element dynamically displays the selected favorite color. This illustrates how Vue's reactivity can enhance user experience by saving states between sessions elegantly. Now let's take a look at how Vue.js allows us to manage product details with reactivity. By creating a simple Vue application, we define a data function that returns an object containing a product, which includes properties like name, price, and available. This data structure will be leveraged in our HTML template to create a dynamic user interface. Next, we implement a conditional template structure that responds to changes in the available property of the product. In the template, we display the product's name and conditionally render either the price or an out-of-stock message based on the availability of the product. This demonstrates Vue's reactivity system in action. When the available property is toggled, the displayed content updates automatically without requiring manual DOM changes or re-renders, showcasing Vue's efficient handling of data updates. By encapsulating data in a reactive object, we can seamlessly interact with the user and reflect changes in real time, enhancing the overall user experience. This is an excellent example of Vue's powerful capabilities in building responsive and interactive applications. The displayed donut chart titled Key Concepts in Vue.js Reactivity breaks down 5 core areas and their relative emphasis: reactive data 35%, components 25%, Devtools 20%, performance 10%, and state management 10%. From these proportions, we can draw several conclusions relevant to our lesson. First, reactive data occupying the largest slice, 35%, indicates that understanding how Vue tracks and updates data is the primary foundation. It directly drives UI updates and should be the main focus when learning reactivity. Second, components at 25% reflect their role as the structural units that encapsulate reactive state and render logic. Mastering component boundaries and props emit patterns is the next priority because components determine where and how reactive data is used and isolated. Third, Devtools at 20% highlights the practical importance of inspection and debugging. Once reactive data and components are in place, Devtools becomes essential for observing state changes, emitted events, and diagnosing issues in real time. Finally, performance and state management are shown as smaller but equal slices, 10% each, suggesting that while optimization and centralized stores, Vuex/Pinia or similar, are important, they typically become focal points after you have a solid grasp of reactive data and component design. The pattern of a dominant reactive data slice, substantial component and tooling support, and smaller optimization state slices recommends a learning and development sequence. Prioritize core reactivity concepts, structure your app into clean components, use Devtools to iterate and debug, and then address performance tuning and global state architecture as needs arise. Now let's implement a simple Vue component that captures user input from a form. First, we create a Vue application by using Vue create app, defining a data function that returns an object containing a single property, user input, initialized as an empty string. This serves as the reactive data property in our application, where any changes to its value will automatically update the UI. Next, we mount our Vue instance to the DOM element with the ID of app. This means our Vue app will control and manage any content within this HTML element. Now let's take a look at the corresponding HTML structure. Here, we create an input field bound to our user input property using the vModel directive, allowing the input to synchronize its value with the data property in real time. This means that as a user types in the field, user input is updated immediately. Additionally, we display the current value of user input in a paragraph below the input field using double curly braces. This reactive binding illustrates how Vue seamlessly integrates user interaction with the displayed data, enabling dynamic updates without requiring manual DOM manipulation. Furthermore, the performance monitoring tools provided by Devtools allow you to trace how much time components take to render and track performance bottlenecks in your application. This lets you optimize your components by identifying slow rendering that could impact user experience. For example, if you notice a specific component taking a long time to render, you can delve into that component's data and methods through the Devtools. This not only saves time, but ensures your application runs smoothly, providing an optimal user experience. In closing, integrating advanced Vue.js features into your applications, including understanding reactivity and leveraging tools for inspection and debugging, can significantly enhance your development process. Reactivity allows you to build dynamic, interactive applications with ease, while Vue.js Devtools provides the insight needed to refine and optimize those applications further. Today, we explored the powerful reactivity features that Vue.js offers and learned how to manage data in a way that strengthens user interaction with your applications. We also examined tools like Vue.js Devtools, which give you an in-depth understanding of your application's state and performance. Armed with this knowledge, you should feel confident developing Vue.js applications that are not only functional but also efficient and enjoyable to use. So let's keep experimenting with these concepts and get ready to build amazing things with Vue.js. Now let's take a look at how we can implement a simple interactive form component in Vue.js. We begin by defining our template, which consists of a header, an input field for user input, and an unordered list that displays the entered activities. The input field is linked to a reactive variable called activity using the vModel directive, allowing for two-way data binding. This means that any updates to the input are automatically reflected in the activity variable. Next, we utilize the @keyUp enter event listener to trigger the addActivity method when the user presses the enter key. This method checks if the activity variable has a value. If so, it adds this value to the activities array and clears the input field. The list displays all activities using v-for, dynamically creating a list item for each entry in the activities array. This component structure not only handles user input but also showcases Vue's reactivity system, ensuring that changes in state lead to immediate UI updates. Such an approach allows for a seamless and interactive user experience. Now let's see how we can enhance our Vue component by adding a feature that allows users to remove activities from the list. In this updated code, we introduce a remove button adjacent to each activity displayed in the list, facilitating this interactivity. Within the template, for each activity rendered with the v-for directive, we include a button bound to the remove activity method, passing the index of the activity to accurately identify which item to remove. Next, we define the remove activity method in the script section. This method utilizes the splice function to remove the selected activity from the activities array, which is crucial for maintaining the integrity of our list when items are deleted. To reinforce user control, we structure the button to trigger this removal function when clicked. This approach not only streamlines the user experience, but also empowers users by providing them with a direct way to manage their list of favorite activities. By enabling the removal of activities, we effectively create a more dynamic and user-friendly application that encourages interaction and personal customization. Now let's implement some styling to enhance the user experience of our interactive component. We begin by defining styles for our main container with a clean font and some margin for spacing. The heading is styled with a dark color to ensure it's visually distinct. For the input field, we apply padding and borders to create a modern look while making it user-friendly. The box sizing property is used so that the width calculation accounts for padding, ensuring that the input field fits well within the layout. Next, we focus on the list of activities. We remove default styles by setting list style type to none and add padding for a cleaner appearance. Each list item is given a light background color and padding, with a left border to distinguish it from other items, enhancing readability. The button designed for removing activities stands out with a vibrant red color, making it easily identifiable. To provide interactive feedback, a hover effect is added to change the button's background color, helping users understand their actions. This combination of styles creates an engaging and friendly interface that encourages interaction. The figure displays a vertical bar chart titled Key Concepts in Building Interactive Vue.js Applications that ranks 5 concepts by importance using percentages on the y-axis 0–40%. From highest to lowest, the concepts are reactivity 30%, two-way data binding 25%, user interface 20%, component structure 15%, and optimization 10%. Key patterns include a clear emphasis on reactive state management. Reactivity alone represents nearly 1/3 of the total importance and is the single largest contributor. Two-way data binding is the second most important, only 5 percentage points behind reactivity, indicating that bidirectional synchronization between model and view is nearly as crucial. The top 3 concepts, reactivity, two-way data binding, and user interface, together account for 75% of the importance shown, which implies that building responsive, data-driven interfaces and delivering a good UI should take priority in design and implementation. Component structure and optimization are smaller but still meaningful slices. Component structure at 15% signals the value of modular reusable components, which aligns with splitting the activity list into an activity list component, while optimization at 10% underscores that performance considerations, though less emphasized, remain part of the overall strategy. The relative gaps between bars suggest a practical roadmap. Invest first in robust reactivity and binding patterns, then polish the UI and component architecture, and finally apply optimization techniques as needed. Now let's see how we can implement a feedback mechanism to enhance user interaction when adding or removing activities in our Vue component. First, we introduce a new reactive variable called message, which will store the feedback text that confirms the user's action. In the addActivity method, when a user adds an activity, message is updated with a string indicating that the activity was added. Similarly, the removeActivity method sets the message to show which activity has been removed. To ensure that this feedback is displayed effectively, we conditionally render a paragraph element in the template that shows the message only if it contains text. Additionally, we use Vue's watch function to monitor changes to the message. When a new message appears, we trigger a timeout that automatically resets the message back to an empty string after 2 seconds. This approach provides users with timely notifications without being intrusive, enhancing their overall experience as they interact with the activity list. This implementation reflects how we can effectively utilize Vue's reactivity and lifecycle features to create a user-friendly interface that communicates important actions clearly. Now let's implement a new component called ActivityListView, which encapsulates the logic for displaying a list of activities. This component is structured using the Vue template syntax, which begins with a template block where we define the layout. Here, we create an unordered list that iterates over the activities prop passed to it using the v-for directive. Each activity is rendered as a list item, including a button that triggers the removeActivity method when clicked, allowing users to remove that specific activity. In addition to the template, the component includes a script block using TypeScript, where we import the defineComponent function from Vue. This function helps define our component's properties. Specifically, we declare activities as an array and removeActivity as a function, both marked as required props. This decouples the list logic from the main component, facilitating better organization of our code and enhancing reusability. By implementing this structured approach, we ensure that our main component remains focused on its core functionality while utilizing ActivityList effectively. Now let's implement the testing for our ActivityListView component using Vue TestUtils and Jest. This testing suite begins with importing the necessary functions from the testing library and the component itself. We will define our suite, where the first test checks that the correct number of activity items is rendered when passed as props. Here we create an array of activities and mount the component with these props, confirming the rendered list contains the expected number of items by checking the length of the list. Next, we verify that the first list item correctly displays the expected activity text. In the second test, we want to ensure the component's interaction works as intended by checking if the removeActivity method is invoked when the corresponding button is clicked. We set up a single activity and a mock function for removeActivity, then trigger a click event on the button. Finally, we expect this mock function to have been called, confirming that the component correctly handled the button click. This automated testing is crucial, as it helps catch issues early in development and ensures our component behaves as expected throughout the application lifecycle. As we wrap up, remember that the key to mastering Vue.js is practice. Experiment with different interactive features, customize your components, and always seek ways to enhance user interaction. Engaging users through dynamic interfaces is a crucial aspect of modern web development, and with Vue.js the possibilities are endless. So go ahead, get creative, and enjoy the journey of building your Vue.js applications. In today's lesson, we dive deep into utilizing Vue.js for comprehensive applications, taking our understanding of this powerful framework to the next level. As we explored previously, building interactive Vue.js components involves reactivity, two-way data binding, and component composition, which helps us create responsive user interfaces. Now we will discuss how to scale these principles and implement them effectively in a larger application context. First, let's set the stage right. If you're working on a Vue.js project and everything is set up correctly, starting your development server is as simple as running the command npm run dev in your terminal. This command spins up a local server and allows you to access your application in your browser, typically at http://localhost 8080. This environment provides live reloading, enabling you to see changes in real time without refreshing your browser. This is especially useful as you build a more comprehensive application. Now let's take a look at how we can structure our Vue.js application effectively. We begin with the project directory, where the src folder contains the essential components of our app. Inside the components directory, we have TaskForm Vue and TaskList Vue, which are reusable components crucial for our task management functionality. The Views directory holds Home Vue and About Vue, which represent the different pages in our application. Next, we will implement the TaskForm component, which will allow users to input new tasks. It features a text input bound to a reactive variable with vModel, and listeners for both the enter key and a button click to submit the task. By emitting an event with the task description upon submission, the component facilitates communication with its parent component while maintaining a clean separation of concerns. Subsequently, in the task list component, we will display the list of tasks dynamically. Each task is rendered within a list, along with a button for deletion. This component receives tasks as props and emits a deletion event, promoting intercomponent communication. Finally, we'll integrate both components into Home View, where we maintain the array of tasks and manage state updates based on user interactions. The displayed bar chart titled Key Concepts in Utilizing Vue.js for Comprehensive Applications presents 5 concepts with their relative importance as percentages. Component structure 30%, reactivity 25%, state management 20%, APIs usage 15%, and user experience 10%. The pattern is a clear descending order from left to right, indicating that component organization and modular structure are assigned the highest priority, closely followed by reactivity. State management sits in the middle, representing a substantial but secondary focus, while API usage and user experience receive smaller shares. Quantitatively, component structure exceeds reactivity by 5 percentage points and is 20 points higher than user experience, highlighting that structural design decisions should consume a larger portion of planning and implementation effort when scaling applications. From this distribution, we can conclude that emphasis should first be placed on designing a solid component architecture and ensuring reactive data flows, then on implementing centralized state solutions, with API integration and UX refinements following as important but lower priority concerns in the development timeline. Now let's take a look at how to create the task form Vue component, which plays a crucial role in our task management application by allowing users to add new tasks. The template section defines the structure, featuring an input field for the task description and a button to submit the task. The vModel directive ensures two-way data binding, so as users type in the input field, the value of the task variable is automatically updated. This enables a reactive experience, meaning the UI will reflect any changes immediately. Next, we implement the submit task method, which is triggered either by pressing the enter key or clicking the button. When the user submits a task, the function checks if the input is not empty, then emits an event called add task to the parent component, passing the task description along. This event-based communication is essential in Vue.js as it allows the parent component to respond by updating its state. Finally, after emitting the event, the input field is cleared. This enhancement improves user experience, as users can effortlessly add multiple tasks without needing to clear the input manually each time. This setup exemplifies good practices in Vue.js component design. Next, we will write the task list component, which is crucial for displaying a list of tasks and providing functionality for deleting them. This component uses Vue's template syntax to iterate over the task's prop with a v-for directive, allowing each task to be rendered as a list item. The template also includes a delete button, which when clicked triggers the remove task method. Now let's implement the script section, where we define the component using TypeScript with defineComponent. We specify the task's prop in the component's props option, indicating that it must be an array and is required. Within the setup function, we declare the remove task method, which takes the index of the task to be deleted. This method emits a custom event named delete task, passing the index to the parent component. This event-driven architecture not only encourages modular coding practices, but also keeps our components decoupled, enabling easier maintenance and testing. By correctly using props and emitting events, we create a clean and efficient bridge between our components, facilitating communication while adhering to Vue's design patterns. Now let's see how we can integrate our task form and task list components into the Home Vue parent component, where we will manage the application state. In this component, we begin by defining a template that consists of our two child components. The task form is configured to emit an add task event, which allows us to capture new task entries, while the task list receives the current list of tasks as a prop and emits a delete task event when a task is removed. Next, within the script section, we import the necessary libraries and the child components. Inside the setup function, we create a reactive array named tasks using Vue's ref, which will dynamically update the UI as users modify it. We then define the add task method, which appends a new task to our reactive array, and the remove task method, which removes a task based on its index. This dual functionality allows for seamless communication between the parent and child components, facilitating a clean and organized way to manage the task list in our application. As a result, this setup encapsulates the entire task management logic while promoting modularity through component composition. Now that we have discussed how to set up routing in our Vue application, let's implement the necessary code to integrate Vue Router. First, we will install Vue Router using npm, which provides the required functionality for navigating between different views or components within our application. After installing, we need to import the necessary modules into our main application file, including createRouter and createWebHistory, alongside our main app component and the individual components for our routes such as home and about. Next, we will define the routes in an array, where each object specifies a path and the corresponding component that should be rendered for that path. In this case, navigating to the route path will render the home component, while the path about will display the about component. Once our routes are set up, we create the router instance and specify that we want to use web history, enhancing the user experience by avoiding hash-based URLs. Finally, we will attach the router to our Vue application instance using the use method before mounting it to the DOM. This setup allows our application to respond to URL changes and display the correct components seamlessly, creating a dynamic navigation experience for users. Now let's implement the navigation structure in our app Vue file using Vue Router. We start with a basic template that defines the overall layout of our application. In the template, we include a navigation bar within a nav element, which utilizes the router link component to define hyperlinks for navigation. The to attribute of the router link specifies the target route for each link. In this case, we have links for home and about that direct users to the route path and the about page, respectively. Beneath the navigation links, we use the router view component, which serves as a placeholder in our application where different views will be rendered based on the current route. This setup seamlessly updates the displayed component when users navigate through the application, promoting a clean and organized structure. This configuration allows the application to maintain a single-page application feel, providing a fluid user experience while switching between components without full-page reloads. With this foundational routing setup, we can easily expand our application by adding more routes and corresponding components as needed. Now let's see how we can integrate Vuex into our Vue.js application for effective state management. First, we begin by installing Vuex with a simple npm command, which allows us to manage the application's state outside of individual components. After installation, we import the necessary function to create a store. Next, we define the store structure, beginning with the state that holds our tasks array. This central repository allows us to keep track of all tasks in one place. We then outline the mutations, which are the only way to directly modify the state. Here, add task allows us to append new tasks, while remove task enables deletion of tasks at specified indices. Additionally, we implement actions, which are designed for asynchronous operations or additional logic before committing mutations. The add task and remove task actions use the commit method to invoke the corresponding mutations, providing a clean and robust way to manage our tasks as users interact with the application. Finally, we prepare to export this store, allowing our components to access and manage tasks seamlessly through Vuex. Now let's implement the following code to connect our Vue.js application with Vuex for state management. First, we import the necessary functions from Vue, our root app component, and the store we created. By calling createApp with our app component, we initialize the Vue application instance. After setting up the app, we prepare to integrate Vuex by creating the store with createStore, which will manage our application state centrally. Next, we need to make sure our app utilizes both the Vuex store and the Vue router for navigation. We achieve this by using app use store to register our Vuex store and app use router to enable routing capabilities. This ensures that all components within our application can access the store for state changes, while also allowing for route handling. Finally, we call app mount #app, which will mount the instance to the DOM element with the id of app, effectively rendering our application to the specified target. This integration creates a solid foundation for a well-structured Vue.js application where components maintain a reactive connection to a centralized state, enhancing maintainability and scalability. Now let's sum up what we have learned. We started with a basic understanding of a Vue.js application structure and how components work together. We built the task form and task list components for user interactions and integrated them in the home component for centralized task management. We then introduced routing using Vue Router to enhance navigation throughout our application. Finally, we discussed Vuex for state management, enabling centralized control over the app state. As you continue to work with Vue.js, embrace the principles of component architecture, clean code practices, and state management. These foundations will serve you well not only in Vue.js but in other frameworks and libraries you encounter in your development journey. Remember, building comprehensive applications is all about layering complexity and ensuring each piece is manageable and understandable. Now, get out there, explore the possibilities with Vue.js, and build something amazing. The Composition API in Vue.js is a powerful feature that enables developers to organize and reuse code effectively throughout their applications. It enhances modularity, making your code not just easier to maintain but also more intuitive to work with. Today, we will delve into understanding how the Composition API functions, why it's beneficial, and how to implement it within a Vue.js application. So far, we learned about structuring a comprehensive Vue.js application, focusing on key components like task form and task list for task management. We explored routing with Vue Router to navigate between different views and implemented Vuex for centralized state management, enhancing performance and maintainability. Each part of the application contributes to creating responsive user interfaces and managing interactions smoothly. Ultimately, embracing these principles will pave the way for building powerful applications with Vue.js. Now we will talk about how the Composition API contributes to component organization, and we'll look at practical examples to maximize our code's modularity. Now let's see how we can implement a simple counter using the Composition API. We start by importing the ref function from Vue, which allows us to create reactive variables. Within our useCounter function, we declare a reactive reference for count, initializing it to 0. This reference will automatically track any changes to its value. Next, we define two methods, increment and decrement, which adjust the count variable by increasing or decreasing it, respectively. By encapsulating this logic within the useCounter function and returning the count, along with these methods, we create a reusable piece of functionality. This means that any component can easily integrate counter logic without being tied to a component's lifecycle, promoting cleaner and more modular code. In a component, we can simply call useCounter in the setup function to access the count and its associated methods, making our component leaner and focused solely on the functionality we need. This structured approach enhances code clarity and encourages reuse across different parts of our application. The displayed bar chart quantifies the relative importance assigned to 5 key concepts of the Composition API: code organization 85%, modularity 90%, reusability 95%, maintenance 80%, and interactivity 75%. Most prominent pattern is a steady descending ranking from reusability down to interactivity, with uniform 5-point increments between adjacent categories: 95 right arrow, 90 right arrow, 85 right arrow, 80 right arrow, 75. This regular gradient highlights that the Composition API is primarily valued for enabling highly reusable and modular code, 95% and 90%, with strong support for improving code organization, 85%. Maintenance is rated slightly lower, 80%, indicating that while the Composition API aids maintainability, there is still a non-trivial effort required to keep complex composed logic clear. Interactivity scores the lowest, 75%, suggesting that while reactivity and UI interactions are supported, achieving advanced interactive behaviors often relies on combining composables with other patterns or APIs. From these values, we can conclude that when designing with the Composition API, prioritizing the creation of small, reusable composables and modular boundaries will yield the most benefit, while additional attention should be given to strategies that keep composed logic maintainable and to supplement interactive features where needed. Now let's see how we can implement a Vue component that utilizes the useCounter function we created earlier. This component features a simple template that displays the current count and provides 2 buttons to increment and decrement that count. By placing the count display within the h1 tag and linking the buttons to their respective actions with the @click directive, the component remains straightforward and user-friendly. In the script section, we use defineComponent from Vue to define our component and incorporate the useCounter function within the setup function. Here we destructure the properties count, increment, and decrement returned by useCounter, which streamlines how we access and utilize these reactive functionalities. This method eliminates the need for cluttering the component with traditional data properties or methods, leading to cleaner and more maintainable code. Overall, this implementation highlights how the Composition API effectively integrates state management and UI interaction, allowing us to maximize code reuse and clarity within our Vue Vue.js application. Now let's take a look at the useInput function, which serves as a reusable composable for managing form input in a Vue application. This function begins by importing ref from Vue, allowing us to create a reactive reference for our input value. By accepting an initial value as a parameter, useInput provides flexibility in defining the starting state of the input. Within the function, we define a value reference to store the current input state. To handle updates, we create an update value method that modifies the value whenever new input is provided. By returning both value and update value, we equip components with both the state and the function needed to modify it. Now let's see how this composable can be integrated into a Vue component. By using useInput, we can easily bind our input field to input value with vModel, which facilitates automatic two-way data binding. Moreover, when the user types in the input box, the update input method is triggered, ensuring our application's state remains synchronized with user input. This pattern exemplifies the power of the Composition API, enabling efficient state management in a clear, modular way. Now let's implement the following component using our useInput function to demonstrate how it manages form inputs reactively. This component consists of a simple template where a labeled input field allows users to type text. The vModel directive is utilized to bind the input field's value to the input value, which updates automatically as the user types, thanks to the reactive nature of Vue. Inside the script, we import define component from Vue and our useInput function that handles the input state. Within the setup function, we call useInput with an initial empty string, destructuring the returned reactive value, input value, and the method updateInput. This setup facilitates seamless changes between the input field and the underlying state. By integrating this functionality, we can see how efficiently the Composition API allows us to handle form data across components. The clarity of this approach not only enhances reusability, but also simplifies the management of state, making our code cleaner and more intuitive. This is a powerful illustration of how the Composition API enhances component organization and interactivity in Vue.js applications. Now let's see how we can implement feedback for user input using the watch function provided by Vue. We begin by defining a composable function, useInput with feedback, which manages a reactive input value called input value. This is accomplished using the ref function, initiating it with an empty string to prepare for user input. Next, we set up a validation function named validateInput. This function will be triggered every time input value changes, and its purpose is to ensure that the input is not empty. If the user leaves the input blank, an alert is shown, warning them that the input can't be empty. To enable this reaction to changes, we apply the watch function, which observes input value and calls validateInput each time the referenced value is updated. This effectively ties the side effect of input validation to updates in the reactive state. Finally, our function returns input value, allowing it to be directly utilized in any component that opts to incorporate this feedback mechanism, showcasing the seamless integration of state management and side effects within the Composition API. Now let's see how we can implement a component that integrates user input with feedback. We begin by defining our template structure, which includes a label and an input field that binds to input value. This setup creates an interactive element where users can type their input directly into the field. In the script section, we import the define component function from Vue and bring in our custom composable, useInput with feedback. This composable manages the input's reactive state and includes validation logic that kicks in whenever the input changes. Within the setup function, we utilize the composable by calling it to retrieve our input value. This ensures that any changes to the input are tracked reactively. By using the Composition API here, we not only organize our code better, but also encourage reusability of the useInput with feedback function across different components. This modular approach allows us to effectively encapsulate input handling and feedback mechanisms, making it easier to maintain and extend functionality as our application evolves. This is a great example of how the Composition API streamlines the integration of complex behaviors into Vue components. Now let's see how we can manage to-do items locally using the Composition API in Vue.js. We start by creating a useToDo function that utilizes Vue's ref to establish a reactive reference for our to-dos array. This allows us to handle our list of to-dos efficiently. the function exposes two key methods, add_to_do and remove_to_do. The add_to_do method takes a string parameter representing the new to-do item, which it appends to the to-dos array, ensuring that our state updates reactively. The remove_to_do method takes an index as a parameter and removes the corresponding item from the array, again benefiting from Vue's reactivity to update the UI seamlessly. Next, we implement a component that utilizes this use_to_do function. We set up an input field bound to a new to-do reference, allowing users to enter new tasks. The component listens for the enter key event to add a new to-do, checking that the input value is not just whitespace before adding it to our to-dos. We also display the list of to-dos, allowing users to remove individual items with a button. This encapsulated approach not only simplifies state management, but also promotes code reusability and clarity in our component structure. Now let's implement the following functionality for managing to-do items using the composition API. In this Vue component, we utilize the use_to_do function to structure our to-do management logic. Here, we define a local state that holds the list of to-dos, which is reactive, ensuring that any changes are automatically reflected in the UI. We create a simple input field bound to new to-do, allowing us to capture user input for new to-do items. When the user presses the enter key, it triggers the add new to-do method, which first checks if the input is not empty before calling the add_to_do function provided by use_to_do. This ensures that we only add valid entries. The to-dos are displayed in a list, and each to-do item is accompanied by a remove button, utilizing the remove_to_do function from our use_to_do hook. This setup not only enhances code readability and organization, but also promotes reusability, as the to-do logic is encapsulated within the use_to_do function, allowing it to be easily shared across different components as needed. The self-contained nature of this approach leads to cleaner, more maintainable code while leveraging Vue's powerful reactivity features. In conclusion, the composition API in Vue.js represents a paradigm shift in how we structure our applications. It empowers us with better organization through logical function grouping, which subsequently increases code reusability and maintainability. By utilizing functions for common state and behavior, we enhance the modularity of our applications, making it easier for teams to collaborate and for individual developers to manage their growing codebases. Through our examples, we have not only established common patterns for handling state, but also embraced the reactive nature of Vue.js, marrying the simplicity of the composition API with TypeScript's type safety. The journey does not end here. Continue to explore how you can implement the composition API in new and exciting ways. Now that we've covered the fundamentals and advantages of the composition API, challenge yourself by refactoring some of your existing components to use this new approach. Transform old habits and embrace a cleaner, more efficient way to code in Vue.js. Happy coding! Vuex is a state management library that complements Vue.js, specifically designed for managing complex application states. Today, we're diving deep into the world of Vuex, uncovering how it helps manage state efficiently while enhancing our Vue.js applications. So far, we learned about the benefits of the composition API in Vue.js, which enhances code organization, reusability, and maintainability by allowing developers to group related data and methods logically. We explored practical applications through examples, such as managing state with functions like useCounter and useInput, showing how to integrate this functionality seamlessly into components. Additionally, we saw how to handle side effects using the watch function and manage local state efficiently with examples like the use_to_do function. This structured approach facilitates cleaner code and allows teams to collaborate more effectively while maintaining the reactive nature of Vue.js. Now, we will cover how to implement Vuex in our Vue.js applications for state management. Next, we will write the command to install Vuex in our Vue.js project. By executing npm install Vuex at next in the terminal, we ensure that the latest version of Vuex is integrated into our application. This installation is critical as it provides all the functionalities required for effective state management across our components. Once Vuex is installed, we need to set up our store. Now let's create a store folder in our project directory, and inside it, we will define an index.ts file. This file serves as the heart of our Vuex implementation, where we'll specify the initial state for our application, including properties like count and to-dos. Next, we will establish mutations that allow us to modify the state. For example, we will create an increment mutation to increase the count and an add to-do mutation to add items to our to-dos array. After that, we will implement actions that facilitate operations requiring additional logic before state changes, such as committing these mutations. Lastly, we will set up getters, which will enable us to retrieve specified state values in a clean and efficient manner, ensuring that our components can easily access the data needed for reactive updates. Now let's take a look at how to set up our Vuex store, which plays a crucial role in managing the application's state. We begin by importing the createStore function from Vuex. This function allows us to create a store instance that will hold our application's state in a centralized location. Next, we define the state object where we initialize our properties, such as count, starting at 0, and an empty array for to-dos. This initial setup provides the data structure that our application will manipulate. Moving on, we implement the mutations section, where we define functions that will alter the state directly. Each function, like increment and add to-do, receives the current state and performs the necessary changes, ensuring that we maintain predictable state modifications. We also introduce the actions, which serve as a bridge for handling asynchronous tasks or complex logic. Unlike mutations, actions cannot directly modify the state but can call the mutations to do so. Finally, we define getters, which act as computed properties, allowing us to derive state values like the current count or to-dos list. By accessing these through getters, components can remain in sync with the store's state, promoting an organized flow of data across the application. The displayed chart is a pie visualization titled Importance of Key Concepts in Vuex State Management that breaks down 5 core concepts and their relative weights. Centralized store 95%, state management 90%, mutations 85%, actions 80%, and modules 75%. From this distribution, we can see a clear ranking where centralized store and state management occupy the largest slices, indicating that designing a single authoritative store and the overall management of state are the top priorities. Mutations and actions follow, with mutations slightly more emphasized than actions. This suggests developers place strong value on the predictable, synchronous state changes that mutations provide, while still recognizing actions as important for handling asynchronous or complex flows. Modules, while the smallest slice, still register a high value, 75%, showing that modularization for scalability is important but often considered secondary to the core responsibilities of a centralized store and direct state control. Taken together, the uniformly high percentages, all greater or equal to 75%, imply that every listed concept is essential. Prioritize establishing a clear centralized store and robust state definitions first, implement concise and predictable mutations next, use actions for async or orchestrated logic, and adopt modules as the application grows to keep concerns separated and maintainable. Now that we have set up our Vuex store, we'll integrate it into our Vue application. To accomplish this, we need to import the store into our main application file. First, we import the necessary createApp function from Vue and our root component, app_vue. Next, we also import the store from our store directory. With everything in place, we use the createApp function to create a new Vue application instance, passing in the app component. Next, we call the use method with the store as an argument, which registers the Vuex store with our application. This step is crucial as it ensures that all components have access to the centralized state management offered by Vuex. Finally, we mount the application to the DOM using the mount method, specifying the element ID where our application will be rendered, often app. With this setup, every component within our application can now easily interact with the Vuex store, facilitating a seamless flow of data and state management throughout the application. This structure lays the groundwork for utilizing Vuex in a more intricate manner in our components to manage application state effectively. Now let's implement the following code for our counter component, which will serve as a simple interface for interacting with the Vuex store. In this component, we first define a template that displays the current count from the store using a header tag. The button below it is set up to trigger an increment action when clicked, providing a clear way for users to interact with the application. Next, within the script tag, we import the necessary functions from Vue and Vuex. We then utilize the define component to create our component, where we make use of the useStore function to gain access to the Vuex store. Within the setup function, we define an increment count method that dispatches the increment action from the store. This action is responsible for modifying the application state by incrementing the count. To ensure our component stays in sync with the store, we also define a getCount method that retrieves the current count from the store's getters. This two-way communication between our component and Vuex helps maintain a reactive and centralized state, demonstrating how Vuex efficiently manages data in our Vue applications. Next, we will implement the to-do list component, which enables users to manage their to-do items efficiently. In this component, we first define a template that includes an input field and an unordered list. The input field uses Vue's vModel directive to bind the user input to a ref named new-to-do, allowing for reactive updates. We also set up an event listener with @keyup, enter, to trigger the add-to-do method whenever the user presses enter, facilitating a smooth user experience for adding new to-dos. The add-to-do method checks if the new-to-do input is not just whitespace. If valid, it dispatches an action named add-to-do to the Vuex store, passing the input value. This action triggers the corresponding mutation in the store, ensuring that our to-do items are consistently managed in a centralized location. Finally, we use the getToDos getter from the store to fetch the current list of to-dos, allowing us to display them dynamically in the list. This structure guarantees that the UI remains in sync with the Vuex state, showcasing the power of Vue's reactivity combined with Vuex's state management. Now let's implement a module to manage our to-do items within the Vuex store. This module encapsulates its own state, mutations, actions, and getters, promoting better organization and scalability for larger applications. First, we define the state for the module, which includes an array to hold our to-dos. This allows us to maintain a clean separation of the to-do functionality from other parts of the application state. Next, we set up a mutation called add-to-do, responsible for updating the state by pushing new to-do items into the to-dos array. Instead of directly modifying the state, we follow Vuex's pattern by committing mutations, ensuring that our changes are trackable and predictable. Additionally, we define an action with the same name to handle any asynchronous aspects of adding a to-do, utilizing the mutation to change the state after obtaining the necessary data. Lastly, we create a getter function named getToDos that allows components to access the current list of to-dos easily. This approach not only encapsulates related functionalities within the module, but also helps keep the overall store configuration straightforward and manageable, enhancing the maintainability of your application as it grows. Now let's implement a plugin for our Vuex store that will enable local storage persistence. This plugin, named Vuex Local Storage, is a simple yet effective way to ensure that any mutations performed on the Vuex state are automatically saved in the browser's local storage. When we subscribe to the store, we listen for any mutations that change the state. Every time a mutation occurs, we serialize the current state and save it to local storage with the key store. Next, we integrate this plugin into our Vuex store configuration. By adding Vuex Local Storage to the plugins array, it enhances our store's functionality without requiring changes to how we implement mutations. This means that our to-do list and any changes made to the state will be preserved even if the user refreshes the page, greatly improving user experience. Not only does this keep the state persistent across sessions, but it also allows us to manage application state more effectively. With this in place, your app can maintain a seamless experience by keeping user data intact between reloads. As we wrap up our discussion on Vuex, remember that while it adds complexity to your application, it also brings powerful tools for managing shared state efficiently. By centralizing your state in a store, using getters for read access, and committing mutations for updates, you have a robust framework for handling the state of your Vue.js applications. In conclusion, today we've explored Vuex's fundamental concepts, including setting up the store, managing state with mutations and actions, and organizing the store through modules. We also looked at advanced techniques for plugins and persisting state. By applying these concepts, you'll not only write cleaner code, but also build scalable applications that can grow with user needs. So now that we've covered Vuex, I encourage you to give it a try in your own projects. Implement a few features, play around with actions and mutations, and watch how Vuex transforms your application's state management into a breeze. Happy coding, and until next time, keep pushing the boundaries of what you can create with Vue.js and Vuex. Building scalable Vue.js applications requires a solid understanding of the framework's lightweight nature, efficient state management, and the principles of modular design. In this session, we will delve into how Vue.js is tree-shakeable, ensuring that only the necessary code is bundled, making our applications perform better and load faster. So far, we learned about Vuex, a state management library designed to centralize and manage application states in Vue.js. We discussed its core components, including a store with state, mutations, actions, and getters, and practiced integrating Vuex into a Vue application. We also explored modularization for organizing store logic and the use of plugins for features like state persistence. Understanding these fundamentals equips us to build scalable and maintainable applications with Vuex. Now we will talk about building scalable applications in Vue.js by utilizing its lightweight architecture alongside state management with Vuex and the importance of following best practices in structuring our code. Vue.js is renowned for its light footprint. This means that when we're developing our applications, we're working with a library that is designed to offer the essential features we need without the heavy baggage that often comes with larger frameworks. This lightweight nature of Vue.js encourages us to build applications that are not only easier to develop, but also faster to load and more efficient in execution. The fact that Vue.js uses a tree-shaking mechanism means that it automatically removes unused parts of the code during the build process. This allows developers to only ship the necessary code to run their applications, which is fantastic for optimizing load times and performance. The accompanying figure, titled Key Concepts in Building Scalable Vue.js Applications, is a horizontal bar chart that ranks 6 core concepts by importance level % on the x-axis. From the chart, we can read the exact importance values. Tree shaking is highest at 95%, followed by lightweight nature at 90%, efficient state management at 85%, modular design at 80%, error handling at 75%, and lazy loading at 70%. The bars are labeled with their percentage values at the ends, making the relative priorities explicit. 2 clear patterns emerge. First, optimization-focused concepts, tree shaking and lightweight nature, appear as the top priorities, indicating that reducing bundle size and minimizing shipped code are primary levers for scalability. Second, application structure concerns, efficient state management, and modular design follow closely, emphasizing maintainability alongside performance. Error handling and lazy loading are shown as important but comparatively lower priorities, suggesting they are essential for robustness and runtime responsiveness, but typically come after initial bundle and architecture optimizations. Overall, the figure visually confirms that while performance optimizations laid, solid state and modular practices form the immediate next layer of investment when scaling Vue.js applications. Now let's see how we can implement a utility module that showcases tree shaking in action. In this example, we have 2 utility functions defined in a file named utils.ts. One of these functions, unused function, is never used in our main component, my component Vue, while the other, used function, is imported and utilized. By structuring our code this way, we allow Vue's tree-shaking mechanism to automatically exclude the unused function from the final build. This process optimizes our bundle size, ensuring that only the necessary code is shipped to users. As we examine my component Vue, we observe that it imports used function and calls it within the mounted lifecycle hook. This illustrates how tree shaking helps streamline the application by removing dead code, which ultimately enhances performance and reduces loading times for users. Next, we will look at how this focused approach to code organization not only keeps our files neat, but also reinforces best practices in building scalable applications, making our code more maintainable and efficient. Now let's implement a reusable button component in Vue.js. In the base button Vue file, we define a single file component that encapsulates all necessary logic for a customizable button. The template consists of a button element, which uses Vue's vbind directive to dynamically apply a CSS class, allowing for flexible styling based on the component's props. Within the script section, we declare the properties that the component will accept, including label and class name. The label prop is a required string that will be displayed on the button, ensuring that every button has relevant text. The class name prop is optional and has a default value of an empty string, allowing you to pass additional styles when needed. This setup exemplifies the principle of separation of concerns, as the component is designed to manage its presentation and logic independently. Finally, the style section contains scoped rules for the button's appearance, ensuring that the styles do not interfere with other components. By using this button across your application, you maintain consistency and uphold the dry principle, making updates easier as you only need to change the button in one location. Next, we will implement the routing logic for our Vue application using Vue router. In the router/index.ts file, we start by importing the necessary functions from the Vue router library. Here, we create a router instance that facilitates navigating through different views of our application. We define a route for the user profile page that includes a dynamic segment, id, which will accept user IDs from the URL. This allows us to generate user-specific content dynamically without needing separate routes for each user. The user profile component is assigned to handle this route, ensuring that user data relevant to the dynamic ID can be displayed. This centralized approach to defining routes simplifies the management of routes as the application scales, allowing for more complex setups like nested routes in the future. By leveraging the createWebHistory function, we ensure that our application supports history mode routing, resulting in cleaner URLs devoid of hashes. In the user profile view, we utilize the useRoute function to access the dynamic segment, which means we can readily display the user's information by simply referring to route params ID. This streamlines our architecture, enhancing maintainability and clarity in our code base. Now let's implement a dedicated Vuex module for managing our product catalog in the e-commerce application. This module encapsulates all relevant state, mutations, actions, and getters related to product management, which promotes clarity and organization as the application scales. First, we define the initial state of the module, where products is initialized as an empty array. This helps us manage the list of products fetched from an API or any data source. Next, we implement a mutation called setProducts, which will update the state with the fetched product data. By committing this mutation, we ensure that our state remains reactive and that any component relying on the product list automatically updates when new products are set. We'll also introduce an action named fetchProducts. This action simulates an API call to retrieve product data and commits the setProducts mutation with the fetched data. This separation of concerns allows actions to handle asynchronous operations while keeping the actual data manipulation in the mutations. Lastly, we define a getter, getProducts, which provides an easy way for our components to access the products from the state. This modular structure not only maintains organization, but enhances maintainability as our application and product catalog grow. Now let's implement a global error handler in our Vue application to enhance our error management capabilities. To start, we first create our Vue application instance using createApp, which initializes our main app component. Next, we set up the error handler by assigning a function to app_config_error_handler. This function takes three parameters: which represents the error object, instance, which is the component instance where the error occurred, and info, which provides additional context about the error. Within this function, we log the error to the console, which enables us to monitor any uncaught errors that arise during the application's runtime. This visibility is crucial for effective debugging and can significantly aid in diagnosing issues as they occur. Moreover, we can expand this handler to include additional logic, such as implementing a logging service or user notifications for better tracking in production environments. Finally, we chain our store and router setup before mounting the application, ensuring that our global error handler is in place from the start, enhancing the robustness and maintainability of our Vue application. Now let's implement lazy loading of components in our Vue application. This can greatly enhance performance by reducing the initial load time, especially for larger components that are not immediately needed. In this approach, we create an asynchronous component using the import function, which allows us to load heavy component Vue only when the user navigates to the specific route associated with it. We define this async component with a straightforward syntax, where we assign the result of the dynamic import to a constant called async component. Then we set up our route configuration in an array. Here, we specify a path for our route, heavy, and link it to our async component. This means that the heavy component will remain unloaded until the user actively requests to access the heavy path. Doing so helps keep our application responsive and snappy, prioritizing initial load speed while managing resources efficiently. This strategy not only optimizes the user experience, but also aligns with best practices in modular application design. In summary, we've covered a lot in our journey to build scalable Vue.js applications. We learned how Vue.js's lightweight nature and tree-shaking capabilities lead to optimized performance. By structuring our components, leveraging Vue router effectively, harnessing Vuex for state management, implementing error handling, and optimizing for performance, we position ourselves to create robust and maintainable applications. With these fundamental principles and techniques in our toolkit, we will be well prepared to tackle any challenges that arise as we develop complex applications with Vue.js. Remember, the goal is not only to write great code, but to enhance the user experience while maintaining an organized and efficient architecture. Thank you for joining today's lesson. Now let's take these concepts and put them to the test in your Vue.js projects. Happy coding! Vue.js has taken a giant leap forward with version 3, introducing significant improvements and breaking changes while retaining core component patterns. Today, we will explore advanced component patterns you can leverage to design scalable and efficient applications. So far, we learned about the importance of building scalable Vue.js applications by leveraging its lightweight architecture, tree-shaking capabilities, and efficient state management with Vuex. We emphasize structuring components and maintaining modularity for improved maintainability, while also highlighting the role of Vue router in managing complex application routes. Additionally, we discussed implementing error handling mechanisms and optimizing performance through techniques such as lazy loading and code splitting. These foundational principles will help us create robust and efficient applications in Vue.js. Now we will dive deeper into advanced patterns for building Vue components, focusing on render functions, functional components, and mixins, ultimately enhancing our development toolbelt. Now let's see how we can implement a component that utilizes the render function in Vue.js. We begin by defining a simple template with a root div that houses a custom component called myList, which receives an array of items and a Boolean value indicating whether to show details. Next, we set up the component's data, initializing an array called items with 3 fruit names and a Boolean show details set to true. This component will conditionally render details based on the show details prop. Now let's take a look at the myList component definition. Instead of using a traditional template, we employ the render method. This method utilizes the createElement function to dynamically generate a list. Inside the method, we map over the items array, creating a lie element for each fruit. If show details is true, a span is appended next to the item name, displaying additional information. This approach provides the flexibility to manage complex conditions and structures that might be challenging with standard templates, showcasing the power of render functions for dynamic DOM construction. Now let's implement a functional component in Vue.js to enhance our understanding of how these stateless components work. We begin by defining myFunctionalButton, which accepts props for type, onClick, and label. This functional component constructs a button element, using a template literal to dynamically assign a CSS class based on the type prop. This approach allows the component to remain lightweight and efficient, as it does not manage its state and instead relies entirely on the props it receives. Next, we'll demonstrate how to utilize this functional component within a parent component. In the parent's template, we use myFunctionalButton and pass the necessary props for type and label, as well as linking the onClick event to a method defined in the parent script section. This method, handleClick, triggers an alert when the button is clicked, showcasing how easy it is to handle events with functional components. By implementing this pattern, we not only streamline our component logic, but also enhance the performance of our Vue.js applications, making use of reusable and presentational components. Now let's take a look at how to create a mixin in Vue.js that allows us to manage state and log events efficiently. First, we define event logger mixin, which encapsulates a data method returning an initial state for counter. This simple piece of logic initializes a counter variable to 0, making it easy to track how many times a certain event occurs. Next, we add a method called incrementCounter within the method's object. This method not only increments the counter, but also logs a message each time it's invoked, providing insight into the component's activity. This mixin can then be utilized in a separate component by including it within the mixins array. The component template includes a button that triggers the increment counter method when clicked, along with a paragraph displaying the current counter value. By employing this mixin, we can easily share the same counter logic across multiple components, promoting the dry principle while maintaining a clean and modular code structure. This method exemplifies how mixins can enhance the reusability and organization of shared functionality in our Vue applications. The displayed figure is a bar chart titled Usage of Advanced Vue.js Component Patterns with 5 categories on the horizontal axis and usage frequency % on the vertical axis. The categories and their labeled values are render functions 20%, functional components 15%, mixins 25%, slots 30%, and scoped slots 10%. From the bar heights and labels, we observe that slots register the highest usage at 30%, followed by mixins at 25%, render functions at 20%, functional components at 15%, and scoped slots at 10%. Key patterns include a clear leaning toward template-based composition. Slots and mixins together account for more than half of the total when compared individually. A moderate but notable use of programmatic rendering with render functions, and relatively lower adoption of functional components and scoped slots in this dataset. Conclusions drawn from these values are: prioritize understanding and applying slots and mixins for immediate impact since they show the highest usage. Keep render functions in your toolbox for cases needing dynamic virtual DOM construction. They sit in the middle at 20%. And treat functional components and scoped slots as more specialized or less frequently used tools based on their lower percentages, 15% and 10% respectively. These numeric comparisons help guide where to focus learning and practical application when choosing patterns for component architecture. Now let's take a look at a practical implementation of a modal component utilizing slots in Vue.js. The modal component begins with its template containing a basic structure divided into 3 parts: the header, body, and footer. Each section includes a slot, which allows for content to be dynamically injected by the parent component. If the parent does not provide content for any particular slot, default fallback content will be displayed. The header has a name attribute for segmentation, while the body slot serves as a generic area for content. Next, we will implement the modal in a parent component by specifying the desired content using named slots. By leveraging named slots for the header and footer, we enable tailored customization while the modal structure remains intact. In the body section, we can insert any content, showcasing the flexibility of the component. This setup illustrates how slots facilitate reusable components by allowing the parent to influence the displayed information without altering the modal's core design. Thus, slots prove invaluable for scenarios requiring both dynamic content and consistent component architecture. Now let's see how we can implement a list component using scoped slots to dynamically provide details for a series of items. In our template, we start by defining a container element that includes a heading for our item list. We then create a slot using the v_for directive, which iterates over the item's prop. This allows each item from the past array to be exposed to the slot, accessible under the name item. If no specific content is provided for the slot, a default display line will show the item name and value. Next, we'll utilize this item list in a parent component. Here, we define the structure with the item list component and specify our item's data property, which contains a list of objects with name and value properties. We then implement a scoped slot, leveraging the destructured item object to present each item's details within a div. This structure enables us to display the item's name, its value, and includes a button that triggers an action when clicked. By utilizing scoped slots, we effectively bind the specific item data from the child to the parent, promoting a clean and manageable approach to rendering complex, data-driven UIs. In conclusion, as we explored advanced Vue.js component patterns today, we've learned how to utilize render functions for dynamic rendering, implemented functional components for better performance, and introduced mixins for sharing common logic. We also discussed the versatility of slots and scoped slots, enabling us to construct reusable and customizable components. These patterns not only enhance your coding skills, but also equip you to build scalable applications more effectively. As you venture into integrating these advanced patterns into your projects, remember to leverage the strengths of each approach and utilize them wisely to enhance your Vue experiences. Thank you for joining me in exploring these exciting features of Vue.js. Happy coding! Vuex is a state management library that seamlessly integrates with Vue.js, providing a centralized store for managing complex application states. This library is essential when working on larger applications where managing state across multiple components can become unwieldy. So far, we learned about the significant advancements in Vue.js 3, focusing on advanced component patterns that aid in building scalable applications. We covered key concepts such as render functions for dynamic rendering, functional components for performance enhancement, and mixins for shared logic. Additionally, we explored the flexibility of slots and scoped slots for creating reusable components with dynamic content. These principles form a solid foundation for developing efficient and maintainable Vue.js applications. Now, we will talk about effective state management with Vuex, which is crucial for maintaining a predictable state across your Vue applications. Now let's take a look at how to create a Vuex store, which is essential for managing application state effectively. We begin by importing Vue and Vuex, which are necessary for utilizing the Vuex library. After that, we enable Vuex by calling Vue use Vuex, allowing us to utilize its functionalities throughout our Vue application. Next, we implement the core of our store by creating a new instance of Vuex store. Within the store, we define our application state as an object, which in this example contains a count initialized to 0 and an empty array to-dos. This state object acts as our single source of truth, ensuring that all components relying on this store can access the same data. Finally, we export the store so that it can be used across our Vue components. This foundational setup is crucial, as it organizes our state management in a centralized manner, preventing the chaos of scattering state across various components. By accessing this store, we can maintain a predictable state throughout our application. The chart titled Distribution of Concepts in Vuex State Management displays a pie breakdown of 5 core concepts: state management 25%, mutations 20%, actions 30%, getters 15%, and modules 10%. From these proportions, we can observe that actions occupy the largest segment at 30%, indicating that handling asynchronous operations and orchestrating state changes through actions is a dominant concern in Vuex usage. State management itself is the next largest segment at 25%, underscoring the central role of a single source of truth in application architecture. Mutations at 20% represent the synchronous mechanisms that directly alter state and remain a substantial part of the workflow. Getters account for 15%, reflecting their role in computing derived state without inflating the store, while modules are the smallest slice at 10%, suggesting that although modularization is important for scaling, it represents a smaller proportion of the conceptual focus compared to actions and core state. Overall, the visual emphasizes prioritizing robust action handling and clear state structure, while still allocating attention to precise mutations, efficient getters, and modular organization. Next, we will write the following code to define our state and mutations in the Vuex store. The store object is created using new Vuex store, which takes an object containing our application's state and mutations. In this example, we initialize the state with a single property, count, starting at 0. The mutations property contains 2 functions, increment and decrement. These methods are responsible for modifying the state in a predictable way. The increment function increases the count by 1, while the decrement function decreases it by 1. It's essential to note that mutations in Vuex should be synchronous to keep track of state changes accurately. Now let's see how we can implement this in our Vue component. The template includes a button that, when clicked, triggers the increment count method. This method uses the commit function to call the increment mutation, which updates the count. Additionally, we utilize map_state to directly access the count from the store, allowing for a more straightforward and efficient way to render the current count in our interface. This encapsulation of state management principles keeps our code organized and manageable. Now let's see how we can implement actions in our Vuex store. In this section, we define an action called fetch_todos, which is responsible for simulating an API call to fetch to-do items. This action uses a promise to create an asynchronous flow, allowing us to wait for an operation to complete before committing changes to the state. Inside the action, we use setTimeout to mimic a delay, and once the to-dos are supposedly retrieved, we loop through the resulting array. For each to-do item, we commit the add_to-do mutation, which pushes the to-do into the to-dos state array. Next, we will set up a Vue component that utilizes this action. When the button labeled Load To-Dos is clicked, the Load To-Dos method is triggered. This method dispatches the Fetch To-Dos action, initiating the asynchronous operation to load the to-do items into the application state. As a result, once the action completes, the to-dos list in the component is automatically populated, effectively demonstrating how actions can facilitate a clear data flow while managing the asynchronous nature of API calls. This organized structure enhances both the clarity and maintainability of our state management. Now let's see how we can implement getters in our Vuex store to manage and derive state efficiently. We define the Vuex store to include a state object that contains an array of to-dos, each with properties like ID, text, and completed status. In the getters section, we create a getter called completed to-dos. This getter is a function that takes the state as its parameter and filters through the to-dos array to return only those items that are marked as completed. Next, we can utilize this getter in a Vue component. By employing the map_getters helper from Vuex, we make the completed to-dos getter directly accessible to our component's computed properties. This allows us to bind the list of completed to-dos to the user interface seamlessly. In the template, we iterate over completed to-dos using v_for, creating a list item for each completed to-do, dynamically showing the text inside. This structure not only offloads filtering logic to the store, but also keeps our component clean and focused solely on rendering the data. Now let's implement a module-based approach in Vuex by creating a to-dos module. This module encapsulates its own state, which in this case is an array of to-dos. Inside the module, we define mutations to handle state changes. For example, the add to-do mutation adds a new to-do item to the state. This encapsulation allows us to keep functionalities related to to-dos separate from the rest of our application, promoting better organization. Next, we introduce actions which handle asynchronous operations. Though we have a placeholder for fetching to-dos, this is where you would typically include your API calls or any other async logic. Finally, we create a getter named completed to-dos, which filters the to-dos array to return only the tasks that have been marked as completed. To utilize this module in our root store, we register it under the modules option, associating it with the name to-dos. This structure not only fosters readability and maintainability, but also encourages parallel development when working in larger teams or developing complex applications. Accessing the mutation and getter and components is straightforward. You just reference them with the module name, enabling a modularized and organized state management system. Now that we've discussed the basics of Vuex, let's touch on some best practices. One fundamental aspect is ensuring that all state changes are funneled through mutations. This enforcement allows for easier debugging, as you can track all state changes in a predictable manner. Using Vuex's built-in time travel debugging with Vue Devtools can significantly enhance your debugging process. Additionally, keep your state as lean as possible. Instead of storing derived values in state, make good use of getters to compute them dynamically. Performance might degrade in large applications if you store excessive redundancies in the state. Also, always remember to keep your modules organized and maintain clear responsibilities for each. This practice not only enhances readability, but also aids in testing and maintaining your application over time. Following Vuex's conventions leads to a more predictable state management pattern across your application. In summary, Vuex serves as a powerful state management solution for Vue.js applications, bringing clarity and maintainability to your component architecture. By understanding its core concepts, state, mutations, actions, and getters, you can manage complex state across your applications effectively. Organizing your state management into modules can further streamline your application as it scales. Always remember, Vuex is your ally in managing state in a predictable manner, enabling you to focus on building exceptional user experiences. Happy coding, and I hope you're excited to implement Vuex in your projects. Optimizing Vue.js performance, especially for large applications, is crucial for delivering a seamless user experience. A well-optimized application not only enhances user satisfaction, but also improves engagement and retention rates. Let's dive into how Vue.js is designed for performance and the strategies we can employ to ensure our applications run smoothly, even as they scale. So far, we learned about the role of Vuex as a state management library within Vue.js applications, emphasizing the importance of a centralized store for managing application state. We covered key principles including state, mutations for synchronous changes, actions for asynchronous operations, getters for derived state, and modules for organized management of larger applications. Best practices were also outlined, highlighting the need for predictable state changes through mutations and efficient use of getters. This foundational understanding equips us to effectively implement and scale applications using Vuex. Now, we will talk about optimizing Vue.js performance for large applications, exploring strategies and code examples that can help you create fast and responsive applications. Now let's take a look at how we manage intervals in our Vue component to track a counter. We start by defining a template that displays the current value of the counter. Inside the script section, we declare our component data, initializing counter to 0 and intervalid to null. In the created lifecycle hook, we set up an interval that increments the counter every second using setInterval. This allows us to update the displayed value continuously while the component is active. However, to maintain performance and prevent any memory leaks, it's crucial to clean up resources when the component is about to be destroyed. Here, we use the beforeDestroy lifecycle hook to clear the interval by calling clearInterval with the intervalid. This ensures that we stop the counter updates and free up resources. By managing our component's lifecycle in this way, we not only enhance the application's performance but also demonstrate good coding practices that lead to a more efficient and robust Vue.js application. Now let's see how we can implement lazy loading in our Vue.js application using Vue Router. The first step is to import the necessary Vue and Router libraries, allowing us to utilize the routing capabilities of Vue.js. We then register the router by calling Vue use router, which sets up the infrastructure for handling our application's routes. Next, we define our routes in an array. Each route object specifies a path, which signifies the URL endpoint, and a name, which is used for programmatic navigation. The key feature here is the component property, where we lazily load our components using dynamic imports. Instead of importing the home and about components at the top of our file, we use an arrow function that returns the import statement. This approach ensures that the code for these components is only fetched when the user navigates to their respective routes. Finally, we create a new instance of the router with the defined routes and export it. This setup not only helps in reducing the initial loading time of the application, but also leverages Webpack's code splitting capabilities, thus optimizing performance significantly for larger applications. The displayed figure titled Impact of Optimization Strategies on Vue.js Performance is a horizontal bar chart plotting 5 optimization strategies against their relative impact on performance %. The chart lists from highest to lowest impact: lazy loading 30%, code splitting 25%, virtual DOM 20%, SSR 15%, and state management 10%. Key patterns are immediately clear. The top 2 strategies, lazy loading and code splitting, together account for 55% of the measured impact, indicating that reducing initial bundle size and delivering code on demand are the most effective levers for improving perceived and real performance in large Vue.js applications. Virtual DOM optimizations contribute a significant but smaller portion, 20%, showing that rendering efficiency remains important once bundle concerns are addressed. Server-side rendering (SSR) provides a moderate impact, 15%, suggesting it's particularly valuable for improving initial load time and SEO, but may be a secondary priority compared to front-end bundling strategies. State management 10% appears as the smallest single contributor in this visualization, implying that while proper state handling, e.g., Vuex patterns, avoiding unnecessary reactivity matters, its direct impact on overall performance is less than load time and rendering optimizations. From these values, we can conclude a practical prioritization. Focus first on lazy loading and code splitting to shrink initial payloads, then optimize rendering and evaluate SSR where server-rendered HTML or SEO is required, and finally refine state management to eliminate local bottlenecks, a sequence that aligns with the techniques discussed earlier in the lesson. Now let's see how we can implement a computed property in Vue.js to efficiently filter a large array of items based on user input. In the template section, we start by creating an unordered list that dynamically renders each item in the filtered items array. Each list item is assigned a unique key, which helps Vue identify elements and optimize rendering. Next, in the script section, we define a data function that initializes two reactive properties: items, which holds a large array of objects, and search query, the user's input for filtering. Instead of using a deep watcher, we leverage a computed property called filtered items. This property returns a filtered array of items that includes the search query in their name property. The benefit of computed properties lies in their caching ability. They only recompute when one of their dependencies changes, in this case, the search query. This approach reduces unnecessary processing and enhances application performance by avoiding deep watchers, making it a practical choice for optimizing how we manage reactivity in larger Vue.js applications. Now let's see how we can efficiently load external libraries in a Vue.js application. The following code snippet demonstrates the use of the dynamic import syntax, which allows us to load the chart.js library only when it is specifically needed, minimizing the initial bundle size of our application. In this example, we define an asynchronous method called loadChartLibrary. When this method is invoked, the import function is called with the library's name as its argument. This triggers a process that fetches the chart.js library only at that moment, ensuring that it does not contribute to the initial loading wait of our application. This approach is particularly advantageous for applications that require multiple libraries but want to maintain optimal performance by reducing the payload size at the start. By lazily loading the chart.js library in this manner, we preserve resources and improve loading times, enhancing the overall user experience. This technique underscores the importance of conscious resource management in Vue.js applications, especially as they grow in complexity and dependency on third-party libraries. Now let's take a look at how we can effectively use the Vuex directive in our Vue.js application to optimize performance. We begin with a template that features a button, which users can click to toggle the visibility of componente. The key aspect here is the Vuex condition applied to componente. This means that the component is only rendered in the DOM when the showComponente data property is set to true. By initializing showComponente as false within the data function, we ensure that componente does not consume resources when it's not needed. The toggle method updates this Boolean state, enabling us to manage component rendering efficiently. Utilizing Vuex over vshow becomes particularly advantageous when handling complex components that may take up significant resources, as it allows for complete removal from the DOM rather than just hiding it. This approach not only minimizes rendering times, but also improves overall application performance by maintaining a clean and efficient DOM structure. Now let's take a look at a simple implementation of server-side rendering SSR using Nuxt.js. In this example, we define a Vue component encapsulated within a template block that displays a heading containing a title. The title, however, is fetched asynchronously before the component is rendered. This is achieved through the asyncData function, which operates on the server side. When the component is rendered, asyncData receives the root parameters, specifically the id in this case, which uniquely identifies the resource we want to fetch. It makes a call to an external API to retrieve the corresponding data, and following the successful fetch, it converts the fetched response into JSON format. By returning an object containing the fetched title, we ensure that when the server sends the rendered HTML to the client, it includes the title directly in the markup. This technique not only enhances the initial load speed, but also improves the application's SEO performance because search engines can index the fetched content directly. Overall, implementing SSR in this way allows for a more efficient user experience by delivering fully rendered pages on the first visit. Now let's implement the following code snippet to facilitate performance profiling in our Vue.js application. The console profile method serves as a powerful tool for measuring performance, allowing us to encapsulate specific operations or interactions we want to analyze. By calling console profile myProfile, we initiate a profiling session and assign it a descriptive label. This step is crucial as it helps us identify the exact operations being monitored. Once we have completed the operations we want to track, we call console profile end myProfile to conclude the profiling session. This action stops the profiling process and logs the captured data to the console, where we can review the performance metrics gathered during that session. Utilizing this approach provides insight into which parts of our application may need optimization, enabling us to identify bottlenecks effectively. Regular performance profiling acts like a performance coach, guiding us to areas needing improvement and helping refine our application for enhanced efficiency. By integrating such profiling techniques into our routine checks, we ensure our application remains responsive and performant as it scales. In summary, optimizing Vue.js performance for large applications requires a multifaceted approach that encompasses efficient component management, lazy loading, effective use of reactivity, and analysis. By implementing these strategies, you not only enhance the performance of your applications, but also provide a superior experience for your users. Remember, performance optimization is not a one-time task, but a continuous process. So keep testing, monitoring, and improving. Your users will thank you. Vue.js is an innovative JavaScript framework that's gaining traction for building interactive user interfaces. Today, we will delve into the Vue.js ecosystem, exploring its vital components, tools, and practices that support and enhance the development process. We'll also examine how this community-driven, open-source project is evolving to help developers create powerful applications. So far, we learned about the importance of optimizing Vue.js performance for large applications to enhance user experience and satisfaction. We explored various strategies, including efficient component lifecycle management, lazy loading, and managing reactivity, each contributing to smoother performance. Additionally, we discussed techniques like SSR and monitoring metrics for continuous improvement. This foundational knowledge supports the development of fast and responsive Vue.js applications. Now let's see how we can implement a basic Vue instance to demonstrate the core reactivity system in Vue.js. In this code, we're creating a new Vue instance and binding it to an HTML element with the ID of app. This means that everything within the Vue instance will be associated with this particular element on the web page. Inside the data option, we define a property called message and set its initial value to hello Vue.js. This property becomes reactive, meaning any updates to message will trigger automatic updates to the DOM, ensuring the displayed content is dynamic and up to date. Furthermore, the template option uses the special Vue syntax to display the message property within a div. As we manipulate the message value later in our application, Vue will efficiently update the user interface in real time without requiring any manual DOM manipulation. This streamlined mechanism not only simplifies the development process but also enhances user experience, making Vue.js an appealing choice for building interactive applications. Now let's take a look at how to set up Vue Router for our application. We begin by installing the Vue Router library using npm, which is crucial for enabling navigation between different components or pages in our single-page application. Once installed, we create a new file named router.js. In this file, we import Vue, the router library, and the components that we will navigate to, in this case, home and about. By utilizing Vue use router, we register the router instance, allowing it to integrate with our Vue application. Next, we define an array of routes, where each route object specifies a path and the corresponding component to render when that path is accessed. In our example, the route path / is associated with the home component, while the path about is linked to the about component. Finally, we export a new router instance that includes our defined routes. This setup is fundamental as it allows our application to dynamically render components based on the current URL without requiring a full page reload, ensuring a seamless user experience. Now, let's see how we can integrate this router configuration into our main Vue instance to enable effective navigation within our app. Next, we will write the following command to install Vuex, our state management library. By using npm install Vuex, we ensure that Vuex is included in our project dependencies, allowing us to leverage its powerful features. Now let's take a look at how to create a Vuex store by setting up a store.js file. Here, we import Vue and Vuex and then install Vuex as a plugin using Vue use Vuex. This step is crucial as it integrates Vuex with our Vue instance. We then define a new Vuex store where we initialize the state, which contains our count variable set to 0. Mutations are used to modify the state in a predictable manner. In this case, we define two mutations, increment and decrement, that will increase and decrease the count, respectively. Additionally, we introduce an action called async_increment, which demonstrates how actions can handle asynchronous operations before committing mutations. Finally, we utilize this store in our Vue components by accessing the state through computed properties and invoking mutations through methods. This structure ensures that our application remains reactive and efficient, aligning well with Vue's core principles. Now let's implement Vuetify in our Vue.js application to enhance the user interface. First, we need to install Vuetify using npm, which allows us to add this material design component framework to our project easily. Once installed, we configure Vuetify by importing it and activating it within our Vue instance. This setup ensures that our application can leverage Vuetify's extensive library of ready-to-use UI components, streamlining the development process. Next, we instantiate Vuetify in the Vue instance by passing a new Vuetify object to the instance options. This connection is crucial because it enables the use of Vuetify components across our application. Now, let's take a look at how we can create a simple user interface using Vuetify components. We define our template using Vuetify's standard layout elements, a toolbar for the title of our application, and a container for the main content. Inside this container, we will add a button that, when clicked, triggers an increment function which updates the displayed count. This reactivity demonstrates how easily we can manage user interactions and keep our UI consistent and intuitive with Vuetify's powerful features. The displayed bar chart, titled Overview of Key Components in the Vue.js Ecosystem, maps an importance level vertical axis against key categories on the horizontal axis: Reactivity System, Vue Router, Vuex, Vuetify, Vue CLI, Testing, and Nuxt.js. The chart shows that the reactivity system has the highest single importance value 30, followed by Vuex 25 and Vue Router 20. Vuetify appears in the middle with a value of 15, while Vue CLI and Nuxt.js share lower but equal importance values of 10 each. Testing registers the smallest value at 5. Interpreting these values together reveals a clear prioritization. Core runtime features and application architecture, reactivity, state management, and routing account for the majority of the measured importance, indicating they are foundational to effective Vue applications. Vuetify's mid-level position suggests UI frameworks are important but secondary to core mechanics. The equal scores for Vue CLI and Nuxt.js indicate toolchain and SSR framework concerns are noticeable but not dominant. The small value for testing highlights a relative underemphasis in this representation, despite its role in reliability. From these patterns, we can conclude that, according to the visualized importance levels, mastering reactivity first, then state management and routing will yield the most impact, while component libraries, tooling, SSR frameworks, and testing remain relevant complementary areas to address. Now let's implement a new Vue.js project using Vue CLI. To create your project, you simply run the command that scaffolds a new Vue application. This command not only sets up the project structure, but also gives you the opportunity to configure various features like routing and state management right from the start. After executing the command, you will be guided through a series of prompts, allowing you to select the specific features you wish to incorporate, ensuring the project aligns with your requirements. Once your project is created, it's time to get it running with a built-in development server. This enables you to see your application in real time as you develop. By navigating into your project directory and running the appropriate command, your application gets compiled and served locally. The development server provides immediate feedback, allowing you to see changes as you make them. This setup greatly enhances your workflow, making the development process faster and more efficient, as you can iterate quickly and address issues on the fly. Next, we will implement the necessary setup for testing our Vue components using Vue testutils and Jest. To do this, we first need to install the required packages, specifically Vue testutils and Jest, which are essential tools that streamline the testing process. By running the installation command, we ensure that our development environment is equipped for effective component testing. Now let's take a look at a simple test case to verify that a Vue component renders correctly. In this example, we will import the shallow mount function from Vue testutils and the component we want to test, myComponent. We begin by creating a test suite using the describe function, where we outline the tests for our component. Within this suite, we write an individual test case using the it function to describe what we aim to validate, specifically, that the component correctly renders a specified message. Inside this test, we utilize shallow mount to create a wrapper instance of myComponent, allowing us to simulate its behavior without rendering child components. Finally, we assert that the rendered text within the component matches the expected output. This approach not only helps confirm that the component works as intended, but also safeguards against future changes that may inadvertently break its functionality. Writing such tests early on fosters a culture of quality and reliability in our code base. Next, we will create a new Nuxt.js application to explore its features and capabilities. To begin, we use the command npx create nuxtapp mynuxtapp, which scaffolds a new Nuxt project with a predefined structure, making it easy to start building our application right away. Once the setup is complete, you will notice that the folder structure of the project promotes a clear organization of your code, adhering to best practices. Now let's implement a simple page within our Nuxt application. By creating a Vue file in the Pages directory, we can define our component that will be directly routable without additional configuration. For instance, in our template, we can add a div containing an h1 tag with a welcome message. This automatic routing feature stems from Nuxt's convention over configuration philosophy, allowing us to focus more on building features rather than managing routes manually. This simplifies the development process, especially when dealing with larger applications. Moreover, utilizing Nuxt.js provides built-in support for server-side rendering, which enhances the app's performance and SEO, making it an excellent choice for developers looking to elevate their Vue.js applications to the next level. In summary, we explored various components of the Vue.js ecosystem, including Vue Router for navigation, Vuex for state management, Vuetify for UI design, the powerful Vue CLI for project setup, testing tools, and Nuxt.js for server-side rendering. Each of these elements plays a critical role in building effective and efficient Vue applications. Empowered with this knowledge, you can confidently embark on your Vue.js development journey, creating applications that offer excellent user experiences. So let's grab our coding hats, get out there, and build something amazing with Vue.js. In this lesson, we will delve into advanced Vue.js component design patterns, specifically focusing on the powerful concept of single-file components. Single-file components are an integral part of the Vue.js philosophy, combining template, script, and styling in one cohesive file for better organization, readability, and maintainability of code. So far, we learned about the key components of the Vue.js ecosystem, including its reactivity system, which ensures seamless UI updates, and Vue Router, which facilitates single-page application navigation. We also explored state management with Vuex, allowing for centralized control of application state, along with the use of Vuetify for UI component design. Additionally, we touched on the importance of Vue CLI for project setup and the testing capabilities integrated within Vue, culminating in a powerful framework for building high-performance applications. This foundational knowledge equips developers to effectively create and manage scalable Vue.js applications. Now let's see how we can implement a basic greeting component using single-file components in Vue.js. The structure consists of a template, script, and style. In the template section, we define the HTML structure of our component, which includes a div containing an h1 element to display our message and an input field that allows users to dynamically update this message using Vue's two-way data binding with vModel. In the script section, we declare the component logic utilizing TypeScript for improved type safety. Specifically, we define a data function that returns an object containing our message, initialized with the text "Hello, Vue.js." This encapsulation keeps our logic organized and clearly linked to the UI. Finally, the style block holds scoped CSS that applies specifically to this component, ensuring that the styles we apply do not leak into other components. Here, we set the color of the greeting text to blue. This modular approach not only enhances readability and maintainability, but also allows multiple developers to work efficiently without conflicts. Now let's see how we can enhance our component by leveraging TypeScript for improved type safety. We start by importing the defineComponent function from Vue, which allows us to define our component in a more type-safe manner. In the data option, we explicitly define the return type of our data method as an object containing a message property of type string. This ensures that the message is always a string, helping to minimize potential runtime errors arising from type mismatches. Next, we initialize our message property with a greetful string, "Hello Vue" with TypeScript. By doing this, we not only make our intention clear to others reading the code, but also take advantage of TypeScript's tools that support better development practices, such as IntelliSense in IDEs. Finally, this structured approach makes it easier to maintain and extend the component in the future, as we have established rigor around the types we're using. In tandem with tools like EaseLint and Prettier, this can significantly enhance the quality and consistency of our code across the project. Now let's take a look at the button component that we can create to demonstrate the use of props and event emissions in Vue.js. This component will accept a prop called label, which is defined as a required string. This prop allows us to customize the button text when it is used in a parent component. In the template section, we have a button element that uses the @click directive to bind the click event to the handleClick method. This method is crucial as it captures the click action and emits a button-clicked event to notify the parent component of this action. By declaring the emits option with our custom event, we ensure that our component communicates effectively with its parent. Next, we see how this button component can be used within a parent component. Here, we import the custom button and listen for the button-clicked event using the @shorthand. This method enables the parent to react to the button click, showcasing the parent-child communication pattern. By structuring components this way, we foster a reusable design that simplifies component integration while enhancing maintainability. Now let's examine how to create a flexible card component using slots. In this code, we begin with a template that defines the structure of our card. The div element serves as the card's container, and within it we have three key parts: a header, a body, and a footer. Each of these sections features a slot element, which acts as a placeholder for external content. By using named slots for the header and footer, we enable other components to inject their own specific content into these areas, while the body slot remains unnamed for flexible content insertion. Next, we define the script section in TypeScript, where we import defineComponent from Vue, creating a basic component without added logic, as this card's primary purpose is to serve as a layout structure. In the style section, we introduce scoped styles to ensure that our card remains visually distinct, applying borders and padding while enhancing the header and footer's prominence. Now let's see how this card component can be utilized within a parent component. Inside the parent component's template, we demonstrate how to provide custom content for each of the card's slots, showcasing the card's reusability and adaptability for various applications. This approach enhances the component's flexibility, allowing developers to craft tailored user interfaces efficiently. Now let's see how we can implement our updated greeting component using the Composition API. In this implementation, we start with a template section that establishes the structure of our component, displaying a greeting message and providing an input field that allows users to modify that message interactively. The setup function plays a crucial role here. It's the entry point for our component's logic and state. Inside setup, we utilize the ref method from Vue's Composition API to create a reactive property called message, initialized with a greeting string. This makes it possible to track changes to message automatically, ensuring that the UI updates in real time as users interact with the input field. By returning the message variable from setup, we make it accessible in our template, enhancing data binding between the UI and the underlying reactive state. This structured approach not only improves code readability, but also fosters better organization of complex logic, allowing for enhanced maintainability and reusability across components. Finally, in the scoped style section, we define a green color for the greeting text, ensuring it stands out in the application's UI. Now let's see how we can implement a mixin in our Vue.js components. The code snippet begins with the creation of a file named logger_mixin.ts, where we define a mixin called logger_mixin. This mixin includes a lifecycle hook, specifically the mounted method, which executes whenever a component using this mixin is mounted to the DOM. Within this method, we utilize console.log to output a message that includes the name of the component, accessible through this $options name. This approach provides valuable feedback in the console, helping developers track component lifecycle events effectively. Next, we integrate this mixin into an example component called example component. By importing logger_mixin and including it in the mixin's array of the component's options, we allow example component to inherit the functionality defined within the mixin. Consequently, every time example component is mounted, it will trigger the console log from logger_mixin, demonstrating how mixins can encapsulate and reuse common functionality. This powerful feature promotes more maintainable code, although it is essential to use mixins judiciously to avoid potential complications in larger applications. Now let's take a look at an example of an organized file structure for a Vue.js application. As your application grows, maintaining a logical folder structure becomes crucial for managing your components, views, and mixins effectively. In this setup, you can see that we have a components folder housing all reusable components such as card view, custom button view, and example component view. This helps keep your UI logic separate from page logic. We can also observe a views folder, which contains various pages like home view and profile view, representing distinct sections of your application. Grouping components by functionality makes it easier for developers to navigate the code and understand the purpose of each file at a glance. Additionally, the mixins folder is dedicated to keeping shared functionality tidy, which enhances the overall code legibility and maintainability. By adhering to such a structured approach and using consistent naming conventions for your components and props, you establish a clear and collaborative coding environment that supports scalability and efficiency, especially when multiple developers are contributing to the project. Through this lesson, we've examined the advanced Vue.js component design patterns, emphasizing the use of single file components. From understanding the structure of SFCs to utilizing TypeScript for enhanced type safety, mastering props, events, slots, and the composition API allows for versatile and reusable components. Mixins and thoughtful file organization further contribute to maintaining clean and maintainable code. By applying these design patterns and best practices in your own projects, you're well on your way to creating robust Vue.js applications that are not only powerful but also enjoyable to manage and scale. Remember, the goal is to break down complexity and build components that are easy to read, maintain, and reuse. Now go ahead and start applying these concepts to your Vue projects, making your development journey both efficient and fun. Welcome everyone. Today we're diving into best practices for Vue.js development. This will be an essential guide as you strive to write clean, efficient, and maintainable code in your Vue applications. So far, we learned about advanced Vue.js component design patterns, particularly the use of single file components, SFCs, that integrate template, script, and styling for better code organization and maintainability. We explored the reactivity system, Vue router, Vuex for state management, and the composition API, which enhances code flexibility and reusability. Additionally, we discussed the significance of props, events, and slots for component communication and customization, along with the use of mixins and best practices for file organization. This foundational knowledge equips developers to create scalable, maintainable, and efficient Vue.js applications. Now, we will cover best practices that ensure you maximize these tools and concepts in your everyday development. Let's begin with setting up your Vue project correctly. The first step is to make sure you have all the required dependencies installed. Keeping your dev environment tidy and organized is key. Navigate into your project folder and kickstart the dependency installation by running npm install. This will ensure that you have all the necessary packages to make your Vue application run smoothly. It's like gathering all your tools before starting any DIY project. Having everything at hand saves time and stress later on. Now let's take a look at how to structure your Vue.js application for optimal organization and maintainability. A solid file structure is essential, and it's common to create designated folders for different parts of your application. This helps not only in navigating your project, but also in collaborating with teammates effectively. Next, we will write the following directory structure. Within the components folder, you'll have your Vue components like button view, modal view, and navbar view, each encapsulating their own template, script, and styles within a single file component, SFC. Then in the views directory, you can place your main application views such as home, view, and profile view. The store folder will hold your state management logic using Vuex, centralized for easy access to shared data across components. Additionally, the mixins folder provides reusable code snippets that can enhance multiple components. Lastly, adding an assets directory to store images and styles further consolidates your assets. This structure not only keeps your application organized, but also aligns with best practices in Vue.js development, making it easier to maintain and expand your application as needed. The displayed horizontal bar chart titled Best Practices for Vue.js Vue.js development presents 7 categories with explicit numeric importance levels. Organized file structure 30, effective props usage 25, state management 20, utilizing composition API 15, testing 5, error handling 3, and documentation 2. The values show a clear ranking. Organized file structure is rated highest, followed by effective props usage and state management, with utilizing composition API trailing them but still substantial. The top 4 categories collectively account for 90 of the total importance points, indicating that the primary emphasis should be on structure, props, state management, and using the composition API. In contrast, testing, error handling, and documentation receive much smaller shares, 5, 3, and 2 respectively, highlighting a steep drop in assigned importance for these support areas. The numeric labels on each bar make the gaps explicit. For example, the 5-point difference between the top 2 items and the pronounced decline from utilizing composition API 15 to testing 5, which suggests allocating team effort and learning focus proportionally. Prioritize organizing files, enforcing effective props usage and robust state patterns, and applying the composition API first, while still planning resources for testing, error handling, and documentation, given their lower but non-zero importance. Now let's take a look at how to create a reusable modal component within Vue using a single file component structure. We begin with the template section, which defines the HTML that will be rendered in the browser. Here we have a simple div with a class of modal that contains an h2 tag displaying the text. This is a modal. This structure allows for a clear presentation of the modal's content. Next, we move to the script section where we import define component from Vue. This function is essential for creating our component. By defining the component and giving it a name property set to modal, we establish a unique identifier that helps in both development and debugging. Naming components is crucial for clarity and consistency in large applications. Lastly, the style section is scoped, meaning the styles defined here will only apply to this modal component, preventing any conflicts with styles from other components. We've added basic styling to ensure the modal is displayed as a block element with a white background. This encapsulated approach enhances maintainability and organization, making it simpler to manage styles and functionality in Vue applications. Next, we will write the user card component to illustrate effective props usage in Vue.js. This component is structured as a single file component SFC, containing template, script, and style sections, which promotes better organization. In the template section, we display the user's name and email by binding to the user prop. This demonstrates how props facilitate the transfer of data from parent to child components, enhancing reusability. In the script section, we define the component using define component from Vue, giving it the name user card. This enhances clarity in debugging. Now let's focus on the critical part, prop validation. We specify that the user prop must be an object and is required for the component to function correctly. This validation step is essential, especially in TypeScript, as it ensures that the parent component always passes the required data. By enforcing these rules, we enhance the component's stability and reliability. Finally, in the style section, we use scoped styling to apply specific styles to the user card class, ensuring the styles do not affect other components. This encapsulation is another best practice in maintaining styles within Vue components. Now let's take a look at how to establish a Vuex store for effective state management in our Vue application. First, we import the createStore function from Vuex in the user module, which contains our user-related state and behaviors. By calling createStore, we set up a centralized store that houses all modules we create. In this case, we include the user module. Next, we'll define our user module in its own file. Here, we establish a state object that holds user properties such as name and email. This encapsulation allows us to manage user-related data neatly. We then implement mutations, which are synchronous functions to directly modify state. The setUser mutation updates the name and email based on the payload received. Moreover, we introduce actions that commit these mutations. The updateUser action is responsible for triggering the setUser mutation, ensuring that the state is updated when user data changes. Finally, we set up getters to access the user state from components, facilitating easy data retrieval. By organizing the store this way, we enhance maintainability and scalability as our application grows. Now let's take a look at how we can create a reusable composition function for fetching data. In this example, we define a function called useFetch, which takes a URL as an argument. Utilizing Vue's ref from the composition API, we declare two reactive references, one for storing the fetched data and another for capturing any errors that may occur during the fetching process. Inside the function, we implement fetchData, an asynchronous method that attempts to retrieve data from the provided URL. If the fetch operation is successful, the response is converted to JSON and assigned to the data ref. If any error arises, it will be caught and stored in the error ref. Next, we will implement this useFetch function in our Vue component. By importing the useFetch function and calling it with the desired API endpoint, we set up the necessary data retrieval process within the setup function. Using the on-mounted lifecycle hook, we trigger the fetchData function to fetch the data automatically when the component mounts. This modular approach keeps our component logic clean and focused, promoting better reusability across different components while maintaining organized code. Now let's implement a template that effectively handles errors during data fetching. This code snippet showcases a Vue component that utilizes conditional rendering to provide user feedback based on the state of data retrieval. We check if there is an error. If so, a message is displayed to inform the user about the loading issue, utilizing error message for context. This approach ensures that users are not left in confusion if something goes wrong. Next, we introduce another condition that checks whether the data has been successfully loaded. If the data is available, a success message is shown, along with a placeholder for rendering the actual data. This dual check mechanism enhances user experience by keeping them informed about what's happening, reinforcing the importance of responsive feedback in applications. By incorporating this error handling structure within the component, we ensure robust reporting of issues and create a more user-friendly application. Utilizing such techniques allows your Vue components to remain resilient and communicative, especially during asynchronous operations. Now let's see how we can implement a basic unit test for the user card component. This testing setup begins by importing necessary modules, specifically mount from @vue/testutils and our user card component. These imports are crucial as they provide the tools needed to render the component in a controlled testing environment. Next, we define a describe block which serves as a container for our tests related to user card Vue. Inside this block, we establish an individual test case using the it function, where we specify what we are testing. Here, we're focusing on verifying that the component correctly renders the user's name and email when provided as props. To perform the test, we create a sample user object containing a name and an email. Using the mount function, we render the user card component, passing the user object as props. This allows us to simulate how the component functions with actual data. Finally, the test employs expect statements to assert that the rendered output contains the correct user name and email, ensuring that our user card behaves as expected. This straightforward yet essential testing process helps maintain confidence in the integrity of our components. As we wrap up, remember that maintaining best practices goes beyond writing code. It encompasses understanding how to make your application scalable, maintainable, and enjoyable to work with. Keep your files organized, utilize props effectively, capitalize on Vuex for state management, and embrace the composition API for maximum flexibility. Prioritize error handling and implement unit tests to safeguard your work. These best practices are not merely suggestions but essential components in your journey to becoming a proficient Vue.js developer. By adhering to them, you're making your applications not just functional, but great to work on, both individually and collaboratively. Now go ahead and put these best practices into action, and watch as your development experience transforms into something much more enjoyable. Happy coding! Creating a Vue.js component is an exciting step in developing dynamic web applications. Today, we're going to dive into the creation of your very first Vue.js component and see how it fits neatly into our application. So far, we learned about advanced Vue.js development practices, emphasizing organized file structure, effective use of props, and state management with Vuex. We also focused on utilizing the composition API for improved code flexibility and on implementing robust error handling and testing routines. Now we will cover how to create a functional component in Vue.js, bringing your knowledge to life with code examples and practical explaining along the way. Now let's take a look at how we define the Hello World component in Vue.js. We start with the template section where we build the HTML structure for our component. Here we create a div that contains an h1 element, which will dynamically display a message using Vue's interpolation syntax, message. This allows the message to be bound to data defined in the component's JavaScript section. Next, in the script section, we import define component from Vue and utilize it to define our component. The export default statement lets Vue know that this object is the component definition. We set the component's name as Hello World and define its state in the data function. This function returns an object that encapsulates the message we aim to display, initializing it with the text Hello Vue.js. Finally, we style our component within the style section, applying styles specifically to h1. The scoped attribute ensures that these styles are limited to the Hello World component, preventing potential conflicts with styles from other parts of the application. This setup demonstrates a clean and organized approach to defining Vue components. The figure displays a bar chart titled Key Concepts in Vue.js Component Development with 4 labeled bars showing importance levels: components at 80, props at 70, state management at 90, and composition API at 85 on a 0-100 scale. From the plotted values, we can observe that state management is rated highest, indicating that centralized state, for example via Vuex or equivalent patterns, is considered the most critical concept in component development. The composition API is also rated very highly, 85, slightly below state management, which suggests a strong emphasis on modern composition-based patterns for organizing logic and improving reusability. Components themselves are important, 80, confirming that encapsulation and reusable UI units remain foundational. Props, while still significant at 70, have a lower value relative to the other concepts, implying that while passing data is essential, it is considered somewhat less influential than managing shared state or adopting composition patterns. The visual pattern, a clear peak at state management, a secondary peak at composition API, and slightly lower values for components and props, supports the conclusion that priorities in component development should be: ensure robust state management first, adopt the composition API for flexible and composable logic, and then focus on component structure and prop-driven interfaces to connect pieces together. Now that we have our Vue.js component structured, let's take a closer look at how to enhance it with props. First, we start with a template that includes a simple div housing an h1 element. This element's content will be dynamically determined by the greeting prop we'll define next. Next, let's implement the script section where we import the define component function from Vue. This function allows us to create our component efficiently. Within the export default, we specify the component name and define a props object. This object includes a property called greeting, which is typed as a string and has a default value of hello Vue.js. This feature ensures that the component can still function interactively, even when a value isn't provided by the parent component. Finally, let's add some styling to the h1 element, applying a scoped style that sets its color. This scoped attribute guarantees that our styles won't leak out to other components, maintaining visual consistency. By following this structure, our component becomes more reusable and flexible, allowing the parent component to customize the greeting dynamically. Next, we will implement a more interactive feature in our Hello World Vue component by incorporating an input field that allows users to dynamically change the greeting message. To achieve this, we'll use the vModel directive, which establishes a two-way data binding between the input element and the greeting prop. This means that any text entered into the input box will be instantly mirrored in the h1 element that displays the greeting. We begin by updating the template section to include an input element with the vModel directive bound to greeting, alongside the heading that shows the greeting message. Now, further down in the component script, we notice that the greeting prop is defined, complete with a default value. This allows the prop to accept an external greeting message, enhancing the versatility of our component. Any parent component can now pass a custom greeting, making our Hello World component both interactive and reusable. By typing into the input field, users can see their changes reflected in real time, showcasing the power of Vue.js for building dynamic user interfaces. As we conclude our tutorial on creating your first Vue.js component, it's worth noting that components can be as simple or as complex as your application needs them to be. They can manage state, handle events, and even include lifecycle hooks to run code at specific times during the component's existence. We've covered the creation of a basic component with a template, scripts, and styles. We then moved on to utilizing props for injecting data into our components and added interactivity through input fields and two-way data binding. This foundation will serve you well as you build out more complex and feature-rich components in your Vue.js applications. Remember, the key to mastering Vue.js components is practice. Experiment with different structures, data types, and interactions. The more you explore, the deeper your understanding will grow. Thanks for joining me today, and I look forward to seeing what you create with Vue.js. In today's lesson, we're diving into an essential tool for any Vue.js developer, the Vue.js Devtools. This powerful browser extension allows you to inspect and manipulate Vue components in real time, making debugging and learning about Vue.js applications a breeze. So far, we learned about the essential process of creating Vue.js components, focusing on their structure, organization, and integration into web applications. We explored advanced practices, including the utilization of the composition API, props for data passing, and two-way data binding for interactivity. Additionally, we emphasized the importance of components as self-contained units that simplify dynamic UI creation. This foundation equips you to build more complex and feature-rich components in future lessons. Now, we will cover how to leverage the Vue.js Devtools to enhance your development workflow and debug your applications efficiently. First off, let's talk about how to install the Vue.js Devtools. If you're a fan of Chrome, rejoice. The Devtools are available as an extension for both Chrome and Firefox. For Chrome users, head to the Chrome Web Store, search for Vue.js Devtools, and simply click on Add to Chrome. For Firefox users, navigate to Mozilla's add-ons page and find the Vue Devtools. It's a straightforward process, and if you run into trouble, don't worry. Just follow the prompts and you'll be up and running in no time. Once installed, you'll see a cute little Vue.js icon in your toolbar, ready to help you unlock the secrets of your Vue applications. Now let's implement a simple counter component using the Vue.js framework. This component begins with a template where we present the title and a button that, when clicked, increments a count variable. The title is dynamically displayed using Vue's templating syntax, which means any change we make to the title or count in the underlying code will be reflected instantly in the UI. In the script section, we define the component. Using the composition API, we first import necessary functions from Vue. Here, we leverage ref to create reactive variables, title and count. The title holds a string for the display, while count is initialized to 0. We also define an increment function that directly modifies the count variable whenever the button is clicked. This functionality showcases Vue's reactivity, allowing us to interact with the application effortlessly. Finally, we return these variables and methods to make them accessible in the template. This approach not only organizes the component clearly, but also utilizes Vue's powerful reactivity model, making it ideal for implementing interactive features in your applications. The displayed figure titled Key Skills in Vue.js Development is a horizontal bar chart that quantifies the relative importance of 5 core concepts: installation 90, component structure 85, state management 80, debugging tools 75, and state monitoring 70. The x-axis runs from 0 to 100 and each bar is labeled with its numeric value, which allows for precise comparison. Key patterns include a clear descending order from installation down to state monitoring, with consistent 5-point drops between most adjacent items: 90 right arrow 85, right arrow 80, right arrow 75, right arrow 70. This pattern indicates a cluster of high-priority skills rather than a single outlier. All 5 concepts fall within a narrow high-importance band, 70-90, suggesting that a well-rounded developer should be competent across installation setup, component architecture, state handling, debugging practices, and monitoring. From this data, we can draw actionable conclusions for learning priorities. Begin with ensuring correct installation and tooling, then focus on component structure and state management as core development skills, and finally emphasize debugging and state monitoring practices to maintain and optimize applications. The explicit numeric labels make it easy to see that while installation leads slightly, no single skill is negligible. Each contributes materially to effective Vue.js development. Now let's implement Vuex, Vue's state management library, to enhance our state management capabilities in the application. First, we need to install Vuex via npm, which adds the library to our project. This step is vital for setting up a centralized store to manage state across our components. Next, we will configure a store in our Vue application. In this store, we define an initial state containing a count property set to 0, representing our counter's starting point. We also create a mutation named increment, which updates the state by increasing the count by 1. This mutation is crucial as it encapsulates the logic for manipulating the state in a structured manner. After setting up the store, we will integrate it into our main Vue instance. This involves importing the store and using it with the createApp method, ensuring that every component within our application has access to the state being managed by Vuex. Finally, we will adapt our counter component to utilize this Vuex store. In the setup function, instead of managing state locally, we will retrieve the count from the store. Moreover, we will modify the increment function to commit the increment mutation, demonstrating how to trigger state changes from within our component. This approach not only centralizes state management, but also makes our application more scalable and maintainable. After you integrate Vuex and use the Devtools to inspect your application, you'll notice an additional Vuex tab in the Devtools interface. This allows you to see the state and commit history of your Vuex store. You can view the current state, and more importantly, you can see how the state changes over time as you commit mutations. Whenever you click the increment button, the store's state updates. If you open the Vuex tab in the Devtools after each action, you will observe an updated state. You can even go back to see previous states, which helps you understand how your application responded to each action. It's like having a time machine at your fingertips. How cool is that? Now let's take a look at how to inspect and modify props and data within Vue components. This feature allows you to become a master of your domain, or should I say your application. The Devtools let you modify the component state on the fly, giving you a great opportunity to experiment with different values and observe how your UI adapts. Return to your counter component. Suppose you want to test what happens when you change the title directly from the Devtools. Click on the component in the components tree and you'll see all its reactive properties listed. Just like magic, you can double-click on the title property and change it directly. Type something radical like ultimate counter, and watch as your component immediately reflects this change. This ability to directly manipulate component state is beneficial during development. It helps you verify your logic without needing to rerun your application or make code changes. You can also test various scenarios quickly, especially beneficial when working with user-provided data or dynamic states. Now let's implement a simple event handler for our counter component to log the current count each time the increment button is clicked. This function starts by invoking a mutation on the Vuex store to update the state. Specifically, it calls store commit increment. This mutation is responsible for updating the count value in the store, ensuring that our application state remains in sync with the user's interaction. Following the state update, we use a template literal to log the current count to the console. The expression console log current count, store state count, retrieves the updated count from the store state and displays it, providing immediate feedback in the console. Consequently, each time the button is clicked, not only does the count increase, but we also gain a clear view of the current state through the console log. This mechanism allows us to track state changes and understand how user interactions affect our application flow, which is invaluable for debugging and monitoring component behavior. Observing these events in the Vue.js Devtools will enhance our understanding of application dynamics as well. Now let's touch on another fantastic feature of Vue.js Devtools, the performance monitoring capabilities. As your application expands, tracking performance becomes crucial. In the Performance tab, you can monitor component re-renders, response times, and various performance metrics. To utilize this functionality, you can enable performance recording while interacting with your components. Simply open the Performance tab and click on Start Recording. As you interact with your app, the Devtools will record rendering performance data, allowing you to test different interactions and see how they impact performance. For instance, let's conduct a performance review while clicking through the counter component. You could analyze how changing the count affects render times. This can be super helpful in identifying bottlenecks in your code or unnecessary re-renders. As we continue expanding our tools and techniques, remember that the Vue.js Devtools assist not just in debugging, but also in learning. As you're navigating through your application, the insights it provides can deepen your understanding of how Vue's reactivity system works. It's a visual guide to seeing what's happening behind the scenes. Consider taking small projects and playing around with the Devtools features. Change props, test mutations with Vuex, and learn how your data flows. The more time you spend in Devtools, the better you'll know your application and Vue in general. Finally, let's address the subject of community and support. As with any tool, you may encounter issues or have questions regarding the Vue.js Devtools. Fortunately, the vibrant Vue community online is incredibly helpful. Platforms such as Vue's official forum, Discord, and Stack Overflow have dedicated communities ready to jump in and assist you. If you run into bugs or potential improvements with the Devtools themselves, don't hesitate to report these directly on the GitHub repository for Vue Devtools. The maintainers are usually quite responsive, and user feedback is crucial for continuous improvement. As we wrap up this lesson, I hope you feel empowered to take full advantage of the Vue.js Devtools. They've opened up a whole new world of inspecting, debugging, and optimizing your applications. By using these tools actively in your development cycles, you'll enhance your productivity and grasp of Vue.js. Next time you start a new Vue project, remember to install and open the Devtools right away. Who knows, you might discover something cool that improves your application's performance or helps you write cleaner code. Thank you for joining me today. Keep experimenting, keep coding, and I'll see you in the next lesson. In this session, we will enhance our application interactivity using Vue.js by exploring key concepts like reactivity and how to inspect our applications with official tools. So far, we learned about the Vue.js Devtools, a crucial tool for inspecting and debugging Vue.js applications in real time. We covered how to install the extension, utilize its various features such as monitoring state changes, modifying component data, tracking events, and recording performance. Additionally, we emphasized the importance of engaging with the vibrant Vue community for support and feedback. This knowledge empowers you to enhance your development workflow and optimize your applications effectively. Now let's dive into enhancing interactivity in Vue.js applications, an exciting topic that opens up endless possibilities. Now let's take a look at how we can implement a simple Vue component to manage a count variable with reactivity. We start by using the template tag to define our HTML structure, showcasing the current count and providing buttons to increment it. Inside the script section, we first import the necessary functions from Vue, specifically defineComponent and ref. Next, we define our component using defineComponent, providing a setup function where the magic happens. Within this function, we declare a reactive variable called count, initialized with ref0, setting its starting value to 0. The increment function allows us to increase count by 1 each time the button is clicked, demonstrating Vue's powerful reactivity system, as any changes to count will immediately update the UI. Finally, we return count and increment from the setup function, making them accessible to our template. This straightforward structure effectively illustrates the principles of reactivity, ensuring that the user interface remains in sync with the underlying data model. Now that we have a grasp on reactivity, let's implement computed properties to enhance our counterexample. We begin by introducing the computed function, which allows us to create a reactive property called countMessage. This property dynamically checks the current value of count to determine if it is even or odd, returning the appropriate string. Next, we'll set up a simple template structure where we display the current count in an h1 tag and the count message in an h2 tag. This structure ensures our template remains clean and efficient, allowing Vue to manage DOM updates seamlessly as count changes. The inclusion of a button that increments the counter when clicked is straightforward. It triggers the increment method, which increases the count variable. As a result, each time the button is pressed, both the counter display and the corresponding message of even or odd will update automatically. This showcases the power of computed properties in reducing redundancy in our code while maintaining optimal performance. This implementation not only enhances user experience by providing real-time feedback, but also exemplifies clean coding practices within the Vue framework. The donut chart summarizes the relative importance assigned to 6 key concepts for improving Vue.js interactivity: reactivity 95%, computed properties 90%, event handling 85%, watchers 80%, state management 75%, and forms 70%. The chart makes clear that reactivity is considered the top priority, with a marginal lead over computed properties. Together, these two dominate the largest portions of the donut, indicating that ensuring reactive data flows and efficient derived state should be the primary focus. Event handling and watchers form the mid-tier priorities, closely grouped 85% and 80%, which suggests a need to invest in robust user interaction handling and side effect management next. State management 75% and forms 70% occupy the smaller but still substantial segments, signaling they are essential for full-featured applications but secondary to the core reactive and computed foundations. From these proportions, we can conclude a recommended roadmap. First, solidify reactivity and computed optimizations, then strengthen event handling and watchers for interaction complexity, and finally integrate scalable state management and user input handling to complete a resilient interactive application stack. Now let's implement an enhanced version of our counter application by adding a reset button. This functionality allows users to reset the count back to 0, improving interactivity within the application. We begin by updating our template to include a second button with an event listener. It uses the @click directive to trigger the reset method when clicked. Next, we move to the script section where we define the reset function. This function is straightforward. It simply sets the count variable back to 0. This highlights how event handling in Vue.js is powerful. Every click on the reset button triggers a state change, making our application more dynamic. Additionally, we still have the increment function, which increases the count when its corresponding button is clicked, and we utilize a computed property called countMessage to indicate whether the count is odd or even. Each interaction is seamlessly reflected in the user interface, showcasing the reactivity model of Vue.js where the UI remains in sync with our data model effortlessly. This structure encourages a more engaging user experience. Next, we will implement a watcher in our component that will respond to changes in the count variable. Watchers are particularly useful for executing side effects when a specific reactive property changes. Here, we are introducing a function that observes the count and prints a message to the console when it reaches 10. Now let's take a look at how we set this up. We first import the watch function from Vue alongside our other imports. In the setup function, we define the watch method and pass in the count variable and a callback function. This callback checks if the new value of count is exactly 10. If it is, we log a message indicating the count has reached that milestone. This showcases how you can create reactive responses to specific data changes, enhancing your application's interactivity and enabling side effects, such as triggering API calls or updating the UI based on certain thresholds. With this, you gain greater control over how your application behaves in response to user actions, making it more dynamic and engaging. Now let's implement the following feature to enhance user interaction by adding forms in our Vue.js application. We start by updating the template to include an input field that allows users to enter their name, binding it to the name variable using vModel. This beautiful two-way data binding means that as users type in the input field, the name property becomes reactive and automatically updates, giving a seamless experience when displaying the greeting. Additionally, the component showcases dynamic content by rendering a personalized greeting with hello, name, based on the user's input. To further enhance interactivity, we also maintain the counter functionality. The current count displayed using count reflects the state managed reactively within the component. The count is updated through an increment function triggered by a button click, while another button utilizes the reset function to set the count back to 0, showcasing the elegance of event handling. Lastly, a computed property calculates whether the count is even or odd, and this information is displayed dynamically, solidifying the interconnectedness of the component's state and UI. Now let's see how we can implement Vuex for state management in our application. Start by installing Vuex, which will provide us a centralized store for managing our application state, including the count we're tracking. Next, we will create a new store file where we define our state, mutations, and actions. In the store, we begin by declaring the state function that returns an object containing count, initializing it to 0. We then define two mutations, increment, which increases the count by 1, and reset, which sets it back to 0. This structure allows components to securely interact with the state. Now let's integrate this store into our Vue application. In the main entry file, we will import the store and register it with our application during the creation of the Vue instance, ensuring that all components have access to the Vuex store. Next, we will modify the counter component to utilize Vuex for state management. By using useStore, we can access the Vuex state within our setup function. The count will now be a computed property derived from the Vuex state. Finally, the increment and reset functions will commit mutations instead of directly modifying the state, demonstrating a scalable approach to state management as our application grows. As we wrap up our exploration of enhancing application interactivity with Vue.js, it's important to reflect on what we've learned. We've covered the core concepts of reactivity, computed properties, event handling, watchers, forms, and state management with Vuex. Engaging with your UI and keeping it interactive not only improves user experience, but also makes the application feel alive. Remember, the more reactive your application, the less code you have to write to handle data synchronization. So keep experimenting with these functionalities in your applications. The possibilities are almost endless when you leverage the full power of Vue.js interactivity. Feel free to share your bright ideas and engaging implementations with the community. Thanks for joining me today. Happy coding and stay creative. Now let's dive into exploring the Vue.js component structure. Understanding components is crucial for organizing your application effectively and managing its complexity. A well-structured component can lead to easier maintenance, better code reuse, and ultimately a more robust application. So far, we learned about enhancing interactivity in Vue.js applications through key concepts such as reactivity, computed properties, event handling, and state management with Vuex. We explored how reactivity allows automatic updates of the DOM as data changes and introduced computed properties for optimizing calculations based on reactive data. The session included practical examples like incrementing and resetting a count, as well as logging messages with watchers and binding input fields using forms. This foundational knowledge empowers developers to create dynamic and engaging user experiences while fostering better application management. Now we will talk about Vue.js component structure and how it helps in building scalable applications. Now let's take a look at the Hello World Vue component, which serves as a straightforward example of how Vue.js integrates its template, script, and style sections within a single file format. We begin in the template section where the HTML structure is defined. Here, the message interpolation demonstrates Vue's reactivity. Any changes to the message variable will automatically reflect in the DOM. This is further enhanced by a button with a click event handler at click equals change message, which allows interaction by invoking the change message method when clicked. Next, in the script section, we utilize TypeScript for type safety. The define component function provides a sleek way to create our component, while the setup function is central to the composition API. Inside this function, we declare a reactive variable message using Vue's ref function, initially set to a greeting. The change message function modifies this variable when the button is clicked, highlighting the dynamic nature of Vue's reactivity. Finally, in the style section, we apply scoped styles to the component, ensuring that the styles will only affect elements within this component, maintaining encapsulation and preventing unintended style leaks. Next, let's dissect each part of the Hello World Vue file. The template section is where you will write all your HTML markup. This part is strictly for displaying data and should not contain any JavaScript logic or behaviors. Transitioning into the script section, we notice the use of TypeScript for type safety and better developer experience. The define component function is imported from Vue, which aids in the creation of our component in a TypeScript-friendly environment. Inside the setup function, we define our reactive data using the ref function. This is an important aspect of Vue 3's composition API, enabling more organized and encapsulated logic. The change message method is a simple function that modifies our message data property upon the button click. Whenever the button is clicked, Vue's reactivity ensures that all dependent templates are updated in real time, enhancing user experience. Now, apart from the basic structure, we can discuss the organization of components. Typically, components can be categorized into 1. Presentational components *. These components focus purely on how things look. They receive data via props and emit events to communicate with parent components. A great use case for presentational components would be for UI elements that are reused across different views. 2 container components asterisk. These components manage state and behavior. They encapsulate the logic and hold data that might need to be passed down to various presentational components. It's all about maintaining data flow in your applications and orchestrating how your components interact with one another. The displayed figure titled Vue.js Component Structure Overview is a bar chart that quantifies usage counts for 4 component types: presentational 40, container 60, reusable 30, and state management 50. The key pattern is that container components have the highest usage count at 60, indicating they play the largest role in the measured applications, followed by state management at 50. Presentational components sit in the middle with a count of 40, while reusable components register the lowest count at 30. From these values, we can conclude that application structure in this sample emphasizes components responsible for orchestrating logic and managing state, container, and state management, while presentation and modular reuse are present but less dominant. This suggests prioritizing clear separation of concerns and robust state handling in component design, while also identifying an opportunity to increase investment in reusable components to improve consistency and reduce duplication across the codebase. Now let's take a look at the implementation of the user card view component, which serves as a presentational component. In the template section, we define the layout, which includes a user's name and email, displayed dynamically using the user prop passed into the component. The button labeled Send Message is linked to a method called Send Message, which we will implement to manage user interactions. Next, we implement the script section, where we declare the component using defineComponent from Vue. The component expects a user prop of type object, ensuring that any parent component passing data conforms to this structure. This validation is crucial for maintaining data integrity. In the methods section, we define the sendMessage function, which is triggered when the button is clicked. This function emits a message sent event along with the user's ID, allowing the parent component to capture this event and react accordingly. This use of event emission exemplifies Vue's principles of keeping concerns separate, enhancing reusability, and promoting a neat data flow between the presentational and container components. Finally, the scoped styles enhance the visual appearance of the user card, keeping it visually distinct and engaging. Now let's implement the user list Vue container component, which is responsible for managing a list of users and rendering multiple user card components. First, we define the template section, where the user card component is used within a v-for loop. This directive allows us to iterate over the user's array, rendering a user card for each user object while maintaining a unique key attribute for each instance, which is crucial for performance and tracking changes. Next, in the script section, we import necessary functionalities from Vue and the user card component. Inside the setup function, we declare the user's reactive variable using the ref function, containing an array of user objects. This ensures that any changes to users will reactively update the DOM. Additionally, we define a handle message sent method that will execute when a message is sent from a user card. This method receives the user's ID as an argument and logs a message to the console. Finally, we return the users and handle message sent from the setup function, making them available to the template and enabling proper interaction between the container and child components. Now let's see how we can use lifecycle hooks within a Vue component to manage its various stages. In this logging component, we define several lifecycle hooks such as before create, created, mounted, and before destroy, each designed to execute specific code at different moments during the component's lifecycle. The before create hook runs right before the component instance is created, allowing us to trigger actions or log messages prior to its initialization. As the component is created, the created hook follows, which can be useful for any setup logic that doesn't require the component to be mounted yet, making it ideal for initiating data fetching. Once the component is actually displayed on the screen, the mounted hook executes, indicating readiness for DOM manipulations. This is a great time to access the rendered elements if needed. Finally, before the component is destroyed, the before destroy hook allows us to clean up, such as canceling API requests or removing event listeners, ensuring we leave no loose ends behind. Collectively, these hooks provide a powerful mechanism for precise control over component behavior during its existence. Now let's take a look at how we can implement a reusable modal component using Vue slots. In this component, we define a basic structure that includes an overlay and content area. The overlay captures clicks to emit a close event, making the modal dismissible by the parent component. Within the content area, we include two slots, a named slot for the header and a default slot for the modal's main content. This allows parent components to customize what is displayed in those areas. Additionally, we have a button that, when clicked, will also emit a close event, ensuring the user can dismiss the modal easily. Next, we'll see how we can use this modal component in a parent component. In our parent component, we instantiate the modal and bind a close event to manipulate the show modal state, effectively controlling its visibility. Using the header slot, we can pass custom content for the modal title, and the default slot allows us to insert the main content, showcasing the flexibility of slots. This setup exemplifies how to harness Vue's capabilities to build components that are both modular and reusable, enhancing structure and maintainability in your applications. As we wrap up our exploration of Vue.js component structure, it's significant to remember that organizing your components thoughtfully can lead to more manageable, maintainable, and scalable applications. Each component plays a vital role, whether it's for presenting data, handling business logic, or collaborating with other components through props, events, and slots. By understanding the component lifecycle, adopting the composition API with TypeScript, and utilizing best practices like creating presentational and container components, you'll be well equipped to structure your Vue applications effectively. In the next session, we will dive deeper into state management with Vuex, which will empower you to handle application-wide state efficiently. Until next time, keep coding and creating fantastic applications with Vue.js. In this video, we will dive into the Vue.js Devtools plugin, a powerful tool that allows you to inspect and manipulate Vue components while they are running in your browser. If you're developing Vue applications and are looking for ways to enhance your debugging experience, this is the tutorial for you. So far, we learned about the importance of Vue.js component structure in organizing applications and managing complexity. Components are the building blocks of Vue applications, enabling modular design with clear separation of concerns between presentational and container components. We explored how reactive data and event handling work within components, along with lifecycle hooks that allow for effective component management. Now we will cover how to utilize Vue.js Devtools for enhanced debugging, making our development process smoother and more efficient. Vue.js Devtools is like a supercharged magnifying glass into your Vue applications. It provides an interface that makes it easy to track down bugs, inspect component hierarchies, and even manipulate component data in real time. First, let's start with how to install the Devtools plugin in your browser. If you're using Chrome or Firefox, simply head to the extension store, search for Vue.js Devtools, and install it. Once installed, you will see a new tab named Vue when you inspect a page that runs a Vue application. Once you have the Devtools set up and running, let's take a look at what you can do with it. When you click on the Vue tab, you'll be greeted with a clear overview of your app's component hierarchy. On the left, you'll see a tree representation of all your Vue components. Selecting a component here will allow you to explore its properties in the right panel. You can see its data, computed properties, methods, and even its emitted events. This is invaluable as it allows you to quickly assess the state of your application. The displayed figure titled Utilizing Vue.js Devtools for Enhanced Debugging is a horizontal bar chart that ranks 5 Devtools features by usage count: component inspection 70, state management 65, event tracking 50, performance monitoring 40, and routing inspection 55. Key patterns are clear. Component inspection is the most used feature, narrowly ahead of state management, a 5-point gap, indicating developers most frequently inspect component internals and local state. Routing inspection and event tracking occupy the middle range, 55 and 50 respectively, showing moderate use for tracing navigation and emitted events, while performance monitoring is the least used at 40, suggesting profiling is performed less often. From these values, we can conclude that day-to-day debugging is dominated by component and state-level inspections, whereas performance analysis is a less frequent but critical activity when issues arise. The numeric spreads highlight where teams may prioritize training or integrate Devtools workflows, for example, investing small effort to raise routine performance checks and ensuring robust practices around component inspection and state management, since they are the most relied upon tools. Now let's see how we can implement a simple user profile component in Vue.js. This component utilizes the Vue Composition API, allowing us to define a reactive user object that holds the user's name and age, initialized with the values for Alice. The displayed template shows the user's name and age, providing a straightforward layout for user information. Next, we'll introduce a method called increaseAge, triggered by a button click. This function will increment Alice's age by 1 each time the button labeled Happy Birthday is pressed, showcasing Vue's reactivity. As users interact with the button, the displayed age will automatically update in real time, demonstrating the dynamic nature of Vue components. With this setup, we can easily visualize changes to the state without reloading the application, enhancing our debugging and testing capabilities. This component not only exemplifies basic interactivity in Vue, but also sets the stage for further exploration of component data manipulation using Vue.js Devtools. Let's now look at filtering and searching for components in Vue.js Devtools, which can significantly speed up your debugging process. In larger applications, tracking down a specific component can be challenging. Thankfully, the Devtools provide a quick search feature. Just click on the search bar at the top of the component tree view and type in the name of the component or any data property you wish to locate. This will filter out the results, allowing you to zoom in on the component you're interested in. For example, imagine your application has a nested component structure and you're looking for a user profile component that's deep within the hierarchy. Typing user profile into the search bar will quickly highlight that component in the tree. Not only does this save you time, but it also helps you understand how your components are laid out and connected. Now let's discuss the events section in Vue.js Devtools. This feature provides insight into all the events emitted by your components, helping you trace interactions and behaviors throughout your application. Each time an event is fired, it logs it in the events panel along with the component that emitted it. Being able to see a timeline of events can be incredibly useful when you're trying to debug complex interactions, especially when dealing with user inputs or API calls. Continuing with our earlier example, if you added an event that triggers some behavior whenever the Happy Birthday button is clicked, you would find that event logged in the Devtools. You can click on the event to see its details, including any payload it carries. This clarity helps ensure that your components are emitting the expected events at the right times. Next, I want to highlight the performance monitoring tools that Vue.js Devtools offers. The Performance tab allows you to analyze the rendering performance of your components. This is particularly helpful for optimizing your app's performance, especially in cases where you have complex computations or operations that may slow down rendering. When you click on the Performance tab, you can start a performance recording. As you interact with your application, the Devtools will track each rendering instance, showing you how long it took for each component to render. If you notice a specific component is taking an unusually long time to render, it's a red flag. Talking about our user profile component, if it were nested in multiple layers and causing delays, Devtools would make it clearer for you. You could then dig deeper into that component's logic to find optimizations. Now let's implement a computed property to our user profile component that calculates the user's birthday based on their current age. In the setup function, we first create a user object using the ref function, initializing it with a name and age. To manage the user's age, we add an increaseAge method that increments the age by 1 whenever the button is clicked, simulating a birthday celebration. Next, we introduce the computed property, birthday year. This property uses the computed function to derive the year when the user will turn 100 years old. It calculates the current year using JavaScript's date object and adds the difference between 100 and the user's current age. This dynamic calculation allows our component to display the future birthday year in the template seamlessly. Lastly, we return the user object, the increaseAge method, and the birthday year computed property within the setup function, making them available for use in our template. By incorporating this computed property, we enhance the functionality of our user profile component while demonstrating how to manage and manipulate state reactively within a Vue application, enriching our debugging experience in the Vue.js Devtools. Next, we will implement a router configuration for our Vue application, focusing on how to set up dynamic routing for user profiles. The code begins by importing necessary functions from Vue Router, specifically createRouter and createWebHistory, which are essential for managing route navigation and history in a single-page application. Now let's define the routes for our application. In this example, we create a route that maps the path /user/d to a user profile component. The id parameter allows us to dynamically access different users' profiles based on the provided ID in the URL, making our application adaptable to various user profiles without needing hard-coded routes. After defining the routes, we create a router instance using createRouter, setting its history to use createWebHistory, which keeps the URL clean and free from hash symbols. Finally, we export this router instance for use throughout our application, enabling seamless navigation between different user profiles. This setup is crucial for enhancing user experience and managing states efficiently as users transition through the various profiles in our application. Now let's take a look at how we can implement Vuex for state management in our application. We start by importing the createStore function from Vuex, which will help us create a centralized store to manage state effectively. The store contains a state object where we define our data structure. In this case, we're initializing an array called users, which can hold user objects with specific properties like ID, name, and age. Next, we define the mutations section, where we can specify functions that will modify the state. Here, we have an addUser mutation that takes the current state and a user object as parameters, pushing the new user onto the users array. This allows us to reactively update the state whenever a new user is added. We also include an actions section, which allows us to define functions that can perform asynchronous operations before committing mutations. In the fetchUsers action, for example, we simulate fetching user data from an API and commit each user to the state using the addUser mutation. This structure not only keeps our state management organized, but also facilitates easier debugging and tracking of state changes in the Vue.js Devtools. Now let's implement the following configuration in our main file to enable debugging logs and enhance our development experience with Vue.js. First, we import createApp from Vue in our root component, app_vue. Next, we create an application instance by calling createApp with the app component. To activate debugging capabilities, we set app_config Devtools to true, which allows us to access Vue.js Devtools features, enabling us to inspect the component lifecycle and reactivity directly from our browser. Additionally, we enable performance monitoring by setting app_config performance to true, ensuring that we can analyze our application's rendering efficiency and detect performance bottlenecks effectively. Finally, we mount our app to the DOM element with the ID of app, which serves as the entry point for our Vue application. By executing this setup, we lay a solid foundation for utilizing Vue.js Devtools, which will help us track component behaviors, optimize performance, and streamline our debugging process throughout the development lifecycle. As you can see, utilizing Vue.js Devtools effectively can drastically improve your debugging workflow, empowering you to find and fix issues more efficiently. From real-time data manipulation to performance monitoring and Vuex integration, the tools available to you allow a comprehensive understanding of your application state and component interactions. In this lesson, we've covered how to install and navigate the Vue.js Devtools, inspect and manipulate component data, monitor events and performance, and even debug routing and state management with Vuex. Now that you've got a solid foundation on how to enhance your debugging skills using the Devtools, you can develop Vue applications with confidence knowing that you have the right tools to track down any issues. In our next lesson, we will focus on state management using Vuex to handle application-wide state effectively. So stay tuned and keep creating amazing applications with Vue.js. To create a production build of your Vue.js application, you need to execute a specific command. To optimize the application for deployment, run npm run build in your terminal. This command triggers the build process defined in your project's configuration file, which is usually set up by the Vue CLI. When you run the command, it processes your source code, ensuring it is minified and effectively bundled. The outcome of this process is a dist directory that contains all the necessary files required for your application to operate in a production environment. The optimizations, including code minification and asset bundling, greatly improve load times for users, making this step crucial for any production deployment. Once the build process is complete, the dist folder will contain essential files such as index, HTML, JavaScript files, and CSS files that enable your Vue application to function. This prepares your project for a smooth transition from development to being publicly accessible, setting the foundation for the subsequent steps in the deployment process. Next, let's discuss what's actually in this dist folder. Inside, you should see a few important files. The index.html file is fundamental because it serves as the entry point for your application. It references your JavaScript and CSS files, which are crucial parts of your app's functionality and styling. The JavaScript files contain the process code from your Vue components, while the CSS files include the styles applied to those components. This clean separation allows browsers to efficiently load only what they need. After you've built your application and are happy with the contents of the dist folder, it's time to choose a hosting service. There are many options available depending on your requirements and budget. For instance, services like Netlify, Versal, and Firebase Hosting offer easy ways to deploy static sites, which is exactly what you need for a Vue.js application. For this example, let's consider deploying your application using Netlify because it's straightforward and free for personal projects. Start by creating an account on the Netlify website if you haven't already. After setting up your account, you'll find a button labeled New Site from Git. For this tutorial, I assume you have your Vue.js project version controlled with Git, as it simplifies deployment significantly. The displayed figure titled Key Steps in Vue.js Application Deployment is a horizontal bar chart that assigns an importance score in % to 5 deployment steps. Build application 95%, configure environment 90%, choose hosting 85%, manage routing 80%, and monitor performance 75%. Reading from the y-axis, the chart makes it clear that the production build step is rated the highest at 95%, indicating that preparing an optimized build is the top priority in the deployment workflow. Configure environment is a close second at 90%, which reinforces the lesson's emphasis on correctly setting environment variables and production configurations. Choose hosting sits in the middle at 85%, demonstrating that selecting an appropriate hosting platform is important but slightly less critical than the build and environment setup. Manage routing is next at 80%, aligning with the guidance to properly handle Vue router, especially history mode, during deployment. Monitor performance is rated lowest among the 5 at 75%, suggesting that while ongoing monitoring is essential, initial deployment efforts should prioritize building and configuring the app correctly. The presence of percentage labels on each bar quantifies the gaps between steps, showing a clear ranking and supporting the takeaway that deployment focus should start with the build and environment, then address hosting and routing, followed by performance monitoring. To prepare your Vue.js application for deployment on Netlify, you need to set the build command and the publish directory. The first step in deploying your application is to create a production build that optimizes performance. This can be accomplished by running the command npm run build. This command prompts the Vue CLI to compile your source code and generate an output folder named dist. The dist directory holds the minified and bundled files required for your app to function in a production setting. Within this folder, you will find essential files such as index.html, which acts as the entry point for your application, as well as JavaScript and CSS files that enhance your app's functionality and styling. Once the build command is set, you also need to configure the publish directory to dist. This step instructs Netlify where to locate the necessary files for serving your application. With these configurations completed, Netlify will automatically execute the designated build command each time you push updates to your repository, ensuring your application stays current with the latest changes. By following these guidelines, you can successfully prepare and deploy your Vue.js app, making it accessible to users on the internet. Now let's implement the following environment variables that will allow our Vue.js application to function correctly in production. In your in-production file, you will define critical variables such as the API URL and API key. By prefixing these variable names with vueapp, Vue will automatically recognize and include them in your application during runtime. Next, we will take a closer look at how to access these variables within our application code. We can retrieve the values of our defined variables using process.env, vueapp API URL, and process.env, vueapp API key. This approach ensures that your code remains clean and free of hard-coded secrets, enhancing security. For example, while making an API call using a service like Axios, we can construct our request by inserting the API URL and API key into the URL. This dynamic approach not only makes your code more maintainable, but also allows for easy configuration changes across different environments. Remember, proper management of these environment settings is key to a successful deployment and ensures that sensitive information is handled securely. In the next step, we will add a crucial rule to our redirects file for Netlify. This rule is essential for ensuring proper functionality of our Vue.js application when utilizing Vue router in history mode. By including the directive /index HTML200, we are directing Netlify to deliver the index HTML file for any user-requested route. This configuration empowers the Vue router to oversee and manage the routing dynamics within the application. When users modify the URL directly in the browser, static hosting services like Netlify may try to retrieve a distinct file for each specific route. Without this redirect rule, users risk encountering 404 errors if they navigate to a route that isn't defined as a static file. By rerouting all traffic to index HTML, we guarantee that the Vue application starts up correctly and is capable of addressing any route, thus providing a seamless user experience. This is particularly crucial for single-page applications, SPAs, developed with Vue.js, as it allows the application to display the appropriate components based on the URL without necessitating a page reload. Now let's implement error monitoring with Sentry to enhance our Vue.js application's reliability. First, you'll need to install the Sentry SDK for Vue.js by running a simple npm command. This SDK provides the necessary tools to track errors and performance issues in your application, making it easier to identify problems that users might encounter. Next, we will initialize Sentry in the main file of your application. This step involves importing Sentry and configuring it with your app instance and a unique data source name DSN that identifies your project in Sentry. The integration of the browser tracing feature allows you to trace performance issues across your application. You will define the trace propagation targets, which are used to specify which requests should be traced. Finally, set the traces sample rate, which determines the percentage of transactions that should be captured. It's crucial to adjust this value in production environments to ensure you're balancing performance and data collection. With this setup, any unhandled exceptions within your app will be automatically reported to Sentry's dashboard, empowering you to monitor and resolve issues effectively and maintain a seamless user experience. Finally, let's cover best practices for maintaining your deployed Vue.js app. Regular updates and maintenance are crucial to keeping your application secure and performant. As a developer, you'll need to keep an eye on dependencies and update them regularly to protect against vulnerabilities. Tools like npm audit can help identify potential security issues in your dependencies. Moreover, a thoughtful deployment strategy can enhance your app significantly. Consider using continuous integration and continuous deployment, CI/CD systems like GitHub Actions or Travis CI. CI/CD allows you to automate the testing and deployment process, making it easier to push updates while ensuring your code remains stable with each deployment. Combining all these aspects, production builds, environment variables, routing handling, performance monitoring, and regular maintenance, will set you on the path toward a successful Vue.js deployment process. In conclusion, we've covered a lot today regarding deploying Vue.js applications. From building your project, choosing a hosting solution like Netlify, configuring environment variables, handling routing, and monitoring performance, I hope you've gained valuable insights for your deployment journey. Each of these steps is crucial for making your application live and ensuring it provides a seamless experience for users. As we wrap up this lesson, remember that deployment is not the endpoint of your development journey, but rather the beginning of endless possibilities to grow and maintain your application. In our next lesson, we will delve into state management using Vuex to handle application-wide state effectively. Until then, keep building and deploying amazing Vue.js applications. In this lesson, we will cover best practices for Vue.js development, ensuring that your applications are robust and maintainable. Our journey into Vue.js continues to build on the foundation we've laid, enhancing your skills and code quality as we dive deeper into this popular JavaScript framework. So far, we learned about the deployment of Vue.js applications, emphasizing the importance of creating a production build and configuring hosting services like Netlify. We explored environment variables for customizable application behavior during deployment, routing considerations with Vue Router, and performance monitoring practices using tools like Google Analytics and Sentry. Additionally, we discussed best practices for maintaining deployed applications, including regular updates and implementing CI/CD systems. Now we will talk about best practices for developing Vue.js applications themselves. Now let's take a look at the typical structure of a Vue.js project, which is vital for maintaining organization and clarity as your application grows. A standard Vue project should include a /src directory, which is the heart of your application, housing essential elements like components and views. Inside the /src folder, we typically see several subdirectories. The assets folder is allocated for static files, such as images and CSS styles. Moving on, the components directory is where you can store reusable Vue components, promoting modularity and reusability across your application. The views folder will contain various application views that represent distinct parts of your application. Next, the router folder is dedicated to routing logic managed by Vue Router, ensuring that your application can navigate between different views seamlessly. Finally, the store directory is used for Vuex state management, allowing you to manage the central state of your application effectively. This layout not only improves code readability, but also fosters a collaborative development environment, paving the way for scalable and maintainable applications. The displayed horizontal bar chart titled Best Practices for Vue.js Development maps 10 key concepts along the vertical axis to an importance level from 1 to 10 on the horizontal axis, with numeric data labels shown at the end of each bar. The highest rated item is project structure with a value of 10, indicating it should be the primary focus when organizing a Vue application. Asynchronous data fetching follows closely with a 9, emphasizing the strong priority of handling API calls and lifecycle-driven data loading correctly. Several practices share an importance level of 8, namely single file components, consistent code style, and testing, which highlights that component encapsulation, uniform coding standards, and verification through tests are equally critical for quality and maintainability. Vue CLI usage, lazy loading, and documentation receive mid-range scores 7, 7, and 5 respectively, suggesting that while scaffolding tools and performance optimizations via lazy loading are important, documentation is a lower but still needed priority relative to structural and runtime concerns. Prop types implementation and state management Vuex score 6 each, indicating that prop validation and centralized state are valuable but may be considered secondary to establishing a solid project layout and reliable data handling. From these values we conclude a clear hierarchy: prioritize architectural decisions, project structure, and robust data fetching patterns, then enforce component patterns, style consistency, and testing, while integrating tooling, lazy loading, state management, and documentation as complementary practices that support long-term maintainability. Now let's see how we can implement a simple counter component using a single file component SFC structure in Vue. This component demonstrates the encapsulation of template, script, and style within a single file, which makes it easier to manage. First, we define the HTML structure in the template section, where we create a div that displays the current count and includes a button for increments. The interpolation syntax, count, allows us to dynamically show the count value. Next, within the script section, we set up our Vue component logic. Here we declare a data property called count, which is initialized to 0, and define a method named increment that increases the count by 1 whenever the button is clicked. Finally, let's look at the styles section, which allows us to specify styles that only apply to this component by utilizing the scoped attribute. This ensures that the styles for our header and button won't interfere with other components. With this component, we illustrate how SFCs effectively enhance modularity and reusability in Vue applications, providing a clean and organized approach to component development. Now let's implement a powerful tool for our Vue.js projects, the Vue CLI. To begin using Vue CLI, we first need to install it globally on our machine, which allows us to access its features from any terminal. This simple command will set up Vue CLI, enabling you to scaffold robust Vue applications with all the necessary configurations out of the box. Once installed, we can easily create a new Vue project. By running a specific command, we initiate the project creation process. This process is user-friendly. You'll be prompted to select various features like TypeScript support, Vue Router, and Vuex during the setup. These options ensure that your project adheres to best practices right from its inception, laying a solid foundation for future development. Utilizing Vue CLI not only saves time, but also enhances the overall structure of your application by ensuring that essential scaffolding components are included from the start, streamlining your development experience and maintaining a high standard for your code. Now let's take a look at how to define props with specific data types in a Vue component. In this example, we use the props option to specify that our component should receive a prop named message. This prop is defined to be of type string and is marked as required, ensuring that any instance of the component must provide a message value. Otherwise, Vue will warn developers about the missing prop. By enforcing prop types through this structure, we make it clear what type of data the component expects. This practice helps prevent runtime errors caused by incorrect data types and improves the maintainability of the code. The centralized definition and validation of props make it easier for developers to understand how components interact with one another, promoting clearer communication throughout the codebase. This method of using props not only enhances the predictability of the component's behavior, but also aligns with best practices for robust component design in Vue.js development. As we continue, you'll see how cultivating such practices leads to improved application quality and collaboration within development teams. Next, we will implement a Vue.js component that effectively handles asynchronous data fetching using the mounted lifecycle hook. This approach ensures that our data is fetched as soon as the component is mounted, optimizing user experience. In this example, we define a template that presents a header and displays the fetched user data within a pre-tag for easy readability. The component's data property initializes user data to null, establishing a placeholder for the incoming data. Now let's take a look at the mounted method. This asynchronous function makes an API call to fetch user data from a specified endpoint using the fetch API. The use of async await syntax simplifies our code, making it more readable by allowing us to write asynchronous code that looks synchronous. We also incorporate error handling with a try-catch block. If the API call fails, the error will be caught, and an informative message will be logged to the console, aiding in debugging efforts. This practice enhances the robustness of the component, ensuring that any issues during the data fetching process are clearly communicated without crashing the application. Now let's take a look at our EaseLint configuration, which is essential for maintaining code quality in our Vue project. This configuration file, eslintrc.js, defines the environment settings, specifying that our code will run in both browser and Node.js environments. By extending recommended rules from Vue and general EaseLint, we ensure that our code adheres to common best practices. Next, we will implement specific rules to catch potential issues. The Vue/no unused vars rule warns us of any variables that are declared but not used within our components. This practice helps eliminate unnecessary code, leading to cleaner and more efficient scripts. Similarly, the Vue/require v4 key rule reminds us to include a unique key attribute when using v4 loops, which is crucial for helping Vue efficiently update elements in the DOM. By adhering to these rules, not only do we enhance the readability of our code, but we also facilitate smoother collaborations, making it easier for teammates to understand and maintain our project over time. Now let's implement a Vuex store to manage our application state effectively. The first step is to import Vue and Vuex, and then we enable Vuex by calling Vue use Vuex. This sets the groundwork for using Vuex within our Vue application. Next, we create a new Vuex store instance, which will hold our centralized state. In this store, we define a state object that contains our initial application state, which includes a property called count, initialized to 0. This count state represents a simple counter we will manipulate. Moving on, we establish a mutations section, which contains methods for modifying the state. Here, we define an increment mutation that will increase the value of count by 1 whenever it is called. Additionally, we create an actions section, where we include an increment async action. This action demonstrates how to handle asynchronous operations in Vuex. It uses setTimeout to delay the invocation of the increment mutation by 1 second, showcasing how Vuex can effectively manage state changes over time. This structure not only centralizes the state management, but also provides a clear flow of data, making it easier for debugging and maintenance. Now let's see how we can implement lazy loading of components in a Vue application using Vue Router. In the code, we define a route for the user profile by assigning it to a variable called userProfile, utilizing a dynamic import syntax. This means that when a user navigates to the specified path, the userProfile Vue component will be loaded only at that moment, rather than during the initial application load. This approach significantly enhances performance by reducing the initial bundle size, leading to faster load times for users. Roots array then holds an object that describes the path /user/d, where id is a dynamic segment. This allows us to create a route that can display different user profiles based on the unique user ID passed in the URL. By lazily loading the component, your application remains responsive, improving the overall user experience. This method exemplifies one of the best practices we discussed, focusing on performance and efficiency in your Vue.js applications. Next, we will write a simple test case for our counter component using the Vue test utils library, which helps ensure our component behaves as expected. In this test, we first import the necessary functions and the component we want to test. We then define a test suite using describe, which groups our test cases. Within this suite, we use the it function to create an individual test, labeled as increments count when button is clicked. Here, we mount the counter component with shallow mount, which creates a lightweight instance for testing without rendering child components. Initially, we assert that the text displayed by the component contains counter 0, validating its initial state. Next, we simulate a button click using the trigger method, which allows us to check how the component updates in response to user interaction. After the click, we assert that the updated text now contains counter 1. This confirms that clicking the button successfully increments the count, demonstrating the component's functionality. Regularly testing your components like this fosters confidence in your application's stability and helps catch bugs early in the development process. Now let's take a look at a crucial aspect of Vuex state management, implementing asynchronous actions. In our example, we define an action called incrementasync, which is responsible for incrementing a count value in the Vuex store after a delay. This demonstrates how to handle asynchronous operations within the Vuex framework efficiently. The action accepts the commit method as an argument, allowing us to commit mutations to update the state. Inside incrementasync, we utilize setTimeout to create a delay of 1 second before executing the commit to the mutation named increment. This approach mimics scenarios where we might need to wait for data from an API or perform other asynchronous tasks before updating the application state. By structuring our code like this, we enhance the user experience by ensuring that state changes are done in a controlled manner, making it easier to manage side effects and maintain a predictable state flow throughout our application. This pattern is essential for keeping your Vue.js applications responsive and organized. In conclusion, adopting best practices for Vue.js development promotes a cleaner, more efficient, and maintainable codebase. We've discussed the importance of project structure, utilizing single-file components, leveraging Vue CLI, and enforcing prop types. Additionally, we explored effective data fetching, maintaining consistency with style guides, managing state with Vuex, implementing lazy loading, prioritizing testing, and the value of documentation. Embracing these practices will not only help you write high-quality Vue.js applications, but also ensure a better collaborative environment if you're working in a team. Remember that the goal is to create applications that are not only functional, but also easy to understand and maintain. Now let's keep building on this knowledge as we delve into state management using Vuex in our next section. In this lesson, we're going to explore the tools within the Vue.js ecosystem that can enhance your development experience. We'll specifically focus on the online development playground known as Vue SFC, Single File Component, and compare it with StackBlitz, a powerful platform that enables you to create fully functional development environments directly in your browser. So far, we learned about best practices for Vue.js development, focusing on the significance of project structure, single-file components, and utilizing Vue CLI for efficient project setup. We've also emphasized the importance of effective data fetching, consistency through style guides, and state management with Vuex. Additionally, we've covered the value of implementing lazy loading, testing, and documentation to enhance code quality and maintainability. As we continue, we'll dive deeper into the tools that can help you develop and prototype your applications effectively. The figure titled Key Tools in the Vue.js ecosystem presents a horizontal bar chart where each bar corresponds to a development tool and its assigned importance level on a 1:10 scale. The y-axis lists the tools in descending order of prominence as displayed: Vue SFC, StackBlitz, Vue CLI, Vuex, Vue Router, testing libraries, API integration, Bootstrap, and Tailwind CSS. The x-axis shows the numeric importance scale with grid lines to aid comparison. Each bar's length visually represents its importance, and numeric labels are placed at the end of each bar showing exact values. Vue SFC at 9, StackBlitz and Vuex at 8, Vue CLI and Vue Router at 7, testing libraries at 6, API integration and Bootstrap at 5, and Tailwind CSS at 4. From this layout we can draw clear conclusions. Single-file components, Vue SFC, are depicted as the most critical element, followed closely by an interactive browser environment, StackBlitz, and state management, Vuex. Core tooling for project scaffolding and routing, Vue CLI and Vue Router, are shown as moderately high priorities. Testing appears as an important, though slightly lower, priority, while API integration and Bootstrap occupy a middle tier and Tailwind CSS is represented as the least emphasized among the listed items. Overall, the chart reinforces prioritizing mastery of SFC patterns, browser-based prototyping, and state management early in your learning path, while treating CSS frameworks as valuable but secondary additions to develop after core Vue concepts are understood. Now let's see how we can implement a simple counter component in our Vue application. We begin by defining a template structure within HTML tags. Here we have a div that contains an h1 tag displaying the current count value, which is dynamically updated by Vue's data binding syntax using count. The button element is set to trigger the increment method when clicked, providing interactivity to our component. Next, we move on to the script section of the single file component. Here, we export a default object that sets up the component's logic. We use the data function to return an object containing our state, which includes a count property initialized to 0. This will serve as our counter variable. To handle the incrementing functionality, we define a method called increment. This method simply increases the value of count by 1 each time the button is clicked. By updating the count property, Vue automatically re-renders the relevant parts of the DOM that rely on this value. Finally, we add some scoped styles to ensure that the heading color is blue and that the button has appropriate padding and font size, enhancing the visual presentation of our component. Now let's see how we can implement the to-do functionality in our Vue application. In the template section, we define the structure, including a heading for the to-do list, an input element bound to the new task data property, and an unordered list to display the tasks. The vModel directive creates a two-way data binding, allowing users to input tasks seamlessly. Additionally, we listen for the keyup, enter event to trigger the add task method, enabling quick task entry simply by pressing enter. Next, we will write the script section where we define the data properties of our component. Here we declare new task, an empty string for user input, tasks, an empty array to hold the list of tasks, and nextId, initialized to 1, which will assign unique identifiers to each task. In the methods object, we implement the add task method. This method checks if new task contains valid input. If it does, it pushes a new task object containing a unique id and the task text into the tasks array. Finally, it resets new task to an empty string, allowing for another entry. This approach not only enhances user interactivity, but also lays a foundation for managing dynamic lists in Vue applications. Now let's see how we can integrate Vue Router into our StackBlitz project for effective routing. First, we need to install Vue Router using npm, allowing us to manage navigation between different components in our application. Next, we will import the necessary libraries in our main.js. Here we import Vue, our root app component, and Vue Router itself. Additionally, we import the home and about components, which we will define routes for later. After setting up our environment, we make sure to configure Vue to avoid displaying production tips, which is particularly useful during development. Now let's create an array named routes that specifies the paths and the corresponding components to render. This array will facilitate the navigation throughout our application, as we define a base path for the home component and a secondary path for the about component. With our routes established, we then create an instance of Vue Router, passing in our defined routes. Finally, we initiate a new Vue instance, associating it with the router and rendering the main app component. This setup lays the groundwork for seamless navigation, allowing users to transition between the home and about views effortlessly in our application. Another phenomenal aspect of StackBlitz is its live reloading capability. As you make changes to your code, you won't need to hit refresh. Your application updates automatically, giving you the effect of a fluid development experience that's often reserved for local environments. This enhances productivity and provides a seamless pathway from coding to testing. Plus, you don't have to worry about local configurations, file systems, or setting up development servers. Everything runs comfortably in the cloud, which means you can develop anywhere there's an internet connection. Now let's see how we can enhance our to-do application by integrating Bootstrap for styling. First, we will install Bootstrap using npm, which adds the framework to our project dependencies and allows us to utilize its predefined styles. After installation, we need to import Bootstrap's CSS file in our main.js. This step is crucial as it applies Bootstrap's styling rules globally throughout our application, enabling us to leverage its responsive design features effortlessly. Now let's implement the application's layout using Bootstrap classes. In our app Vue, we will wrap our components within a container class to center the content and provide appropriate padding. We will add a header with the text center class to align the title My To-Do List centrally, making it more visually appealing. The task input field will be enhanced to form control using the form group and form control classes, giving it a polished, interactive appearance. Lastly, we will use the list group and list group item classes for the task items in our list, ensuring proper styling and spacing. This integration not only improves the aesthetics but also adheres to modern design practices, enhancing user engagement in our application. It's important to highlight that both of these tools, Vuex and StackBlitz, provide educational platforms that encourage learning and experimentation. As you work, they expose you to best practices in component design, state management, and route handling, which are crucial for real-world Vue applications. They offer a supportive environment where you can learn by doing, which is arguably one of the best ways to solidify your understanding of Vue.js. You can create and share prototypes effortlessly, giving you an added layer of collaboration with peers or mentors. If you find a piece of code that perplexes you or sparks your curiosity, simply use the sharing feature of StackBlitz to let someone else look at your code base. Together, you can troubleshoot or brainstorm enhancements. Now let's implement the following code in the mounted lifecycle hook to fetch existing tasks from an API. This method is executed after the component is created and ready, ensuring that when your application starts, it initiates a network request to retrieve data. We use the fetch function to call the API endpoint, which returns a promise. Once the response is received, we convert it to JSON format to make it usable in our Vue application. The next step involves processing the data by mapping through each task fetched from the API. Here, we're constructing a new array of task objects that align with our application's structure, specifying unique identifiers and task titles. It's important to handle any potential errors that may arise during this retrieval process, which we do by attaching a catch method to log errors in the console. This feature not only enhances the app's robustness, but also provides valuable feedback for debugging. Overall, this addition enriches your to-do application, integrating it with dynamic data and ensuring that tasks are automatically loaded and displayed upon starting the application. In conclusion, embracing Vue.js ecosystem tools like Vuex and StackBlitz elevates your development experience. They enhance your ability to design responsive applications quickly and allow for easy experimentation with features and functionalities. Whether you're just starting with Vue or looking to prototype sophisticated applications, these tools empower you. Remember that practice is essential, so dive in, create, break things, and fix them again in these environments and share your creations with the community. With the combination of these platforms, best practices we've uncovered, and a curious mindset, you'll be well on your way to becoming a skilled Vue.js developer. Make sure to explore and leverage the full capabilities of these platforms as you continue your journey. The goal is to keep pushing the envelope and discover what you can build with Vue.js. Thank you for joining me in this lesson as we uncover powerful tools in the Vue.js ecosystem. Happy coding! Let's delve into advanced Vue.js component design patterns, focusing on the powerful concept of single-file components, often abbreviated as SFCs. These components encapsulate the template, script, and styling within a single file, enhancing the organization, readability, and maintainability of your code. As we explore these design patterns, we'll solidify our understanding of how to create components that not only follow the Vue.js philosophy, but also optimize development workflows. So far, we've learned about key tools in the Vue.js ecosystem, focusing on the educational benefits of Vuex and StackBlitz for developing applications. We've emphasized best practices involving project structure, state management with Vuex, and effective data fetching while introducing responsive design options with CSS frameworks. Additionally, we explored component creation, real-time feedback during development, and seamless NPM package integration in StackBlitz. Now we will talk about advanced Vue.js component design patterns, specifically how to design, organize, and optimize your SFCs for better maintainability and performance. Now let's see how we can implement the user profile component using single file component structure. The template section showcases the layout of the user profile, encapsulating the HTML structure clearly and neatly. Within this template, we utilize Vue's data binding features, expressing the user's avatar, name, and email using the user prop passed into the component. Next, we will write the script section that leverages TypeScript for static typing. This section imports the define component helper from Vue, which helps in defining the component with its props more effectively. Here, the user prop is expected to be an object and is marked as required, ensuring that users of the user profile component provide the necessary data. Finally, we will integrate some styling in the style scoped section. This uses scoped styles to ensure that the styling applies only to this component, preventing it from affecting other components on the page. In this way, we maintain clean, modular, and reusable code that aligns with best practices in Vue.js development. The displayed chart titled Benefits of Single File Components in Vue.js maps 6 benefit categories on the x-axis: encapsulation, reusability, separation of concerns, simplicity, maintainability, and performance optimization, against an importance scale on the y-axis labeled Importance Level 110. Each bar is annotated with its numeric value. Encapsulation equals 9, reusability equals 8, separation of concerns equals 9, simplicity equals 8, maintainability equals 7, and performance optimization equals 8. Key patterns are immediately visible. Encapsulation and separation of concerns score highest at 9, indicating that SFCs most strongly deliver on isolating component internals and organizing responsibilities. Reusability, simplicity, and performance optimization cluster at 8, showing they are consistently strong advantages of SFCs. Maintainability sits slightly lower at 7, still positive but the least pronounced benefit on the chart. From these values, we can conclude that single file components provide robust separation and encapsulation by design, make components reusable and straightforward to work with while improving performance considerations, and that teams should pair SFCs with disciplined practices, modularization, testing, documentation, to fully realize maintainability gains. The overall tight range, 7-9, reflects that SFCs deliver balanced, significant benefits across multiple dimensions of component design. Now let's explore how we can implement the user profile component within our main application. In the template section, we create a simple layout where we can render multiple user profile components. Here, we pass different user objects to each user profile instance using props, demonstrating the power of reusability. The current user and another user objects in the data section provide 2 distinct sets of user information, which is critical for showcasing how the same component can adapt to various data inputs without code duplication. Next, we define the script section where we import the user profile component. By utilizing the define component function from Vue, we ensure our component adheres to the composition API principles. The data method returns a structured format containing our user objects. This flexibility exemplifies the advantages of Vue's component-based architecture. By passing different user data to the same component, we maintain clean and maintainable code while significantly reducing redundancy. This approach ultimately enhances application performance and simplifies ongoing development, key principles we strive for in advanced Vue.js applications. Now let's implement the user profile component with slot functionality to enhance its flexibility. In this component, we define the user profile layout that includes an avatar, name, and email, all sourced from a user prop passed to the component. The inclusion of slot/slot allows for custom content to be inserted within the user profile, letting users add personalized elements without altering the core design. Next, we see how we can utilize the slot feature when rendering the user profile component. By using the vslot default directive, we can pass additional markup, in this case, a button to be displayed below the email. This allows developers to customize the component further while keeping the original structure clean and focused on its primary purpose. The buttons at click event handler, defined in our script section, triggers a method to send a message to the current user, showcasing how user interactivity can be seamlessly integrated. This approach not only maintains a separation of concerns, but also promotes reusability and adaptability in our component designs. By empowering users to embed their content, we create a more dynamic and engaging interface. Now let's see how we can implement dynamic components in our Vue application. We begin by utilizing the component tag, which allows us to render components conditionally based on the user's role. In the template section, we use the is directive to dynamically bind the component to render, which is determined by the computed property control component. Within the script, we define our component using TypeScript for type safety and clarity. Here, we import the admin profile and guest profile components, which are the two different profiles we want to display based on user roles. Next, we declare control component as a computed property that evaluates the user role. If the user's role is admin, it returns the admin profile component. Otherwise, it defaults to the guest profile. This approach not only helps keep our code base clean and compliant with the dry principle, but also enhances maintainability and readability, as it clearly delineates which component corresponds to which user role without duplicating reusable code. Now let's expand our user profile component to enable integration with Vuex for state management. This code snippet demonstrates how to retrieve user data directly from the Vuex store, enhancing the component's focus on rendering and responding to user interactions. Within the template section, we conditionally render the user profile only if the user data is available, which is a best practice for handling potentially undefined variables in Vue.js. In the script section, we use Vue's define component to define our component and the use store composable from Vuex to access the store. By calling const store use store, we can interact with our Vuex state. Next, we assign the current user from the Vuex store to a local constant called user. This approach creates a clear dependency on the Vuex store, ensuring that our component pulls in the latest user data, thus simplifying state management across the application. Overall, this implementation emphasizes the importance of using Vuex as a single source of truth for application state, reducing the risk of bugs and inconsistencies while streamlining the code structure for better maintainability. Now let's implement the following computed property in our Vue component to enhance performance and manage reactivity effectively. This code snippet introduces a computed property named displayName, which is calculated based on the first name and last name properties of the user prop. By utilizing the computed function from Vue, we ensure that displayName only updates when either first name or last name changes. This efficient management of dependencies prevents unnecessary recalculations and re-renders, making our component more responsive, particularly as applications grow in size. Inside the setup function, we use props to access the user object passed to the component. The computed property concatenates the first and last names into a single string representation, effectively creating a user-friendly display name. As we return display name from the setup function, it becomes accessible within the component's template section. By strategically leveraging computed properties like this, we can significantly improve the performance of our Vue applications, ensuring a smoother user experience while reducing overhead from unnecessary updates. In conclusion, mastering advanced Vue.js component design patterns is essential for crafting sophisticated, maintainable applications. With single-file components, we gain better organization and clarity. Utilizing slots, dynamic components, and state management through Vuex can enhance flexibility and scalability. Coupling these techniques with performance optimizations ensures your applications run smoothly, providing an excellent user experience. As you move forward in your Vue.js journey, keep practicing these design patterns and experiment with your own components. The world of Vue.js is vast, and by embracing these advanced practices, you'll empower yourself to build applications that not only meet user needs but are also a joy to work on. Happy coding! Let's dive into the advanced features of Vue.js, focusing specifically on the Composition API. This feature allows us to organize and reuse code throughout our applications more effectively, resulting in modular, maintainable code. So far, we've learned about advanced Vue, JS component design patterns, particularly the benefits and structure of single file components, SFCs, which enhance organization and maintainability. We discussed the purpose of each section in an SFC and explored how to create reusable components using props and slots for added flexibility. Additionally, we covered dynamic components and the importance of state management with Vuex to streamline data handling in applications. Lastly, we emphasized the necessity of performance optimizations to create responsive and efficient Vue.js applications. Now, we will cover the Composition API, which transforms the way we develop Vue applications by promoting a more organized approach to managing state and methods. The figure shows a bar chart of adoption percentages for 5 advanced Vue.js features: single file components 90%, state management 85%, composition API 80%, performance optimization 75%, and dynamic components 70%. The clear pattern is that SFCs lead in adoption, followed closely by state management and the composition API, which together form the core practices in current Vue development. This suggests teams prioritize file organization and robust state handling, while the composition API has strong but slightly lower uptake as developers migrate from the options API. Performance optimization sits in the middle, indicating consistent attention but room for increased focus, and dynamic components show the lowest relative adoption among these advanced topics, implying they are used selectively for specific UI scenarios. From these values, we can conclude that projects should strongly consider SFCs and solid-state management as foundational choices, adopt the composition API to align with modern patterns, and treat performance tuning and dynamic component usage as important but more situational investments. The Composition API provides us with a powerful alternative to the Options API, allowing us to group related code together instead of splitting it between various component options like data, methods, and computed. This can be especially beneficial in larger components where separating concerns can lead to cluttered and hard-to-maintain code. With the Composition API, the focus is on the logic associated with a particular feature, enhancing the overall structure and making it easier for developers to reason about their code. Now let's implement a simple counter component using the Composition API in Vue. The first section of the code, wrapped in the template tag, outlines the user interface, which includes a heading displaying the current counter value and a button that triggers the increment action. Next, we define the script section where we import the ref function from Vue. This is crucial for creating a reactive reference to our counter variable, count. Inside the setup function, the core of our component's logic, we initialize count with a value of 0 using ref. This establishes a reactive variable that will automatically update the template displaying the counter. We also define an increment function that increases the value of count each time the button is clicked. This function modifies count value, ensuring that changes are reactive. Finally, we return both count and increment from the setup function, making them accessible in the template. This structure exemplifies how the Composition API allows us to organize state and logic seamlessly, creating clean and maintainable code. Now let's see how we can create a reusable composable function to manage a counter in our Vue application. We begin by defining a function called useCounter, which utilizes Vue's ref to create a reactive variable named count, initialized at 0. This reactive variable allows Vue to automatically update the UI whenever its value changes. Next, we define two methods, increment and decrement, which modify the value of count by 1, either increasing or decreasing it accordingly. These methods are returned as part of an object, along with the count variable, enabling any component that imports this composable to easily access and manipulate the counter state. Now let's implement this composable in a component to illustrate its practical use. In the component, we first import the useCounter function, then call it inside the setup function. The returned values from useCounter, specifically count, increment, and decrement, are made available for display in the template and for interaction through button clicks. This approach centralizes our counter logic within a single file, promoting better organization and reusability across multiple components while simplifying unit testing. Now let's see how we can implement lifecycle hooks using the Composition API in Vue 3. In this code example, we import ref and onMounted from Vue, which are essential for creating reactive state and utilizing lifecycle hooks. Inside the setup function, we declare a reactive reference data initialized to null. This variable will store the fetched data from an API once the component is mounted. Next, we utilize the onMounted hook to perform an asynchronous function that triggers when the component is ready. Within this function, we make a fetch request to a specified API endpoint. Upon a successful response, we convert the response to JSON format and assign it to our data variable, making it reactive. This means that any changes to data will automatically update the component's rendering. Finally, we return the data variable from the setup function, allowing it to be directly accessed within the template. By organizing our data fetching logic within the lifecycle hook, we enhance the clarity and structure of our component, tightly coupling the data management with the component's lifecycle. Now let's take a look at how we can implement error handling in our API call with Vue's composition API. In this code, we start by defining a reactive state for both our data and error messages using the ref function. This sets up the necessary variables to hold the data we fetch from the API and any potential error messages we might encounter. Next, we use the onMounted lifecycle hook to trigger our data fetching logic when the component mounts. Inside this hook, we employ a try-catch block to handle potential errors gracefully. We initiate the fetch request to our API, and if the response isn't okay, we throw an error. If all goes well, the data from the response is converted to JSON and assigned to our reactive data variable. In the event of an error, we catch it and store the error message in our error state. This allows us to conditionally render feedback to the user in the template. Thus, if an error occurs, the message will appear in the UI, enhancing the user experience while ensuring robust error handling integrated within our component's logic. This approach promotes maintainable code and a clear error management strategy. Now let's implement a reactive user object using Vue 3's composition API. We start by defining a template that displays the user's name and age, along with a button to increase the age. In the script section, we import the reactive function from Vue, which allows us to create a deeply reactive object. Within the setup function, we declare a user object initialized with a name and an age, making it reactive. This means any changes to the user object will automatically update the view without needing additional effort. Here, we define an increaseAge function that increments the age property of the user when triggered by the button click. Finally, we return the reactive user object and the increaseAge function from the setup function, thereby making them accessible to our template. This setup highlights the power of the composition API in managing state, as it simplifies how we handle user-related data and interactions in our Vue.js applications, demonstrating a clearer and more efficient approach to state management. Now let's implement the following example using TypeScript to leverage the benefits of type safety within our Vue component. The script section begins by importing the ref function from Vue, which we will use to create a reactive reference. Here, we define a reactive state variable count, initialized to 0, while explicitly specifying its type as number. This ensures that any operations performed on count are validated at compile time, helping us avoid potential runtime errors due to incorrect data types. Next, we define an increment function, which is annotated with a return type of void, indicating that it does not return any value. Inside this function, we simply increment the value of count by 1 each time the button is clicked. Importantly, because we are using TypeScript, any changes to the type or structure of our reactive variables will be caught early in the development process, enhancing the overall reliability of our code. Finally, we return both count and increment from the setup function, making them available for our template to use, thus seamlessly connecting our logic with the user interface. As we wrap up our exploration of the composition API in Vue.js, it's evident that this feature provides a robust framework for building scalable applications. By enabling better code organization, promoting composability, and enhancing reusability through composables, the composition API significantly transforms how we approach development in Vue.js. When using the composition API, remember to leverage reactive properties, lifecycle hooks, and TypeScript features to create applications that are not only maintainable but also performance optimized. The ability to compose functionalities independently and reuse them across components paves the way for cleaner, more efficient code bases. So far, we've covered the essentials of the composition API, including its core features, the use of reactive state, composable functions, and lifecycle hooks. We explored how to integrate error handling and reactive objects, along with enhancing our code with TypeScript for added safety. Now you're equipped with the knowledge to implement these advanced features in your Vue.js applications. Go forth and refactor your components with the Composition API and experience the difference in organization, reusability, and maintainability. Let's build amazing applications together. Testing Vue.js applications is crucial to ensure the integrity and functionality of your code. As developers, it's our job to deliver high-quality software that holds up to users' expectations. Today, we'll explore the best practices for testing Vue.js applications, emphasizing the importance of both unit and integration tests. So far, we learned about the advanced features of Vue.js, focusing on the Composition API, which promotes better code organization and reusability through composables. We discussed the use of reactive state, lifecycle hooks, and error handling to enhance maintainability in our applications. Additionally, we covered how to incorporate TypeScript for improved safety and structure. With this knowledge, you are now ready to implement these practices to build efficient and scalable Vue.js applications. Now let's implement the testing setup for our Vue components using Vue testutils and Jest. First, we need to install the necessary libraries to facilitate our testing process. We'll use the command line to install both Vue testutils and Jest as development dependencies, ensuring we have the right tools for testing our Vue applications. Next, we will create a simple button component that can respond to user interactions. This component includes a label prop that determines the text displayed on the button. We also define a handleClick method, which emits a custom btn_click event when the button is clicked. This setup allows us to test that our button component behaves correctly based on the props it receives and the user actions that occur. Now let's see how we can implement the tests for our button component. We will import the button component and Vue testutils into our testing file. Using shallow mount, we can mount the button component without rendering its child components, which helps keep our tests focused and efficient. We'll write two tests, one to verify that the button renders the correct label and another to simulate a click event, ensuring the btn_click event is emitted as expected. This structured approach ensures our button functions properly and meets the anticipated requirements. Now let's implement snapshot testing for our button component. The following test case uses Jest's snapshot feature to capture the rendered HTML output of our button component and store it for future comparison. By using shallow mount, we create an instance of the button component with a prop for the label set to click me. This approach allows us to focus on the button's output without rendering any deeper child components, ensuring our tests remain efficient. The key part of this test is the expect wrapper HTML to match snapshot line. This assertion checks the current rendered HTML against a previously stored snapshot. When you run this test for the first time, Jest will generate a new snapshot file that reflects the current state of the button component. In subsequent test runs, if the component's output changes, Jest will alert us by failing the test, highlighting any discrepancies. This method not only helps ensure that our component's output remains consistent over time, but it can also catch unintended changes that may occur during development, serving as an essential tool in maintaining the integrity of our UI. Now let's implement an integration test for our parent component. In this test, we begin by mounting the parent component using Vue testutils, which allows us to create a rendered instance of our component in a test environment. Next, we use the findComponent method to locate our button component within the parent component's template. This is crucial, as we need to ensure that we can interact with the button effectively. Now let's simulate a click event on the button component. By triggering this event, we can test the interaction between the button and parent components. After the click, we will check the text content of the parent component to assert that it updates correctly based on the data change initiated by the button click. Specifically, we expect the message in the parent component to reflect that the button has been clicked, confirming that our components are working together as intended. This integration test demonstrates how you can verify the expected interactions between multiple components, enhancing the reliability of your application. The displayed figure titled Importance of Best Practices for Testing Vue.js Applications is a horizontal bar chart that ranks 5 testing practices by their importance rating 0-100%, unit testing 95%, error handling 90%, integration testing 85%, snapshot testing 80%, and visual regression testing 75%. From the data shown, unit testing is the clear top priority at 95%, closely followed by error handling at 90%. This emphasizes that verifying individual component logic and ensuring graceful failure handling are the most critical tasks. Integration testing sits in the upper middle 85%, supporting the earlier point that component interactions must be validated once unit-level correctness is in place. Snapshot testing at 80% confirms its role as a useful safeguard for structural regressions, while visual regression testing at 75% is still important for UI consistency, but is quantitatively lower than functional tests in this representation. The horizontal layout with value-labeled axes and grid lines makes the relative gaps easy to read. The largest span is between unit testing and visual regression, 20 percentage points, suggesting a practical prioritization strategy. Allocate most testing effort first to unit tests and error handling, then to integration and snapshot tests, and finally to visual regression checks. Overall, the figure reinforces the lesson's guidance. Focus initial resources on unit-level coverage and robust error handling, then extend coverage to integration and visual checks to ensure both correctness and consistent user experience. Now let's discuss how to test asynchronous operations in our Vue.js components. To handle fetching data from an API, we first implement the fetchData method within our parent component. This method uses the fetch API to asynchronously retrieve data from a specified URL. It then updates the component's message state with the JSON response from the API. To effectively test this functionality, we need to simulate the asynchronous behavior by mocking the global fetch function. Next, we will write a test that ensures our fetchData method works as expected. In this test, we mock the fetch function to return a resolved promise containing test data. Once the mock is set up, we invoke the fetchData method and await its completion. After the promise resolves, we assert that the component's rendered text includes the fetched data, confirming that the method updates the message correctly. This approach enables us to verify that our components can properly handle asynchronous logic and display data fetched from an external source, ensuring their functionality aligns with user expectations. Now let's see how we can implement error handling in our fetch method. The modified fetchData method utilizes a try-catch block, which is essential for catching errors that may occur during asynchronous operations. When initiating the fetch request, we check if the response is OK, and if it isn't, we throw an error indicating a network issue. This is crucial as it allows us to handle different responses appropriately. If there's an error, whether from the fetch operation or from our explicitly thrown error, we catch it in the catch block and set the component's message to the error's message. This way, if something goes wrong during the API call, our application can respond gracefully by providing feedback to the user. Next, we will write the corresponding test case to ensure our error handling works as intended. By mocking the fetch function to return a rejected promise, we can simulate a fetch error. When we call the fetchData method in our test, we expect that the component will catch the error and update the message accordingly, demonstrating how robust error handling can enhance user experience in our Vue.js application. Next, we will write a visual regression test using Cypress to ensure our application's UI remains consistent. In this test, we begin by defining a test suite with the describe function, which groups our tests under the title Visual Regression Test. Within this suite, we define a test with the it function to specify what we are testing, in this case, ensuring that our visual snapshots match expected results. Inside the test, we use visit / to navigate to the root of our application where the main UI resides. This initializes the UI for testing. We then simulate a user interaction by clicking a button, which could trigger changes in our application's display. After the interaction, we implement match image snapshot, a function provided by a Cypress plugin designed to capture a screenshot of the current state of the UI and compare it to a baseline image stored from previous test runs. If there are any discrepancies between the screenshots, the test will fail, enabling us to identify unintended visual changes and maintain the integrity of our user interface throughout development. This approach reinforces the importance of visual consistency alongside traditional functionality tests. Now let's see how we can implement a continuous integration workflow for our Vue.js application using GitHub Actions. The configuration starts by naming the workflow Vue.js CI and specifies that it will be triggered on pushes and pull requests to the main branch. This ensures that every change made is verified by the CI process. Next, we define a job called test, which runs on the latest version of Ubuntu. The steps within this job are crucial as they outline the sequence of actions that GitHub Actions will perform. First, we check out the code from the repository, allowing the CI tool to access the latest version of our codebase. Then we set up Node.js specifying version 14, which is essential for running our Vue.js application. Subsequently, we install the necessary dependencies using npm, ensuring that all required packages are available for testing. Finally, we run the tests with a simple command. If any of these tests fail, the CI pipeline will stop the merge process, preventing any potentially problematic code from entering the main branch. This setup exemplifies how CI can enhance code quality and streamline the development process. Finally, let's highlight the importance of documentation in your testing strategy. Just as you document your functions and components, documenting your tests is vital too. This practice not only assists your team in understanding what each test does, but also helps in onboarding new developers. Add comments to explain the purpose of each test, and consider using a testing report tool to visualize the test coverage and results. In conclusion, we've covered a wealth of information today. We began with the basics of unit testing Vue.js applications, leveraging the power of Vue test utils and Jest for effective component testing. We explored integration testing to ensure components work together seamlessly, then moved on to testing asynchronous behavior and error handling in our components. Following that, we discussed the benefits of visual regression testing to maintain uniformity in our UI, the role of continuous integration in our development lifecycle, and the criticality of documentation. With these best practices in hand, you're equipped to ensure your Vue.js applications are well tested, sturdy, and ready for deployment. Now go forth and implement these testing strategies in your own projects. Let's ensure that the next Vue.js application you build is not only feature-rich but also rock-solid in terms of reliability and user experience. Happy coding! Now let's take a look at how we can efficiently filter a list of items using Vue's reactive capabilities. In the example, we define a template that includes an input field bound to a property called search query, allowing users to input their search terms. Below this input, we have an unordered list displaying items generated by iterating over a computed property called filtered items. The data function initializes the component's reactive state, including the search query and a predefined list of items. This list contains objects, each representing a fruit with its unique id and name. Here, S where the power of computed properties shines. The filtered items computed property uses the filter method to return only those items whose names include the text from the search query. This means that every time the search input updates, filtered items recalculates automatically and efficiently, ensuring that we only display relevant results without unnecessary computations on every keystroke. This approach optimizes both computation and rendering performance, showcasing how Vue's reactivity can enhance user interactions and application responsiveness. The displayed pie chart titled Impact of Performance Optimization Strategies in Vue.js Applications quantifies how 5 optimization techniques compare in relative effectiveness: efficient component lifecycle, largest slice, lazy loading, state management, using computed properties, and optimizing rendering. The chart assigns values 90, 85, 80, 75, 70, which translate to proportional shares of the whole. Efficient component lifecycle approximately 22.5%, lazy loading approximately 21.3%, state management approximately 20%, using computed properties approximately 18.8%, and optimizing rendering approximately 17.5%. Key patterns are clear. The top 3 strategies, lifecycle, lazy loading, and state management, together account for about 63.8% of the total depicted impact, indicating that efforts focused on lifecycle optimization, deferring non-essential code, and structuring state effectively will yield the largest performance gains. At the same time, the slices for computed properties and rendering optimization remain meaningful, nearly a fifth each, reinforcing that caching reactive computations and reducing render cost are important complements. The conclusion drawn from this distribution is to prioritize interventions where they give the most return, start with lifecycle and loading behavior, and then address state and computed render efficiencies to achieve a balanced, high-impact optimization plan. Now let's implement a pagination system to enhance our Vue.js application's performance when dealing with large lists. In the template, we create an unordered list that utilizes the v-for directive to display only a subset of the items known as paginated items, which will be dynamically determined based on the current page. This helps ensure that our application runs efficiently by rendering fewer items at a time. We also introduce buttons for navigating through the pages, one for previous and another for the next page. These buttons become disabled when the user is on the first or last page, preventing unnecessary clicks. In the script section, we define our data properties, including current page to track the active page and items per page, to specify how many items to show on each page. The computed properties serve critical roles here. Total pages calculates the total number of pages based on the total number of items divided by items per page, while paginated items slices the original items array to show only those within the current page's range. The methods nextPage and prevPage allow users to navigate through the pages by adjusting the current page value, ensuring a seamless and responsive user experience. Next, we will write the following code to implement a Vuex store for efficient state management within our Vue application. In this setup, we first import Vue and Vuex, then utilize Vuex by installing it into our Vue application. Inside the Vuex store, we define the initial state, which contains an array of items, each with a unique ID and name. This state serves as a centralized data source that various components can refer to. Next, we create a getter called filtered items. This getter accepts a query parameter, enabling components to filter the items based on the user's input. The method filters the items in the state by checking if the item names include the provided search query, thus returning only those items that match the search criteria. Now let's see how we can implement this within a component. We will set up a template containing an input field bound to a search query data property, allowing users to type their search terms. Using the mapGetters helper from Vuex, we can link our component's computed properties to the Vuex getter. This keeps our component logic clean and efficient, ensuring that it reacts only to relevant state changes and minimizing unnecessary computations. Now let's take a look at how we can efficiently render a list of items in Vue.js using the v-for directive. In the provided template, we use an unordered list, ol, to display items from our data. Each item is iterated over with v-for, which binds each list item, li, to the unique properties of an object in our items array. Specifically, we utilize key=item, d, to assign a unique identifier to each element, allowing Vue to maintain track of these elements effectively during updates. This practice is crucial as it optimizes rendering performance by ensuring that Vue can recognize the identity of each item, leading to smoother updates and preventing unnecessary re-renders. In this example, when the underlying data changes, Vue retains the state of each item based on its key, significantly improving the efficiency of the application. This approach not only reduces the possibility of Vue incorrectly reusing DOM elements, but also enhances user experience through faster rendering times. By ensuring each list item is uniquely identified, we lay a strong foundation for scalable and performance-oriented Vue applications. Now let's implement lazy loading to optimize our application's component loading. When we declare a component like userProfile, we use the syntax const userProfile equals import /component /userProfile Vue. This approach leverages dynamic imports, allowing the userProfile component to be loaded only when it's actually needed, rather than at initial load time. This deferred loading is particularly beneficial for routes that aren't immediately accessed, thereby significantly improving the application's initial load performance. Next, we define the routes in our router configuration. The code continues with setting up an array called routes, where we specify that for the path user id, the component to be rendered is the user profile. By organizing our routes this way, Vue Router efficiently manages component loading, ensuring that only the necessary components are instantiated when users navigate to these routes. This mirrors modern web practices and greatly enhances user experience by reducing wait times and resource usage, ultimately leading to a more responsive application. Now let's take a look at how we can set up Webpack to optimize our Vue.js application's build process. The provided configuration begins by importing the necessary modules, specifically the path module for resolving directory paths and the clean Webpack plugin for ensuring a clean output directory before each build. Next, we define the Webpack configuration object. Setting the mode to production enables built-in optimizations such as minification, which will strip out unnecessary whitespace and comments from the final output files. We specify the entry point of our application as src/main.js, where our Vue application starts. In the output section, we define the name and location of the bundled file, directing it to a dist directory. Now, let's implement the plugins section, where we instantiate the clean Webpack plugin. This ensures that previous build artifacts are removed, keeping the output folder clean. The optimization section is key to performance. Here, we configure split chunks to allow code splitting, which separates vendor code from our application code, improving load times. Finally, we set minimize to true, ensuring our output files are minimized, significantly enhancing application performance. This configuration lays the foundation for an optimized build process in Vue.js applications. Now let's implement the following code to register a service worker in our Vue.js application. This code checks if the browser supports service workers by verifying if service worker is available in the navigator object. If supported, it sets up an event listener that triggers when the window has finished loading. Inside this event listener, we call the register method on navigator service worker, providing the path to our service worker file, typically located at /serviceworker.js. Upon a successful registration, the promise resolves, logging the scope of the registered service worker to the console, which helps us confirm that it's operating correctly. If the registration fails, we catch the error and log it to the console for debugging purposes. This process effectively allows your application to utilize caching strategies, enabling offline capabilities and improving overall performance by reducing load times through efficient asset management. By intercepting requests, the service worker can serve cached content, ensuring a smoother experience for users even under limited connectivity. By implementing these performance optimization strategies, you can significantly enhance the speed, responsiveness, and overall user experience of your Vue.js applications. Optimize your component lifecycle usage, manage state efficiently with Vuex, avoid unnecessary renders through effective key usage, and leverage lazy loading for non-essential components. Don't forget to optimize your build process with Webpack and ensure your application interacts well with the browser. In conclusion, performance optimization in Vue.js is an ongoing effort that pays off with enhanced user satisfaction and application efficiency. As you embark on your development journey, keep these strategies in mind to create Vue applications that are not only functional but also perform exceptionally well. With these optimizations, you're well on your way to delivering a snappy and engaging Vue.js experience. Happy coding! In this final section, we will do a project challenge to apply what we have learned so far. This project will require you to create a real-world web application using the Vue.js framework, integrating state management with Pinia, and interacting with external APIs to enhance functionality. You have the freedom to choose from exciting project ideas like a recipe finder, fitness tracker, expense tracker, object recognition game, or a personal portfolio website. Throughout this challenge, you'll implement best practices in code structure and user experience, culminating in a deployed application that's accessible to the public. Be sure to document your project thoroughly in a README file and submit your work via GitHub, including well-commented code and a demo link. Embrace this opportunity to showcase your skills, and remember, you can find the full details of the final project in the GitHub repository linked in the description. Good luck and let your creativity shine.